Good morning, sir. So should we wait for like 2 to 3 minutes? Like it seems less people has joined, or should we start? So you can unmute yourself. Yes, sir. You are in the panelist. You can yes.
Yeah. Am I live or still to be put live?
Yes, sir. We are live.
We are live.
Should we start then?
Whenever you are ready.
Okay. A very good morning to one and all present here. Can you switch off the mic speaker? Sorry. Um, A very good morning to one and all present here, respected speakers and all the attendees of the conference. I am Sumiran Mehra. We are gathered here today for the conclave on Fabless and Fab Semiconductor ecosystem being organized by Madhya Pradesh Vigyan Sammelan, MPVS 2021. I'm delighted to take the opportunity to introduce you all Dr. Satya Gupta for the first keynote talk. Dr. Satya Gupta has been a part of worldwide semiconductor industry for more than 30 years in USA and in India. During this period, he has been involved in semiconductor product design, intelligent electronics product, semiconductor and electronic manufacturing, IP development, industry, academia, ecosystem, and government initiative in these areas. Dr. Gupta completed his bachelor's degree from BITS Pilani, MTech from IIT Delhi, and PhD from Old Dominion University, Norquay, Virginia. After a long corporate career in Intel, he has co-founded 5 successful startups, namely Intel Microelectronics, Open Silicon, Concept 2 Silicon, Sensept, and Sense Innovation. In addition to his professional career and startup activities, he is highly active in building ESDM ecosystem in India and was one of the founding members of India Electronic Semiconductor Association and has been actively involved in IESA since its inception. He is currently serving as the advisory IESA and was chairman IESA in the year 2021 and 2012-13. He is the recipient of Silver Award. He has been recipient of several awards, including IEEE Golden Bell Award for High Performance Computing, Mentor Graphics Award for Most Respected Semiconductor Professional at Open Silicon, and many more. I'm honored to invite Dr. Satya Gupta to address the audience with its thought. Welcome, sir.
Thank you so much. Thank you for your kind words and good morning and welcome to everybody. Um, Today I'll be talking more about semiconductor ecosystem, what is the current landscape and what are the strategies for moving forward and what is the road ahead for this important sectors in the Indian ecosystem, impacting economy, impacting the products, impacting the day-to-day life of every citizen. So let me share presentation. Is my slide visible?
Oh, yes, sir.
Yeah. So I think in general, this audience is pretty savvy about the overall technology field, but over the last month or so, there has been much activity about the semiconductors in terms of the discussions, policies, and so on and so forth. So in the context of this landscape, I'll just share my thoughts and views about the uh, Semiconductor India, what's the road ahead to build a basically significant ecosystem for semiconductors in India, which is becoming a very strategic asset for any country in today's geopolitical environment and uh, strategic from economic security, physical security, cyber security, all of those things depend heavily on electronics, and electronics is predominantly driven by the semiconductors. So today, if you look, electronics is no more a gadget or couple of devices, but it is becoming the heart of almost every sector of industry, every sector of society, things like education, uh, telecom, healthcare, environment, uh, agriculture, EV, autonomous vehicle, all of them are basically heavily dependent on electronics, and by corollary, electronics basically means semiconductor also. And all of these developments are being driven by technologies like IoT, 5G, AI, ML, AR, VR, uh, cloud, sensors, edge computing, development in autonomous vehicle and electrical vehicles. Um, yeah, and a lot of this was heightened when in last 1 year, uh, the shortage of the chips has severely impacted a lot of these industries. You might have heard a lot of basically news about how much money was lost by auto industry, right? Because that is in high prominence. But it's just not the auto industry. Every industry in last 1 year has been impacted by shortage of the chips. And that highlighted the strategic importance of the chips and semiconductor, that if you don't have your own domestic ecosystem to do these products, right? And these kind of the events, maybe there are different viewpoint of what caused this basically shortage of the chip, but ultimately the impact was borne by India and the other countries like India in terms of severe impact to their economy. So electronics and the semiconductors are becoming critical part of day-to-day life, as well as basically key drivers of growth in the economy, and also becoming agents of social transformation of the masses, like education delivery through electronic devices, uh, agriculture through basically sensors, precision agriculture, and so on and so forth, healthcare through telemedicine, and so on and so forth. So not just economy and growth, it is also having a significant impact on the social transformation of the masses, which are basically lives in the small towns and villages and all those things as well, right? So, uh, so if you look at the landscape today, uh, India approximately going to consume about $200 billion this year, and probably grow to about basically $400 billion of electronics products by 25-26 financial year. We produce about 90 billion of this in terms of the manufacturing of these electronic goods. Probably that's going to grow to about $250 billion. Jobs from 7 lakhs to 20 lakhs. Startups from 350 to 1,000. So pretty significant industry. And if we look at the manufacturing, although we are manufacturing a large amount of the electronics products now in India, including the mobile phones and others, but the domestic value addition in those products is very minimal, approximately 10 to 12%. And secondly, most of these products are being manufactured for the global company. There is very small percentage of these products are basically from the Indian product companies. So those are the things basically which are need to be looked at when we look at the overall ESDM stands for Electronic System Design and Manufacturing, overall ecosystem in the ESDM area. So this is showing that although the consumption and the production, so both are growing, but there is a significant gap between the production and consumption. And second is that, as I said, the domestic value addition is very minimal. Like when we do electronics product manufacturing and we don't own the product, then typically the manufacturing of the electronics products add approximately 8 to 10% value, right? The rest of the value is added by the product company which is owning the product, components, and so on and so forth. So since we don't do semiconductor components in India, increasing this value addition beyond basically 50% is difficult till we address the problem of the semiconductor components in the country, right? So now, if we look at the overall ecosystem of the electronics industry, we need to have electronics products like end products. If you take Wi-Fi routers, security cameras, education tablet, mobile phones, all of those end products have to be basically, we need to have Indian products in this category. And to make better value addition in these products, we need to have basically semiconductor products which will drive these products at the end of the day. We need to support design and R&D, which will produce the right talent, which will go to the industry and develop these products, both in the semiconductor chip area and electronics product areas. And we need to have manufacturing of these products, both wafers, through the wafers, the packaged chips, and then going to electronics, and addressing the value addition question which is looming large in front of us, that how do we go from 10 to 12% value addition to 40 to 50% value addition. So create a balanced ecosystem, we need to focus on all the four aspects of our ESDM industry. Now, if we take a current assessment of a complete end-to-end food chain in the electronics area, so obviously the driver for any industrial product is the market demand. So India economy is growing very fast. The aspiration of the large population is growing fast. So market demand is very healthy. Market demand gets fulfilled by the electronics products, things like mobile phone, tablet, Wi-Fi router, security cameras, and so on and so forth. Okay. These electronics products get basically manufactured by electronics manufacturing companies, the likes of the Foxconn as a global company and people like Dixon as Indian companies. Okay. These basically products get driven by embedded software, which basically hardware design gets driven by the embedded software, and the hardware design basically get driven by semiconductor products, which basically ultimately do semiconductor design, and at the heart of it is the semiconductor manufacturing. So if you look at today's situation, very healthy market demand, India is very good at embedded software, India is very good at semiconductor design. Okay. Over last 5 years or so, we have done very well in the electronics manufacturing, and it is becoming more and more. And like electronics product design as a service is also basically growing pretty well. But two or three critical areas where India needs to focus and we are not doing well is the Indian electronics products. Like I said, is the mobile phone, Wi-Fi router, security camera, and so on and so forth. Most of these products today are the global products which are manufactured in India, but there is very small percentage which are the Indian products in this segment, right? Second is semicon products, which are basically the chips which go into these products. Although India is very well basically positioned in terms of the designing of semiconductor chips for the global market by the global company, but there are hardly any significant semiconductor products which are coming out of the Indian companies, right? So whether it's a startup or mid-sized companies, there are only handful of the companies which do a small percentage of this semiconductor products. Probably cumulatively we will have about $50 million revenue in the semiconductor products coming out of India. And third is that semicon manufacturing, both wafer manufacturing and packaging and test facilities. We don't have any such commercial facilities right now. And in today's economy, this is becoming a strategic asset. As I said before, the chip shortage and all of those things get impacted by your capability for manufacturing these products, which are designed by either domestic companies or global companies. Having this manufacturing capability and advanced technology knowledge is becoming very essential for any significant country to have a say in the growth of the country. So looking at this, if we have to address the India semiconductor positioning in the world, we need to work on a very comprehensive plan, and that's what I have talked in my earlier discussions in this forum as well as other forums. To have a balanced system, we have to focus on the research, we have to focus on the products, and we have to focus on the manufacturing, as I discussed in the previous thing. The manufacturing means basically wafer fabs, display fab, analog fab, memory fabs, all of those things. ATMP is basically once the wafers are manufactured, then you have to package them and test them so that it can go to the electronics product guys, which can put them onto their PCBs and basically realize this thing. The products are typically semiconductor chips. You might have a processor which drives the mobile phone and tablet type of the products, or you might have a controller which kind of heart of utility meter, a Wi-Fi chip which is driving your Wi-Fi, memory chips, and so on and so forth. Right? And this has to be supported by research and manpower development, which will produce the right talent to go into both products and manufacturing, as well as create technologies which can be long-term beneficial for the country. Now, to achieve this, we certainly need skilled manpower, infrastructure, enabling policies, raw material, equipment, supply chain, and government support. That's what we have been talking. So, as we reach towards the end of the year and festive season, Government of India decided to take a very comprehensive view of the current situations and the need of the country. And as of 15th December, they had announced a very comprehensive semiconductor policy, with the 76,000 crore investment from the government side, which will be given as an incentive to various segments of the ecosystem, which is design, manufacturing, and packaging. And as I said, skilling and research will be also part of it. Uh, so I have personally worked with basically various government initiative in last 15 years, and this is the first time, in my opinion, that the very comprehensive policy covering all the angles of the semiconductor design, manufacturing, packaging, all of this has been packaged very nicely into a single policy. Earlier policies were also good, but they were piecemeal. Like there will be one policy for fab, one for packaging, one for design, and so on and so forth. So to as these design, manufacturing, packaging, they are very interlinked to each other. So make a very cohesive ecosystem. To make a very cohesive ecosystem, we need to address all different aspects. So Government of India, under the leadership of Modi ji and our new IT Minister Ashwini Vaishnav and Rajiv Chandrasekhar, has put together in last 3-4 months a policy which will create an outlay of $10 billion. Bulk of it will go to the manufacturing, but as that is a very expensive activity, but good coverage to packaging and design and R&D also has been taken into account for this policy. And we feel that this is the right way to move forward to create a 360-degree ecosystem for semiconductors in India, and also put India on the map for basic map for these technologies across the world. Now, as I showed this basically chart before, the two important things which were in the red before, that has been kind of focused and addressed into this policy. One is semiconductor products like fabless chips and ICs, and second is fabless semiconductor manufacturing, including fab and ATM. So by and by, slowly the initiatives from the government and development of industry, we are seeing less and less red in this circle, which is very good news for all the professionals, industry, government, state government, central government. Hopefully next 5 years, we will have all of these circles in green. Excuse me, in the green. And we see that I think there is a right thinking and right consultative approach in the government to make sure that we march towards basically addressing all the areas where the weakness is there. Now, the government job to come with the incentive policies, but make use of policies and incentive and convert them into real benefits to the industry and the ecosystem. There is a lot of work needs to be done after the policies are announced. So one of the key element of the policy was setting up a India semiconductor mission. So that's the team I'm referring to here. So as we move along in the next couple of weeks to month, while we set up the government set up the India semiconductor mission, it's imperative that we choose the right people with the right experience and right expertise to drive India semiconductor mission. And as in the semiconductor manufacturing, since that ecosystem does not exist in India, we don't have too many experts in India. So the team which needs to be put up for making this policy successful has to involve the eminent domestic and the global Indians from the industry, because this is more of a commercial activity. Obviously, we need to have people from the government and other, but industry professionals who have the global knowledge of this sector, as well as they have the global connections, so that they can get the right players to basically participate into this journey in terms of their investment, technology bringing to India, and so on and so forth. So it's very important we have the right set of the people who have the global stature, global connects, global network, and the global knowledge of this sector. Another thing in the past, whenever we have talked about semiconductor manufacturing in the country, right? And consulted a lot of the global people, they always used to say that India does not have the right infrastructure in terms of putting these complex manufacturing facilities, right? So, what does it mean in real terms? A semiconductor manufacturing facility requires a large quantity of clean water. It requires a quality and uninterrupted power. It needs basically chemicals and gases which go into the manufacturing process. For it being environmentally safe, it needs to have basically good effluent treatment facilities. It needs to have the equipment suppliers and their servicing nearby. So whenever basically something goes bad, the plant gets up and running soon. And it needs to have good global connectivity in terms of the air and sea and road, so that whole thing. And one of the critical factor which uh, global people are a little bit sensitive about is ease of doing business. So if all of this could be built into, let's call a semiconductor park ahead of time, probably about 500 acres with an investment of $500 million, with all the things which we talk, plus things like local custom clearance, that if your goods are coming from outside or you're sending them out of the country, they can be cleared at the locally at the semiconductor park itself. And all the other clearances which are required to set up your factory in the semiconductor part, if those can be facilitated at the park itself, I think the global investors and the global players in this field will find that to be very welcoming environment for them to come and set up this policy, make use of this policy. And as a lot of this falls into the sphere of state governments can play a big role. While government is putting $10 billion, if we can set up one or two such semiconductor park in the country, there is no need to basically put 10 such plants, right? And the state which can take the progressive action to set up this infrastructure ahead of people putting their plant and making the investment, I think that will basically make the policy implementation fast and also productive, because then you will get a lot of global people interested in putting up the facilities in India. So since and MP can play a critical role here, as this is very basically approachable from all parts of the India and has all the right basically ingredients to put up something like this thing. So working with the central government, if they can conceive putting a semiconductor park at a reasonable location, Indore, Bhopal, somewhere, with these kind of the facilities, overall infrastructure and investment, that can go a long way in bringing some of this investment, because when government announced $10 billion incentive, that should trigger around $30 billion of investment and $100 billion of ROI. So generally, 3 to 4x of the incentive should come as a investment, and the impact of it should be basically about 10x of whatever government invest in next 7 to 10 years. So some of the things which are already beginning to happen in the ecosystem, if you see, Tata has set up a new unit called Tata Electronics, which is getting into electronics and semiconductor manufacturing, especially in the packaging and test side. Ola is starting a mega factory for electrical vehicles, which will be basically catalyst in using the electronics and semiconductor. Reliance is almost there to launch a smartphone in collaboration with Google. And Vedanta is basically planning a display fab. So I think we are in pretty good situation with respect to basically putting our foot forward in terms of providing the right enabling incentives from the government. The central government has done its job. Now, state governments also can look at overall ability to attract this investment, and they can put the additional incentive, infrastructure, and all of those things to attract some of these things in their state. And I think that's a kind of a message to the leadership, political and technical leadership of the state, that how do we put together a right incentive and infrastructure enablement, so some of these investment can come to the state. So I think I would like to conclude at this point of the time. Thank you all for listening, and greetings for festival season, New Year's, and happy semiconductor days ahead of us.
Yeah.
So if there are any questions or the moderator wants some clarification about the overall what I presented, welcome to take for next 10 minutes or so, any questions and answers. Thank you so much for giving me the opportunity.
Thank you so much, sir. That was indeed a very informative session. Is there any question? Participants can add the questions in the chat box. Okay, it seems the things are all clear to students.
So thank you so much. We all want you to learn the art of the chip design and semiconductor and join some of these exciting things which are happening in the country as soon as possible. So looking forward to interacting both with the students and also people in the MP government to see how some of these activities can take shape in state of Madhya Pradesh. Thank you so much.
Thank you so much, sir. We are also willing to join somewhere to serve the nation for the good. Also, due to some unavoidable circumstances, Dr. Nishit Gupta can't able to join the session. So we'll be like taking a short break and we'll be joining again at 11:30. Like there are a few keynote sessions and invited talks coming up. So I'll request all the audience to join again at 11:30. Thank you. Thank you, sir.
Thank you. Thank you, everybody.
Hi, this is Naveen. Can you hear me?
Hello? Yes, sir, we can hear you.
Okay.
Hello. Good morning, sir.
Hey, good morning.
We'll be starting at 11:30.
Sure. I'll just try to share my slide and validate, and then I'm all set. Something wrong with my WebEx. I'll just log out and log in again. Okay, give me a second. Can you see the slides that I'm sharing?
Yes, sir, now it's visible.
Okay, fine.
Good morning, everyone. Welcome back to the conference on Fabless and Fab Semiconductor Ecosystem. Continuing the keynote talk, I'm glad to invite Mr. Naveen Bishnoi. Mr. Bishnoi is Senior Director ASIC Design at Marvel Semiconductor India and lead custom ASIC design for infrastructure domain. Prior to this, he has worked with IBM, Global Foundries, Freescale, Cadence, and TI for automotive, consumer, and custom ASIC design. He received his bachelor degree in electronics and communication from NIT Surtalla in 1998. He is the founding member of ITC India to drive the growth of DFT test in India's semiconductor ecosystem, serve as general chair of ITC India from the last 5 years. I'd like to request Mr. Bisnoi to deliver his talk. Yes.
Thank you. Is my voice clear?
Yes.
Okay. And can you see the slides properly?
Yeah.
Okay. Thank you so much. Good morning, everyone. Pleasure to be here, especially when an event is happening in MP. I'm born and brought up in MP. It was Bhilai, which has become Chhattisgarh, but have my roots and connection to MP for a long time. And when I started my career, all of us had to come all the way to Bangalore for most of the semiconductor and other work. But it's glad to see that now within MP, Indore, Bhopal, around, there are so much ecosystem coming up. And I'm here to share some of my experience and vision that many of us have been seeing. I've been to IIT Indore a couple of times. The first time when I think it was one of the first industry conclave when it happened around 10 years back. And then a few years back when VU hosted the VDAT conference. I know it's virtual, but I'll try to go through a set of slides and keep some time for questions as well for all of you. So what I thought, we are talking about the Fabless and Fab semiconductor ecosystem, and I'll connect a decade-based story, right? So let's get started. Let's first start with saying, finally, whatever we are doing is for an end product, right? That product, and then if you look at any products that we use in our day-to-day use, any product is ready and on the shelf. And then we look at saying like, how long will it be serviceable or useful for the end customer, right? And then you can see something is an hour, a week, a month, and then you start seeing some of the instruments and equipments and other things that starts coming in, which goes and lives for years, decades, 50 years, and then maybe close to 80 to 100 plus years, right? The place where we are in is in the electronics. And if we focus on there are three components. Primarily to start with, the base component is an IP. Anything that we can repeatedly use many times across multiple electronic products, we tend to use that word called IP for that. So that's something which gets created and gets used very often. Using those IPs, then you build the SoCs or the chips that we call. The lifetime for those chips varies from 2 years to 10 years, depending on which use case you are using. And then these are built on a fabrication technology node. And those fab nodes are usually relevant for 10 years. Some of them live longer for a specific segment, but generally you will see that every 10 years or so, these node changes. So in general, if you see in our domain, every decade brings in a huge change in terms of technology, the kind of IPs, the kind of products that we built in. And that's the decade story that I'm trying to build in, right? Now, if we go back to 60 or 70 years since we have started doing electronics and semiconductor and divide that into the decade story that I was talking about. We started with centralized computing. That was long back. We moved into personal computers. From there, the networking came in, the internet coming up, the wireless technology, the mobile became this thing, connect anywhere. And then finally, we are going into saying not just connect anywhere, everything and anything and everything is a smart or electronic device there. If you look at this, the trend that has gone through, originally when the first computing and other came up, there was like one computer and maybe hundreds or thousands of users. And as we moved, it became one computer for one user. slowly became up to maybe 5 to 10 computers or smart devices or electronics for a user. And we are moving into a domain where each user will have maybe hundreds or thousands computers or electronics around them, right? That is what we are seeing. So every decade has evolved, and then it has evolved in terms of connectivity, and now it is evolving around the intelligence of it, right? How has this happened, right? And if we see just a quick peek into last decade, you would have seen this picture in different format. From if you go and do a web search, you'll find it what happens in a minute, and there are different statistics saying how much data, users, the gigabytes, the terabytes, the seconds, and all of that, right? A lot of statistics about what happens in a minute in the world. But what is happening is that what was a computer which was in an office space has moved into not just office, but into our home, into our factories, into our roads, and into the smart cities, right? We started with flying objects, which used to be a transport mechanism for us, but we have started moving towards using some of these flying objects for not just transportation, but now into the agriculture. And I mean, sometimes I'm worried it is starting getting into the war zone as well. It has helped us to remain healthy, getting into the medical world where we have built equipments or instruments or devices that can be put as part of the body. And then one more thing which have been driving a lot of change or is becoming very common is the whole automotive, the smart roads, and connecting to the smart city, right? This has been the last decade which is driving some of these semiconductor, and I'll connect it to the Fabless and the Fab story in short time. So I talked about it. It's always about connectivity, and it's always about intelligence now, all right? Uh, when we looked at all of these things, there is computation processing, there is storage that is required, there's a network that connects and talk to each other, and then there's a lot of sensors and then smart things which does the things, right? That's the connected intelligence that we are talking about. What does this mean in terms of, what are the requirements when you go and make an SoC? The computation needs the processing power, the predictability, and all of that. The storage is started looking at is where the storage would be, whether it is near the processor or near the sensor. There's networks connecting within the data center to data center, system to system, and a lot of, what we call as a sensor. Finally, all of this has to connect an end to end and then create an orchestra, right? Around different use cases, whether it is a client or a consumer like you and me who is using these things, the networks that get involved by some of the enterprise companies, and then finally, which uses the data center for computing, storage, and many other things. That's the end-to-end story which we are trying to build, right? How does this happen? What are the technologies required for these things to happen? Is you have multiple technologies you will hear about. There is a FinFET technology, the FDSOI, the amount of packaging innovation that's happening. We are trying to play with different memories and an analog and all of that, right? One thing you will realize is that one technology doesn't fit all, right? The architecture partitioning plays and there's a lot of choice, and you have to make that choice based on the merits, alignment with requirements, and finally what you want to serve to the end market. With this as the ecosystem or the driver for all the work that we do in a fabless ecosystem, how do we keep the pace of innovation, right? When we look at this, there is requirement about more density. Can we pack more memories, more storage? Can we do more performance? Can we do better power management, more bandwidth, and all of that, right? How has this pace of innovation kept by the electronics industry? One such thing was Moore's law. You can see this is a picture that Intel has published when Moore's actually forecasted, saying they looked at each technology node and then saw how many components can be fit into a chip, and then extrapolated that, saying like it will double, every this whenever we introduce the next technology node, and then we'll go from that. This Moore's law drove the innovation for a long time, right? We shifted nodes from different technology to lower node to lower node. What that meant was that we could we could make dense components. We can actually convert the existing IPs or logics and functionality into smaller area size, and then that means you can multiply those IPs. So you can have more throughput. You can add new IPs so you can have more functionalities or features that is there. You can reduce the size, make it smaller and have a lower cost. You can make it more power efficient, and then finally play with the different range of the device parameters to saying like, when it is idle, how it is more efficient for power, but when it is running at full throttle, how can it run faster, right? So that was the one innovation, along with lot of device innovation and an EDA innovation and an architecture learnings that we got, and drove some of the things that I talked about. What started happening now recently, you'll see, is that over time we started fitting more discrete into a single SoC. But what's coming in now is that we are saying like, we'll connect a lot of different SoCs, which could be built on different nodes and have a so-called as a multi-chip module or a three-dimensional packaging and all of that. This concept is leading to putting more functionality, more features, using the best of power performance, and using the complex packaging that we have built to be ready for the next generation computers or electronics or whatever we are required, right? So this is the driver for the whole semiconductor ecosystem to grow. Now, if we connect and then see what is the path we have treaded so far, right? The one you see on the left is the path of how some of the different processors have been built over the years, and then at what level they have reached in terms of the instructions and the cycles and the performance throughput that we can do. Another comparison, if you do, of a processor that was there a couple of decades back versus what is available little more recently, you will see how things have shrinked or changed, whether in terms of the number of the silicons, the number of the transistors that we can do, how the energy efficiency improved, and the price that has reduced per transistor, right? And then there was this interesting comparison that I also saw, was that between a two PC that was built in two different decades or two different eras, how it compared against different components, whether it is the memory, the processor, the video, and all of that. And then there was also a comparison saying, okay, look at the cost, right? And then compare it, the cost maybe is the silicon real estate cost with a real estate cost that can happen in a city like Bangalore, where a lot of these design is happening. Many of this cost has reduced over 2 decades so that we can give more and more functionality to an end user at a lesser cost and then make it readily available for the mass, versus comparison to the how real estate has grown in anywhere else, Bangalore or wherever we go, right? And then another comparison, if you see, is that what was the so-called as an NVIDIA chip that you see, which was one of the biggest GPU that they created, and then compare it to one of the new AI/ML wafer scale engine that has been created, and it is 50 plus X size of that, right? So that's the path we have treaded so far with what innovations and what the semiconductor ecosystem was asking for. Now, if we deep dive into saying like, how do we understand that? What happens in that chip design life cycle? There is design, there is mask manufacturing, there is fabrication, there is die and sort, test assembly, and then finally supply chain and send it out to the customer, right? This is what you will go and see from anybody who has the fab and show saying like, what are the steps? If we talk about fabless, it is in the box one, where the design, which we are usually, the India ecosystem has grown in the last at least 4 decades, right? When TI came in 85, and since then there have been a lot of activity where every semiconductor house is sitting and doing those design here. What does a chip design require, right? This is the fabless block diagram that we are talking about. And if you look in those blocks, they are hierarchically made, just to see, and then I'll focus first on the innermost box, right? The building block for these fabless ecosystem or the chip design ecosystem is two things. The first one is technology, which comes from Fab, saying how a device can be manufactured, what are the rules they have to follow. And there are a lot of rules and electrical parameters, the spice models and everything that's given so that you can design, simulate, and verify and ensure that, this can be manufactured and the power performance will be as what is expected. There are fabs around the world, and we are all hearing all the news that's coming up. And this is one area we'll see more growth in India. There are companies which is focusing in India who is building some of the technology related ones. I was part of that company called Global Foundries, where there's a team which builds a lot of technology and manufacturing rule decks and in general the fab data. The second building block is what we call as an EDA. We have moved into an area where there are a billion of transistors and blocks and designs, and it's not possible for a human to go and do something manually. And you need that automation using smart tools to go do this design and then make it work for the size of the tech node that we are talking about. So once we have these two building blocks, we go a level up, we start using some of the IPs, which is very commonly used, and usually in the industry, you'll hear two terminologies. One is called foundational IP, which is something which gets used in every chip that gets done, right? Whether it's an IoT chip or a processor, whether it's an automotive or a data center, everyone will need the foundational IP of those usual standard library, the logic gates, sequential and combinational, the PLLs and the memories. And then you have the complex AMS IPs, which are different based on the use case. Some of them are like, the high-speed peripherals, like SerDes, whereas some of them have a lot of analog and digital interface, and you have ADCs and DACs and many of those things. So when you know these IPs get reused, gets multiplied in different use cases, you try to create it and keep it using the technology fab data, using the CAD tools and the functionality that you're trying to implement. Now, there's a lot of ecosystem in India where the companies are doing these both IP development, either as a foundational or an AMS IP. You name an IP company and they have a house here to do that. Once you have the IPs on the shelf, right, that's where comes the final SoC or a product or a design company, which picks up these IPs, have an idea about what I want to implement, let's call it an architecture, and go and use all of this to integrate, put it into a box and get it ready so that we can send it for manufacturing for the use case that we are targeting about. Usually it has two domains, which we call as the front end, a lot of architecture, RTL design, verification, emulation, and all of that happens. And then there is a back end where it gets mapped to a tech node and then goes through a physical cycle of, mapping the logics, placing it and ensuring clock reaches there, and then signing it off on the power performance and the manufacturability, right? So that's what is many fabless companies are doing in India for decades and decades. There are experts who have reached to a fellow level, which is the highest technical, a ladder or a role that a company can have. And we have fellows sitting in here who is doing a lot of these designs as part of the fabless ecosystem. One more way to look at it is the simplest diagram. I picked it up from the wiki, is how this chip design goes through from a system specification. From a top level, it looks like in 9 blocks. But each of them has 10, 15, and 20 sub steps and maybe beyond. And this is actually a 200 plus steps process. It takes 12 to 18 months to go and get it done. And then you have the SoC out, which goes into manufacturing and backend. So that's the starting point of chip design. No. Now, what does it take to do the chip design? And I've just put an example architecture block diagram. This is what any SoC design will pick it up. There are different components, which is going from the memory, cache, the processors, the different IOs. There could be security and safety built in. And then there are different blocks that you assemble and integrate to get the SoC ready. Now, what have been the challenges and opportunities that we have solved here, right? To look at challenges, we all know, and I think you heard it, there is millions and billions of transistors. There are different components from digital to analog. You pick some from different place, some from different place. Different people have different philosophy. So standards have come in to ensure that everybody align to that standards and release their IP for reuse across the different domain companies, tools and flows. And then you start going and start tracking the electrical manufacturability and physical parameters of performance, power, and other things. And it's very important that you keep a time to market, because unless you are in right time, your product may not sell. So that has been the challenges. What have been the opportunities, right? We started with what we called as the lowest most things, simple steps in the design flow, and now are doing an end-to-end. But when you go and do this end-to-end, there are 200 steps involved. There are 100 of engineers working, maybe these people working across 4 time zones, and then covering from the physics of the material to the electrical parameters, to manufacturing, and then computer architecture algorithm, where we try to optimize a billion transistors or placeable blocks in a design. And that's what is the characteristics of this design flow, right? There are multiple sequential steps and all of that, and that creates a lot of opportunities for innovation and continuous improvement that we go through. Now, this has been done for almost like, uh, close to 4 decades right now. And then we have experts. Now, what is next is what we are all moving towards is the manufacturing and test part of it, right? What you see on the right is a picture of a clean room in a fab that you see. Currently, actually, the more and more the technology is progressing, the human intervention there is reducing. Actually, all of these gets done through automated ways of usage of robots and many other things into the fab to reduce any errors, to reduce any any particles that is not required to come there. Now, some of the technology that you will hear, what you call as a wafer, how we started with a wafer size of 100, going to 200 and 300, we can fit more chips on those wafers. There are so-called, as you know, we lose at the corners the real estate space, but the intent is always to try and put more chips on the wafers, right? And then there is a manufacturing process also that goes through. Some of the important parameters that you should know and be aware of that, right? As you connect to the stories that is coming up, that we should have a fab ecosystem, the dimension of the structure that we are talking about is so tiny, right? That means any particle, dust, pollen, and all can damage them, right? Not just like create a function, a electrical issue, but it can create a damage and functionality can be. And that's why the clean rooms, their classification about saying what kind of cleanliness they need is million times cleaner than what we see in a day-to-day life, the air that we have. And there are different damages that can happen, and that's why you have different precautions and different ways to ensure the clean room remains a clean, and the context of clean is much different from what you and I have been used to, right? Once you do this manufacturing, you also have a lot of test-based ecosystem. What test means is that once your chip is ready, or even wafer is ready, and then chip, and then package, there are different stages that particular SoC or chip gets tested against the functionality it was built in. And that's where you will see there's a lot of patterns which is used to transfer that through the chip and then measure at the output and see if the output is intended, and then define saying, yes, chip has life, and not just life, but it is also functioning or as we thought, right? So there is a tester on which the DUT or the device that needs to be tested is placed, and then it goes through a cycle to identify if there's a defects or a fault. And depending on how many passes, how many fail, there's quality levels and reliability levels that you need to certify. And this varies depending on which market segment you're using. These are the pictures of how the ATE testers look like. Many of the fabless company who started have started having a test lab in their offices in India. So there are set of testers there. There are dedicated companies who built their business model on either as a service or as a development to have testers and then provide that for the product development in the India fabless ecosystem. So that was happened. And now this is what you are hearing is the manufacturing ecosystem. So that's the manufacturing and test part of it. Now, I would also put in some case studies so you can connect it with the design challenges that are coming in and how it connects to some of the students and the academia projects, or how where government can also use some of these things, right? Now, you are hearing everything now is becoming battery, and it has become important. Now, there's one thing where you need battery life, and so you want those sensors, those equipments to last longer. And the other side, there are a lot of data being consumed and stored and processed. And those, data centers or SoCs or chips are becoming not just like, watts, kilowatts. There are, multiples of kilowatts is being consumed in different data centers. And they're thinking of keeping the the data centers in the oceans under the water to have the cooling effect. And then to reduce the power, there are multiple things you can control and use it to drive a low power design or an SoC for you. You can use ED algorithms to optimize well. You can make your IP better by having the right devices and a right amount of the circuits so that you can reduce the power. And then you can do a lot of things on the design side also. As a technology, you can try reducing the voltage of operation. It directly reduces the power. But then during the design, can you optimize something? Can you switch off something? Can you reduce the load? Can you do different things? So there's a lot of opportunities here, from device to PDK, to the technology, to the EDA, IP, and finally SoC architecture, both front and back end, to actually contribute to reducing the low power. A lot of fabless companies is focusing on this as we have been building products from here, right? Another case study that I'll take is an automotive. We have started seeing it, but globally this has been a phenomena. That number of electronics in a car is going from 1 to 5 to 5 to 10 and now into hundreds of electronics and semiconductor. You look at a car functionality or feature and it has an electronics attached to it. The sensors, the displays, the processors, the connectivity, and all of that, right? Now, as we build the next generation automotive and the future cities and the ecosystem around that, there's a lot of smartness and an intelligence built in. And then we are dreaming of the world where we will have a self-drive car where you and I don't have to drive it. We can just sit in it and it will go on its own once we feed the address. How will this happen? This technology is called as ADAS, which you will hear very often, where there are multiple things that are being implemented in the automotive system, right? There are cruise control was always there, but there's an adaptive cruise control. If there is a vehicle in front of you or something, the cruise control can slow it down, but then again take you back to the speed that you did that. From high beam to pedestrian, the different views, cameras that you have, multiple things that are being designed to fit it into an automotive and make it ready for a so-called as a driverless car, right? How is it different from traditional fabless or SoCs that we have been doing, which was focused on functionality, power, performance, area, and yield? Now comes that car lives for 15 years in our garage, right? So the quality and reliability, the aging effect is not for 2, 3, 5, 10 years, which was originally the case, but for 15 years, right? Secondly, now we are talking about self-drive. So the safety perspective, the zero defect, the electronics should not malfunction, so that whole self-drive functional goes for a toss, right? So there is a lot of that. And then when these cars are connecting to each other, there's a lot of security aspect comes in. And when you build all of these things, every government will put a compliance standards, what you use, what you follow, so that you are aligned to that compliance, you certify it, and then put your electronics and semiconductor out, and then finally your automotive, right? So this is the second one where again, there is a lot of design activities from an IP, EDA, SoC design, and even technology development happening for so long. This fabless ecosystem is again thriving. The third one, which you will hear very often, is about the buzzword called AI/ML, right? Now, there are two use of it. One, it's a software context. Can you use it to do your design better, right? And the second one is that you are making some of the hardware which have the inference, training, and other functionality built in to do some of the simulation and make decisions for you, and things improve as such from there, right? During the VLSI design, there's a lot of problem statement that exists as part of your design. You do different power voltage temperature analysis. You want to do a different estimation, and then you can use the supervised learning. Similarly, you're doing a lot of other simulations for pre-silicon or post-silicon. You want to improve the routing of different nets that is being done. There's a lot of areas and opportunities where the AI/ML software algorithms are coming in as part of the EDA tools to help improve the efficiency of the design and maybe actually get the better QR or the results for a design performance. But the second one was more that you make a chip which is for the AI market. And then there are two areas, high-end market where a lot of inferencing and training is happening. The data centers and the cloud, when the data goes, if we save something on a data center, it goes and sits somewhere. How does they use saying like which data needs to be kept front and back? There's a lot of memory involved. These chips are humongous and are using the latest and greatest technology nodes. This has been proliferating a lot in terms of CPUs and GPUs. But then there is a lot of mid-range or low-range where it is used in day-to-day IoTs, the edge, smartphones, where you can use some of the existing nodes, but you have to build on the other requirements on memories or the automotive and another things. So that's the other, I would say, another market or areas where there's a lot of innovation happening, a lot of work is happening. The India ecosystem of fabless design has been doing this work for the recent last 5 to 10 years, right? Now, we have seen the fabless world, what it takes, what all is happening, and then where do we go from here? What next for us, right? Uh, before we get into some of those things, this is a old picture I have taken from 2016, where SIA kind of says that, you know, if you have to look at saying how an idea and then from there into a Verilog code, and IP goes into a chip design, but that's one part of the work, right? It maybe gets done in 2 or 3 geography. But then the second point of the work is that how does it get into an end product? And then there's a life cycle which crosses borders, right? There are different countries which specializes in different equipments that are there, front end, back end equipments, the materials that are needed for make wafers and other stuff. There is an IP ecosystem, media ecosystem, the manufacturing is somewhere, packaging is somewhere, the overall assembly and test could be somewhere else. And there's a lot of, you know, what you see across the geography that happens. A lot of partnership between the companies across the world. But that's where some of the geopolitical situations is creating a complexity, and you're hearing the shortage, as well as an ambition to have things localized and be more, you know, self-reliant on producing these end equipments, right? Now, what does this mean in terms of the fab ecosystem? That is one ecosystem that we are all aspiring for. What you see is that long back, how many companies had fabs? And these are the companies, you will see some of them have been removed as you go down, because they are the one who became fabless by selling their fab or closing their fab or giving it to somebody who specializes in fab. And at this time, if you go into the most advanced node, if you have to make the high performance processor or some other ASIC component, then we are left with finally 3 choices to use that for 5 nanometer and below. Above that, yes, we still have 5 choices that we can use. And then for some of the analog or discrete or some components, we still have more than 5 or 7 there. But the fab ecosystem has changed because of primarily one, the cost that's involved, the equipments that are needed, and the volume that is needed. Do we need that many fab or not, right? And you can see the cost that's estimated by Intel, Global Foundries, and TSMC these days about how much cost is required depending on which technology node we are doing, right? What we have been seeing, yes, right, we have been hearing, can we have the self-reliance? Government has been seeking proposal, right? Semiconductor is the key for technology leadership. That is what the whole experts is trying to forecast, and working the Fabless and the overall Semiconductor Association has been working with government to put up something that, hey, can we have the ecosystem which is more local and self-reliant, make for India and then maybe make for the world, right? We saw that announcement a week before, where we have announced the policies by the government, the intent and the amount of money that has been there. And then they are now launching the different schemes and other things for different players to come and use that and utilize this, right? So I think this is what we are moving towards. Uh, Now, if we connect all of this, and I want to wrap it up, my talk here, what has been the past, present, and future, right? The past have been Texas Instruments. That's the one that started. If you remember, I think you would have seen this in many social media or other places. The satellite dish being brought over in an office in Bangalore in a bullock cart, and that set the first communication link and an NTI office to start working with US and others, right? That was one of the first R&D center. There's a lot of good videos also there in case you want to go and see that history, how it happened, and the people behind it. Both government, the industries, and some of the advisors who work towards it. What has happened is also that we talked about some of the most latest and greatest gadgets and all, and we have heard the amount of noise, or I would say press, that the news about Tesla generating, that they drive into India with a new company and a plan to enable their car in 2021 in India, and they have started that as well. So that's the TI was the past. The present Tesla is here. What I think the future is, I don't know if we continue TT and is it TSMC or something else, whatever the fab comes up, that is what the future is. But the most important part of it is that this decade story is continuing. And I think all of us, or many of us, and especially the young students and the researchers, they will be part of this next decade and the future that we are trying to do and build the overall ecosystem, continuing on the fabless innovation that we have done, the expertise of getting the product development, and not just the product development, the other ecosystem out, and now getting into the manufacturing and then the rest of the ecosystem. So with that, I'll stop here. If there are any questions, I'll take that. Would you read if there are any questions for me, or do I need to look at the chat window?
Like till now, there is no questions.
Sure.
Hello, good afternoon, sir.
Hi, good afternoon.
Sir, actually, as we are aware about, like, if you have to work in the startup domain, especially in the field of VLSI architecture. So, is there any brief roadmap so that we should look ahead, specifically in the field of VLSI? Let's say how we can jump into the startup domain, especially in the IP integration and the service provider.
So if I understand, this is more from an India ecosystem growing, or you're asking from a student's perspective, how they get into the startup ecosystem?
Yeah, how student can go into the startup ecosystem, especially in the India, if LSI domain.
See, I think the biggest, I would say, the blockage for not so many startups in electronics and semiconductor compared to software is that the time and money it requires to get your idea into an actual product has been huge, right? A simple chip, usually when you're doing the second, third, or fourth time, then maybe it can be in months, but usually for the first time, it is into a year and more. And then you have manufacturing, testing, and each manufacturing, it goes into $1 million to do that. So that has been the so-called as the factor which delayed a lot of these things. But as you've seen, actually the policy is bringing in that there has been support for the startup ecosystems to get some of the free tools, free IPs, so that they can do a prototype of their design. And then with this model, we can actually have a so-called as an exploration or some ways to put it on a test shuttle and do a proof of concept when the final silicon comes. So there are things happening, but I think there will be a lot of acceleration of these startup companies with these policies coming into picture. Many of these had started from even government institutes. Many of the IITs have their startup arm where they have been building the POCs, but a lot of private players will utilize the policies that's coming in.
Sure, sir. And is there, sir, any note like at present government has like giving any opportunity to the students so that we can focus in the way like specifically?
I know for sure. I think Professor Viskarma will know much more than me on that. But I know the SMDP program and any other many program by government not just enables with a theoretical knowledge. I have seen a lot of products being designed by set of colleges combining together and doing a product for either the government bodies or for our aerospace and defense projects, and some of the processors that has come out from the Shakti Lab and others. There has been a lot of such projects that has been doing. I have reviewed at least 8 of them where different IITs along with ISCs and NITs and other colleges in that ecosystem have done that. In fact, last couple of years when I went and hired placement from the campus, many of them have done actual design and has been part of that, working with their professors and faculty as part of that program. So maybe you should talk to Professor Viskarma and others to get more details on how you can be engaged in that.
Sure, sure. Thank you so much.
Meanwhile, we have few questions in the chat box. So the first question is from Vabhav. How academic institute participate in Fab India program?
The Fab India program, I would say, is that there are two components to it. One is the factory component in general, right? How do we have the factory with the right equipments, the right environment, and right, I would say, the skills and labors and everything required. Maybe let it keep it more driven from a corporate or industry or the government to do that. But to be able to build the technologies, I'll tell you is that the people who work in some of these fab companies who build that PDKs and all, these are the people who work more in physics and in material science and all of that, right? While a lot of people have been focused on digital design and analog design to go and contribute to a fabless, there has been still a limited work in limited colleges or universities being done more on devices, technology, and materials. I would say that is one very good starting point to start. How do we make best use of the technology to build some things which can be the starting point for the fab for the product specifically for India, right? We will use a lot of sensors, lot of smart cities. We'll need a lot of low power equipments. We'll need billions of them. So how can we reduce the cost and size of it? So I would suggest start with the technology and material side of things. And then once a fab shows up, there'll be a lot of skills and in jobs and in research opportunities next on the way.
Sure. Thank you, sir. Thank you for that input. Like few more questions in the chat box. One from Sai Kumar. He's saying, can I know some trade-off between the parameters while designing a chip in a real-time industry?
So I'll tell you. I think if you are using a variable, right, for monitoring your a health or activity and other things. Now these variables have been made with a thought process of saying they are running from battery and they should run for weeks. You don't have to charge every day, every night, or every other day, right? So when you decide this, the form factor is very small. the power has to be very small. So when you go and optimize the design from your IP to an SoC, your primary factor has been power, power, and power, right? It's okay if it takes a millisecond or a few seconds more to show something which you are trying to touch and find out. Versus you go to some other applications, say gaming applications or something else that has been built upon, where the performance has been the key. It's okay, somebody knows that I'll charge after I play this game every 2 hours, but my response to any instructions or any touch or anything else is very important, right? So each equipment is very different. I'll pick up another example of an automotive and not just go into a smart car, but takes a lot of these smart two-wheelers that have coming in, right? Satya talked about the Ola factory that's coming in. There's a lot of smart electronics built in the Ola scooter, right? When they come in and they use some of the functionality, you will have to ensure that it survives it will be stationed outside, right? So there'll be moisture, there'll be temperature variations, there'll be rains and everything. How does it survive those environment conditions and still work for the lifetime of the scooter? So these are the real-time end users, and based on that, you get the the factors or the controls that you want to balance and enable your design cycle.
Great. Yes, thank you so much, sir, for that answer. So, coming to the next question we have, what are the current challenges to establish Fab in India? This was a question from Praneet Jain.
So Praneet, I think I attended at least Dr. Satya's talk for sure. And he talked about it. The challenges starts from multiple angles, and I'll focus only on the top level, that it does need the clean room that I talked about, the clean air, uninterrupted water supply, the power supply, and all of that is such huge, and be any city or a country to provide that needs a lot of the background work to ensure that that uninterrupted supply of all those things can be done. That is one of the first one to do. The second one is the bigger question of saying which technology node to focus on, right? I know there's a lot of people who would want to rush and say 5, 7, 12, 14 nanometer. That's where a lot of CPUs and GPUs are designed. But remember, there's a sizable semiconductor electronics which is built on 28, 32, 45, 65, or 90 nanometer, which gets used in our day-to-day life, right? Smart city will use it, smart factories will use it, smart roads will use it, our home will use it, and a lot of other will use it. The decision took saying which node to start and ensure that we can do a fab which has a profit in the coming years, and then also a utilization that it can be used continuously for 365 by 24 by 7 are the two key decisions, and a lot of analysis that needs to be done before they finalize and say this will be the location of the fab, this is a technology node, and all of that. I think once we do that, the rest of the semiconductor ecosystem has grown very well. They can come together and help it. Technology, the skill set, the human, the capital and the skills that is required will be the next order.
Thank you, sir. Hope Praneet get the answers. And if not, you can you can ask the further questions in the chat box too. So the next question is from Mahendra Singh. He's from Prestige Institute, Indore. I'd like to ask, he's saying, I'd like to ask, is there any industry academic collaboration in your organization?
Sure, I think every company sets up time, energy, money, people to do industry academia collaboration for multiple reasons. We can use the talent, the ideas, and the lot of research work that's being done, and then also it gets used for hiring and branding and all other things. So there are at the start of my presentation, I posted my email ID, or on LinkedIn you can ping me, and then I can connect you to the person who manages that.
Okay, thank you. Thank you so much, sir, for that. And one more question from Vaibhav. He's asking, what are the current trend in low power memory and processor design for AI and other high performance application? Should I repeat?
low power memory and processor design for AI. Okay. It's a, I don't know if it is a typo or really it was a loop that got created there. Uh, um, Means the low power memory it has been a trend not just today. It has been there, and people have been building different memory there. uh, the recent one is that the AI chip that you make, it needs a lot of memories, lots and lots of memories, because you want to store the data, you want to do analysis, do some training and inference, and make decisions for do that. That is where there's a lot of analysis happening about how do we keep it low power but at a faster speed. And then since there is so much of memory there, memory comes with a feature called repairability. How much repairability should be enabled in the design, which is always an overhead, and all of that. So there has been a lot of growth on it. Maybe I can type down some of the research article that you can read out, and keep a track on that.
Thank you, sir. Thank you, sir. With this, I think there are no more questions. Few thanks from Mahendra and other students who have got the answers. And finally, thank you, sir, for taking your time and sharing your thoughts on Fabless and Fab Semiconductor ecosystem. And that was indeed a very informative session. And obviously, I'll say that thanks for bringing the transparency between industrial and academic aspects of Fabless and Fab Semiconductor. We'll be happy to see you soon in the campus so that we'll interact in person instead of this online conversations. So thank you, sir. Moving to the next invited talks. So we have some very interesting invited talks by academic and industry to establish collaborative ecosystem in MP. There are academic programs, R&D activities, startups, industry arrangements for joint student supervision, joint projects, EDA, and Fab facilities. So let's welcome our first speaker, Dr. Vaibhav Nima. Dr. Nima is currently working as an assistant professor in Department of Electronics and Telecommunication at Institute of Engineering and Technology, DAVB Indore. His area of research includes circuit simulation, circuit analysis, low power nanoscale CMOS circuit design, and microelectronics and semiconductor engineering and EDA tools. I request Dr. Nima to enlighten us with his thoughts. Welcome, sir.
Yeah, thank you. Am I audible?
Yes, sir.
Okay. One second, I have to start my display.
Yes.
So is this slide is visible?
Like it's coming, it seems there is some lag.
Now?
Sir, it seems only the browser screen is being shared.
Okay.
So you can stop presenting and then try presenting again. Yes.
Now I think it's visible.
Yeah. Yeah. Yes, sir.
Yes. So thank you so much. So as the role of this the aim of the session is to create an ecosystem from academia and industries. So from morning we have seen a presentation from the industries persons, and the first academic presentation is from my side. So first of all, I'll try to make what the academic institutions are doing at Indore and Madhya Pradesh, and what we are required support required from the industries to develop a complete ecosystem for VLSI industries and VLSI. So myself, Dr. Vaibhav Nima, and I'm working as assistant professor at Electronics and Telecommunication Engineering Department, Institute of Engineering Technology, Devi Visyalaya, Indore. So first I will try to explain to you what we are doing and what we are. Actually, I'm working with Devi Visyalaya, Indore, and Devi Visyalaya, Indore is one of the central Indian university which accredited A+ grade by the NET.
Sorry to interrupt you, sir. Can you please make it like full screen in the present section on the rightmost corner? Yeah.
No,
Yeah. Thank you, sir.
Yeah.
Yeah.
Thank you so much. So, first of all, I'll give you the brief idea about what Devi University Indore, where I'm working. So, Devi Visyalaya Indore is established in 1964, and the Devi Visyalaya Indore is the first Madhya Pradesh State University, has been accredited by A+ grade by the NET. Devi University is an affiliating state universities hold judicial, including the 7 tribal dominating districts of Indore division. There are 30 university teaching departments offering the undergraduate, postgraduate, and the research program in 16 faculties. Devi University Indore is amongst the first few university in the country to introduce the innovative and integrated program in area of science, engineering, technology, management, law, and media. The university has 264 affiliated colleges, in addition to university teaching department and centers. All schools, institutes have a complete academic autonomy and flexibility. The university serve around 260,000 students every year through the well-qualified human resources with diversified program structure, interdisciplinary research, and the value-based education. This is a brief introduction about the Devi University. Then these are the teaching departments. So various dimensions are there in the university. As I told you, there are 30 different departments in the university, and each department have their own autonomy for the syllabus, for examination, and all this. And out of this 30 departments, these 4 departments are mainly working in electronics field and electronics related areas. The first main institute is Institute of Engineering Technology, which offers the Bachelor of Engineering in Electronics and Telecommunication, Electronics and Instrumentation, Computer Science, Information Technology, Mechanical and Civil Engineering. It offers the master's programs in Digital Communication, Digital Instrumentation, Thermal Design, IT Security, IoTs, and other areas. It also offers the PhD programs in engineering. And the second institute which offers the courses related to the electronics are the School of Electronics, which offers a very famous program is the MTech in Embedded Systems and PhD programs in Engineering and Sciences. The third institute is which offers the course related to the electronics are the School of Instrumentation. It offers the MTech program in Internet of Things and PhD program in same Internet of Things and other related areas. The School of Data Science offers the MTech program in Data Science and PhD program in Engineering. So the institutes, the basic 4, these institutes are working in the field of electronics, and they offer the various programs in the as a bachelor programs, master programs, and the research degree as a PhD degree and other ones. So I belong to the Institute of Engineering Technology. So I'll give you the brief about this Institute of Engineering Technology, IET. It's popularly known as the IET DAV Indore. And I'm working with Electronics and Telecommunication Engineering departments, and these departments have various laboratories which support this VLSI related courses. First, we have the Advanced VLSI lab. That is that the lab is having a facility of CAD and CDA tools, Xilinx tool, FPGA boards, and some other boards are there for the prototyping, circuit design, and the verification. Then the other labs are the advanced communication labs also there, where we have the MATLAB and other tools. Apart from that, we have DRDO sponsored and DSC sponsored the photonics lab, where we'll do the research of related to the optical set, the optical and wireless communication systems. Apart from that, as far as the my area of concern, I'm mainly working in the hybrid memory and reliable memory system design. So yesterday, my two PhD scholars presented their works. One is in hybrid memory system, where we are working in the hybrid architecture of memories. The hybrid architecture of memory means the different architectures of memory, the SRAM memory cells. We try to make a bank of that different memory cells, and as per the application, as per the requirement, as per the need, we design a controller circuit that control the part of means that control the required circuitry, and according to the required, according to need, means a need means what? If it required low power, if it required a high reliability, the controller decide that this data has to send to the which bank. And bank has the various other options and various other related capabilities. So according to that, we have developed one prototype for that, that is known as a hybrid memory controller design. And that controller is mainly means we are focusing for this image processing and the video processing applications, hybrid memory cells. Apart from that, we are also working in the reliable memory system design. So where we are working in the various reliability issues which are occur for the memory design, means as we know that at the very lower size, means a very lower technology node, the reliability is the mainly issues for the memory circuitry. So we use that, and we try to design a circuitry that are mainly work, and that they should have a high reliability, means they should have a high reliabilities. Apart from that, we are working with some research projects. I have a collaborative research project with IIT Indore. The one current research project is again Indo-South Korea joint network for environmental physical system design, and we received the funding from the DST. We have completed with IIT again. We have completed one project, is a Alto Finland project, and that is for the skill development for IoT based implementation. Funding amount is around 50,000 euros. And presently, I'm working on this TRE fellowship of DST, and in that we are working with this hybrid memory cell and hybrid memory circuit designing. Apart from that, I have completed one research project from MPCST Bhopal. The worth of that project is around 8 lakh rupees. I have also completed one UGC seed money project that is of 1 lakh rupees. So these are the research projects which we have worked and we are working. These are the my PhD students. So the two PhD students have completed their degree, Miss Nidhi and Pushpa Rekwal. And apart from that, the four different students are working in the field of VLSI. Natwar Butla, Pritesh Kumar Jain, Renka Sharma, and Pradeep Jala. As I told you, the Natwar Butla is mainly working on energy efficient memory circuit designing for IoT applications. And Priyanka is mainly working on the hybrid memory. And Pradeep Jala is working in the design of continuous time integral delta sigma analog to digital converter for multi-channel readout circuitry. So these are the PhD students. So we are working in this various areas and application, and the two major areas where we can work and we can collaborate. So university is always open to collaborate with the industries, and we require the support from the industry, because whatever the prototype, whatever the design we are making, that is not an industry standard design. So for the large scale development of the circuitry and the large scale development and large scale means a skill power also, we require the industry support. So we are looking forward for the industry support in these two areas. Thank you so much.
Thank you, sir. That was indeed an enlightening talk. Is there any questions? Oh, okay. It seems that there's no question from the audience.
Okay, thank you.
Thank you, sir. Thank you for the talk. So for the next talk, we have with us Mr. Ashish Lachwani. So Mr. Lachwani is a 2004 Institute silver medalist from IIT Madras. He joined TI Wireless Group in 2004 and was industrial in developing 2 generations of TI low power Bluetooth radio solution with simple link. Sorry. He's a co-author for the book on low power radio published by Springer. Ashish was the frequency synthesizer architect at Qualcomm, Snapdragon 65 bits RFIC. At Steradian, he leads the business while developing the technology for the next generation radar platform. He holds 11 issues on US patent on Vani to deliver his talk. Over to you, sir.
Great. Thank you so much for that generous introduction. I hope you can hear me well.
Yes, sir, it's audible.
All right, great. What I'll do is quickly share a couple of slides as well. Let me know if you're able to see the screen. Is the screen visible?
Yes, sir.
All right, thank you so much there. Let's get started. So, as introduced, I represent Fabless Semiconductor over here. We are getting close to 6 year of our operation. On the product side, we focus on 4D imaging radars as one of the primary products. So this is primarily intended as a civil automotive radar and for industrial applications as well. So automotive, it's pretty, fancied as that sensor which can help you do higher levels of autonomy. So you are looking at ADAS functions of driver assistance or even the holy grail of autonomous vehicles, right? So as a sensor, that's where it gets used. Industrial applications, a lot of places where there are, requirement of figuring out the speed or mapping the surroundings, where camera isn't suitable, either privacy concerns or all-weather applicability, right? So those are the kind of places where we have done well and been able to deploy our solutions. As a company, we remain essentially a technology provider. So working towards that, we have multiple patents covering both the software and hardware side. So I'll talk about the kind of offerings we have and where we find a lot of synergy with the academy as well. So of course, as I was mentioning about, how radars are getting used in automotive, being able to replace some of the existing sensors, or as a sensor spot itself, they have been there, almost from 2 decades now, primarily because of reliability being the primary driving factor, where you can use these sensors to see 300-meter plus under any weather conditions, fog, dust, rain, snow, and so on. I mean, very easy to understand even in our country, northern part of the country, where fog determines all the visibility what you have, right? And that's where these sensors can be used. Defense is an area again where they have used this sensor for like more than 5 or 6 decades, and one of the primary sensors used for tracking any kind of let's say UAVs or any objects around, right? So reliability is something which is associated with this sensor, and that's what brings it to the focus of being deployed in such scenarios. These sensors today are being used in millimeter wave range. So what that means is you have the advantage of visibility across the weather conditions. So these are at 80 gigahertz. So you can imagine the kind of challenges which would associate with this kind of a sensor. So just to give you some perspective, the entire 3G spectrum is around like 2 gigahertz to 3 gigahertz. The 5G, which is in an evolution phase for next generations, will be looking at 40 gigahertz sensors. And what we are working off today is at 80 gigahertz. So in a true sense, it is that next generation technology. On what we are trying to do essentially using this sensor is able to add more and more dimensions. So imagine a poor camera where you had a low visibility or like, lesser contrast available. So the present generation radar, that's where they reside, able to decipher only, certain part of your surrounding. So the 4D allows you to see those other dimensions like elevation side, get the height, width, shape of the objects as well, and still retaining the frequency band as 80 gigahertz. So the reliability of sensor is still maintained out. Application wise, where we have gone and used these sensors all the way from even ITS, which is the intelligent transportation systems, being able to rather proudly claiming that one of the places where we have got this solution installed in India as well is as a traffic monitoring device, right? So you have this single device projecting on the gantry where you can monitor the traffic, control the traffic lights in a more automated fashion, find out the queue lengths, do enforcement, find out that one vehicle which is breaking the speed limit or in some lane where it's not supposed to be there, many such applications, right? So just quickly jumping on to the product and where our industry from the industry side, where our connect to the academia begins. We have the radar semiconductor, which is a 28 nanometer TSMC technology. So as was being talked about earlier, one of the discussion points was that there is a race to go to that lower technology node from an industry point of view, where a lot of processor works happen. But as you can see, even for an 80 gigahertz application, we are very well commercialized these solutions, even from a 28 nanometer. So it's not that the technology node is saturated, but it's a very application dependent, context to look at. On the software side, so we also build the embedded software or the signal processing algorithms required to take this output of this IC and being able to produce what is called as point cloud, which assimilates well with the camera or the LiDAR sensors. So this middle box is the one which we are also shipping out to multiple countries today, and which forms a good customer base for us, where these units are used as a plug and play box. So in that true sense, we are a company which is a vertically integrated player, going all the way from antenna design, which goes into this box, because this is 80 gigahertz. It's a patch antenna microstrip which we are using inside this box. The IC design, having our own ASIC or a semiconductor, and then the signal processing, and then of course this box which gets qualified for various standards of FCC CEs and IP67s and so on. So connect wise, this is as broad and anything under the sun from electronic product point of view, be it high frequency patch antennas, ASIC design. If you have an interest in analog, RF, mixed signal, digital design, all gets encompassed into this IC. You have an interest in signal processing algorithms, spectral imaging, tracking, clusterings, the more new age stuff like even identification, also known as AI MLs nowadays. A lot of it gets encompassed into what we do. And we have gone beyond just our own employee base working on these today. Almost every 6 months, we have a new batch of interns coming on board, almost like 25 interns. Though being a smaller company of like 65 team members, it's a huge number for us to assimilate, but we have seen various benefits of that model, and being able to tap into the talent much better that way. So we accommodate almost these interns from the known IITs, of course, the BITS, very recently from IIT Naya Raipur. So I mean, really look forward to having connect with say IIT Indore, DAVV, GSITS, some of the local colleges as well. We would be very receptive to those connects as well. Just also a broad overview of the kind of blocks which we work on, just breaking it down, the IC into bare minimum. You're looking at receive and transmits. This is for a wireless RF device sort of receive transmit, where you have the usual blocks of LNAs, power amplifiers, PLLs, high frequency ADCs. I guess Dr. Weber was showing earlier, Delta Sigma, very interested in those kind of blocks. FFT engines, design of MIPI, very high data rate, 14 Gbps. These are the kind of blocks which we work on from a chip perspective, right? Some of our development also happens in communication side, where we are working on proprietary communication standards at 2 gigahertz ICs for that purpose. So your similar receive transmit, but covering a wide band from 1.5 to 2.5 gigahertz. 5G side, millimeter wave, we have certain devices for base station infrastructure side. So that's your 40 gigahertz development. This particular for radar, of course, will be at 80 gigahertz. So tons of work which is going on in relevant side, and where we see a lot of connect and synergy which can be established. We also have, by the way, a few projects running with faculty directly in IIT Bombay and in Hyderabad, where we collaborate with certain projects where they need either sort of an industry connect to get that latest technologies assimilated, and work on certain projects in a more joint fashion. So we are open to those projects as well today. I guess that gives a good color of what we are into, the kind of development work which is going on at Steradian, and how we connect to the student community, the internship programs, the joint efforts with various faculty across the country. Open to any questions.
Thank you, sir. We'll wait for any questions from the attendees. Okay, it seems there is no such questions in the chat box too. So thank you, sir. Thank you. That was such an informative session. And moving to the next invited talk, I'd like to invite Dr. Ankur Behar. So Dr. Ankur received the MTech degree in VLSI and Embedded System Design in 2010 from NIT Bhopal and doctoral degree from IIT Indore in the specialization of nanoscale device and its circuit application in 2018. Further, he has joined postdoc in the Department of School of Electrical Engineering and Computer Science in ISER Bhopal in 2018. He is currently working as an assistant professor in VIT Bhopal from November 2019 to present. I'd like to invite Dr. Ankur to address the students on this topic of Fabless and Fab Semiconductor ecosystem. Ankur, sir.
Yeah, good afternoon to all of you. Am I audible?
Yes, sir.
Okay. Just a minute, please. Let me share. So, is it visible to all of you? I shared one slide here.
Yes, sir. Yes, sir. We can go on the present mode. Yes.
Okay. Sure. So again, good afternoon to all of you and respected dignities, speakers, and all dear participants. Thanks to all of you for the opportunity. So let me have discuss first the research and resource facilities in SEEE VIT Bhopal. As on behalf of the VIT Bhopal, we have offered basically 2 courses. Let us first discuss about the courses and research we have, and after then we have the possibilities. What is the over the research as well as the industrial collaboration we can discuss right now. So we have the 3 courses for that with EC specialization in AI and cybernetics after this communication, and we have MTech VLSI design. Under the MTech Village is the SN program coordinator. We have some from the last 2-3 years. We have actually offered that in 2019, and we have device optimization, modeling, analog circuits, and the neuromorphic circuits, digital VLSI and FPGA interfaces we have. Apart from this, we talk about the device optimization as far as my main specialization from this device to circuit applications. We have various advanced MOS devices such as tunnel FET and graphene FET. We did work from there from last 2 years. Now single gate, double gate, and cylindrical. Apart from this, the heterogate structure. So what we found the limitations of low on current, high gate drain that we have. What are the possibilities and how can we overcome that optimization using the optimization simulation techniques to get 3-dimensional view. Since nowadays from the industries also after the conventional MOSFET, this advanced MOSFET like tunnel FET, due to the beauty of its low power consumption and the tunneling band-to-band tunneling, it may be most demanding way. So that will move towards it after this, and after the optimized simulations, analog RF parameters for transconductance, frequency, and radio frequency applications, we have go for to the device to circuit applications. So after this, we go for the analog in continuation with our advanced MOS structure. We another have the graphene FET structure as due to famous personality due to their high mobility structures and low band gap material. We can say that even the gapless material we can see, and excellent thermal conductivity. We use this the graphene FET. So now from the last few years, we have also worked over this apart from this tunnel FET MOS structures, so that with the own beauty of this single gate and double gate structure for the graphene structures, being their property of mobility, capacities, and reliability mobilities, we have some transfer characteristics and ambipolar behaviors that we can consume over the IDVG characteristics as well as for the different channel length and different drain voltages right now. So these ambipolar characteristics and graph of graphene FET, as we know, that nowadays only due to the practical application, the fabrication, since some challenges may be assumed, but now recently from the few months or the some lab have already accelerated over the working over this. So now the important thing is that after the device, how basically the circuit applications over the application using our own optimized device, that is our main approach, that is the device to circuit applications. So as we know about the following basic steps of how can we convert a device to circuit using the LUT method, that is lookup table approach we have. So as you know well, we have this. As for the block diagrams, we have to after the extraction of successfully all relevant parameters, we have to combine it all the parameters in the form of lookup table. And once we have performed, I mean for the different VG, different VD with the step size of from minus 0.1 volt to up to the 1.5 like this, with a step size of 0.01 in the. So in order we have the all characteristics parameters in the one file. After this, we have to prepare the Verilog A code while calling that parameters of the device using the Verilog A code. And that Verilog A code may be simulated using the HSpice simulation tool once we have formed the model or the Spice netlist file. So these are the flow, how can we convert. So once the circuit that we are working over from the last many years are based on the TSMC and other files, conventional files, available library files, but we are in position to work over our own tunnel FET device as well as the model file based on the graphene FET. For graphene FET, we are using the mathematical modeling equations for that. But for our tunnel FET, we have the lots of simulation characterization data. So after this, we have characterized. So in this way, our own library files based on our device we have so that we can make the circuit. And the beauty of that circuit is that may be of low power applications. Sorry. So this is the device to circuit. Again, we have that tool we are supporting for the Verilog A foil and that using the TCAD and HSpice simulations. And after this small, so two parameters we have, either we can go for the model development using the model equations or for using the analog RF performances right now for simulations. So this is the final flow chart that we have to go from the device analysis, device design analysis and test. Once it is yes, and we are getting the optimized results, we have to flow further. Otherwise, we have to further back stage until unless we have not optimized our device. Then LUT and Spice netlist, and then we have the circuit-based testing. Once it is finalized, then we can go for the final comparisons. So these are the characteristics and transfer characteristics that we can go. And finally, after this, we can go to draw the circuit based on our own model files, Verilog model file, where we can call based on tunnel FET. So simple inverter circuits and two input non-gates results we are getting. After this, we have also designed one cross-couple voltage doubler. Doubler circuits as the basic phenomena is to just indicate to double the voltages as we have to invert. So we have analyzed this based on our MOSFET as compared to the MOSFET and TFET. So we can see that as compared to TFET, we have an at least percentage of at least 0.5 or more than 0.5 volt enhancement we have in the voltage doubler circuits with low power consumption. Since the beauty of the tunnel FET is the low power. So that is also we have got it in the finally circuit application. After this, now we have in continuation neuromorphic computing, as we know on the for example that the process to apply the neural system models. So it is referred to the biological process and later to turn out to be the computing algorithms. So based on as the block diagram, where we have used the current directions and neuron sum system model, where we have low pass filter and current splitters. So that is used to compromise the neuron non-abilities based on the human brains as axon and dendrites while using that comparisons we can. So few of our student, MTech student already worked over them and got some results based on the current direction selectors and schematics. After for this, in continuation, we have the FPGA programming that can also be offered for the students. Even the external students can also work over them as an intern there. Using the programmable various programmings, as we know that we can program and as per the requirements and based on that based on the configurable logic blocks. So these boards are already available and offered by the level of our institute. So apart from this, the partitioning techniques at we know in the VLSI is also one of the important techniques the parts to be the important role over to design the blocks or blocks for that particular modules. So using that efficient FM method for these Fiducia methods, students already worked over the circuit and getting some post synthesis simulated output results for FF partitions. So the tools that available and provided by our lab for the VLSI, particularly in the case of the TCAD as well as the for the circuit simulation, we have anti-spice simulation, and for the that may work for both device to circuit simulations, co-design, and the mental graphics for circuit simulation that may support. So the possible applications in future that we have to work and support for the low power SoC modules, and so that we have the optimized device and circuit applications based on our home device having ultra low power applications. That is our objective right now. In the research outcomes by our student in various journals and conferences they've already met, and they've already worked with the collaborated work of as a project intern with Vandevan University. And after this, we have an excellent placement based on that from our MTech VLSI students. These are on the 2022 batch and by the batch for Borgina, Payteams, Intel, and other MediaTechs. So now come to the resource facilities that may be available for the even the external people also for we have. That is from our institute, that is Vidyarthi. It's a very renowned e-program, Center of Innovation Programs, Collaborative Active Learning through Technology, STAR schemes, NSC project exhibitions, and workshop training, open research collaborations with industries and academic institutions. So here main important thing is Vidyarthi as well as the STAR schemes that may be available for all the school toppers, where our institute is sponsored not only tuition fees, but also we have offered the total hostel fees as well as their lodging, fooding, everything up to for the 4 years. So no a single money they have to pay. We have actually the district level toppers in the school from 1st to 3 top rankers. We have adopt these students, and if they wish, they have to join under STAR schemes. So it's totally free with lodging including that for them. Others we have project exhibition and intensive programs for any students, and also open research collaborations always welcome for the industries and academic institutions to work with us. So Vidyarthi is basically a goal so with that to create industry specific tailored and get learning programs. So from the last 1 year only we recently work over them, and few months ago only we have implemented this slowly. Right now we have basically to reuse tools and templates, since as per the pandemic situation everything is on the online phase. So here we have the features of these two rapid implementations, where it may also install in the own device, any device, either including the smartphones, tablets, iPads, and where we have some programming and like the courses, we have a link that we can build and provide them, so that at any place on pace they have to continue and work over them. Even the ones the no internet is there for the poor people sometimes, and for the rural places, we also provide no internet facilities, learn offline options, and download content to learn without going to online. So that for how to you correct and how to take that also we are providing the training over them. So e-learning programs that may be help for not only for technical, some other subjects other than VLSI may also be provided. So these are the outsourced benefits for the students by them, that is academic institutions, schools, universities, colleges, and non-profit and non-government organization, educationals, and any companies that may take the benefits of this Vidyarthi programs that was recently a few months ago only we have implemented. So that's all. Now I would like to give thanks to IT Indore, MPCST, and all participants, all respected dignities and speakers. So for any further, if anyone have interest, they may contact on the given email address. So thanks to all of you.
Thank you, sir. Thank you so much for the insights on semiconductor ecosystem, and also regarding that opportunities of Vidyarthi. I'm sure that all the students will make use of it. There are some thank you in the chat box too. Yeah. Some thanks from Praneet Jain and all, and thank you on behalf of all the attendees.
Yeah, me too.
Thank you, sir.
Me too. Very thankful to have an opportunity and open discussion in this platform. So NSDC Lab as well as the IT Indore and all the related organizing committee. Be thankful to all of you. Any question?
Any questions from the audience?
Hello.
Yeah, please.
Hello, Ankur sir. Yeah. So I have the question. Let's say we have our fabricated device. So
Okay,
how
yes,
we
yes,
can
sir.
explore till the circuit design and how we can build the indigenous architecture using the proposed device.
Okay, yes. So we have actually two approach for them. Once we can go with the modeling equations or we can go with the simulations data. And once another one that we have the if we have a fabrication based data, then also it's so much beneficial for us. So out of these three phase, we can go anyone. Suppose we have go with the simulation. So we have to collect first of all the all entire parameter range that is varied from the minus something minus 1 volt to plus 1.5 volt with a step size of 0.001 0.02 like this. In such a way we have a maximum number of simulations that may give to the more accurate characteristics. Once we have extract all the data and parameters in terms of id vg idvd cgd transconductances like this, all these we have extract in a one file that is known as lookup table. And once we have look up it in an Excel file, and then we have to call it using the Verilog A model that we have called in the syntax all that parameters, and that Verilog A file, that model in the form of spice netlist, that we have to again turn and curl in the form of HSpice simulations. So that file may be using the simulation. Maybe if you have the fabrication, you have the extract the all parameters and data that has to be called, so that the file that is available in conventional file today we have used only that is available why that SMC and other like companies that have produced or promoted us to for work over them. But once we have our own file, then we can do and we can work over the circuits that is consist of our optimized or low power device. So then so that we have low power dissipations in our circuit also. So that is, I think you got it, the
Thank you,
approach.
sir. Yeah, I got that.
Okay, thanks to all.
Thank you, sir. Thank you so much. I think there is no more questions from the audience side. Thank you, sir. Thank you for your session.
Okay.
So with this, I'd like to close the morning session. In the afternoon session, we have some more interesting invited talks by industrial and academic personals. Let's meet again at 1:45. I hope to see you all again. Thank you.
Hello?
Yeah, yes, sir. You are audible.
Audible? Okay. And
Yeah.
thanks. And do you also would want me to switch on the video?
Yeah, sir, it's up to you. If you
And
want to, you can say check your screens here. Yeah,
yeah,
now you are visible also.
yeah. Okay. And I can just try my screen share check also.
Yeah, sure.
You can see me, right?
Yeah, yes, sir.
Okay.
Yeah, now it's your screen is also visible.
Perfect then. Okay, good.
Yeah.
Thank you. So I'll join it too, right?
Yeah.
Okay, perfect. Thank you.
Yeah, sure.
Hello.
Yeah, yes, sir.
Oh, just checking. You can hear me all right?
Yeah, yes, sir. I can hear.
Okay. Thank you.
Yeah.
Good afternoon, everyone. Good afternoon, everyone. I'm Vasundhara Trivedi. On the behalf of IIT Indore and MPBS, I welcome you all back to the session of invited talks in the Conclave of Fabless and Fab Semiconductor ecosystem. The invited talks are related to establishing a collaborative ecosystem in MP, the role of academic programs, R&D activities, startups, industry engagement for joint supervision, fab facilities, etc. Now, moving ahead, I would like to invite Mr. Amit Chabra for the invited talk. Over to you, sir. Mr. Amit Chabra is currently working as a senior principal design engineer and is leading the advanced product design group at ARM Noida. He has over 19 years of industry experience and has more than 15 publications and more than 20 patents in VLSI design. His research areas include DTCO activities in 3D designs and reliability. He did his B.Tech from IIT Delhi in 2002. I cordially invite Mr. Amit to deliver his talk. Over to you, sir. Sir, are you able to unmute yourself? Mr. Amit, you are the panelist. You can unmute yourself, please. If there is any issue, can you please type in the chat box? Amit, sir, are you able to hear me? Amit, sir, in case you are facing any issues, could you please rejoin the meeting? It seems that Amit sir is facing certain issues in joining, so we'll just wait for a couple of minutes. We'll inform you when he's here. Good afternoon, everyone. Amit sir, are you available?
Yeah, I am.
Okay, sir. Thank you, sir. Thank you for your confirmation. We'll just begin in a couple of minutes. A very good afternoon, everyone. I'm Vasundhara Trivedi. On the behalf of IIT Indore and MPBS, I welcome you all back to the session of invited talks in the Conclave of Fab and Fabless Semiconductor ecosystem. The invited talks are related to establishing a collaborative ecosystem in MP, role of academic programs, R&D activities, startups, industry engagement for joint supervision, etc. Now, I would like to invite Mr. Amit Chabra for the invited talk. Mr. Amit Chabra is currently working as a senior principal design engineer and is leading the ARM product design group at ARM Noida. He has over 19 years of industry experience and has more than 15 publications and more than 20 patents in VLSI design. His research areas include DTCO activities in 3D designs and reliability. He did his BTech from IIT Delhi in 2002. I cordially invite Mr. Amit to deliver his talk. Over to you, sir.
Okay, so can you hear me?
Yes, sir.
Okay, and I'm sharing my screen because that makes. So can you see my screen as well?
Yes.
Okay. Good afternoon. My name is Amit, and thank you for inviting me for this talk. I'd like to share a little bit about the research engagement. So, since this conference and this conclave is about building the ecosystem, what I'd be focusing on is what what are the different kind of research engagements that ARM has been working on, and how uh, the uh, the other students can take benefit from that. So before that, let me just do a quick intro. So thanks for the introduction. I think it was pretty much covered well. So uh, just a bit on my current research areas. I'm currently working in the design technology co-optimization exercises in advanced technologies. And that kind of means beyond like 3 nanometer, where we talk about the nanosheets and fork sheets and CFET and what is beyond CFET. So that's essentially the 3D design aspect of the DDCO. And then yeah, I am, I started my career as a memory designer, and I'm still a memory designer. And then the other thing that I'm currently working on in terms of research is reliability and failure in time. So here are my contact details. Feel free to contact me after the presentation. Okay, so now what when we talk about research within ARM, we are actually talking about three different kinds of things, right? One is the research enabled by ARM, where ARM works, it collaborates with universities, and the way it helps is that the universities can also get access to the latest technologies, and then it also helps us in order to improve our solutions and build a much better ecosystem for our partners. Now, in addition, and I think I'd be talking about this in a bit more detail in the next slides. But in addition to this, we have a research group within ARM, which the primary focus of that is to keep an eye on what kind of technologies would be differentiated in future, and how would our microarchitecture, how should that evolve to take the maximum benefit out of those technologies. So that group, the ARM research group, it works with with multiple different institutes, organizations across the world. And they kind of we even have joint projects, with other organizations, and then and those are like companies like, for example, Synopsys, Tokyo Electron, and IMEC, and that also includes some government company agencies like, for example, DARPA. So, so the objective of doing all of this is to I'm actually concentrating on the first side where ARM is collaborating with different kinds of universities. So the objective essentially is to enable the academicians to increase their research impact. Now, what that means is that ARM is the technology supported by ARM are pretty ubiquitous. They are present all over the place, and if you as a researcher, if you kind of prove or demonstrate something on an ARM-based technology, that finds relevance in multiple different facets, and then you kind of have a complete ecosystem that's supported by ARM. So you kind of are proving the research impact in a much broader way. And we actually do provide some tailor-made collaborations with our with the institutes. So, and I think that's that kind of leads me to the next slide, which is that we have something called ARM Academic Access. So, if you've been working with ARM, we've currently introduced ARM Total Access and ARM Flexible Access, but that's mostly for our industry partners. Academic Access is, a very tailor-made concept for supporting the academic institutions, where we do provide free of charge access to all the industry proven ARM IP. And if you see from the top, it starts from processors, which constitute of the Cortex A class, R, and M class processors. And for those of you who are not familiar with the A class processors, are mostly for the application processors for the smartphones and tablets, and now it's also extended to support infrastructural cloud capabilities. The R class processors are the real-time processors, mostly used in either the storage space devices or the automotive section. And the Cortex M class are like small and cheap processors, which are used in many different applications. And then in addition to the CPUs, we also have access to the GPUs. Followed by that, we have the fabric, the interconnect fabric, all the system controllers, and then the core stone. The core stone is pretty interesting because those are like reference designs. So those are systems that are pre-built, and you could quickly integrate all the above the ARM processors and the fabric and build a quick system, and then include the debug and trace, and eventually you kind of have a quick way to have an environment where you can develop your software tools on it. We also support models which are cycle accurate models, which are used to have quick simulation and for verification purposes. And in addition to all of this, we also have physical IPs, which are standard cell and memory compilers, which can help you do an implementation run and find out where in terms of gigahertz your processor or your subsystem is landing. So all of this is streamlined under one legal process. So essentially, we do want to support, easy, quick, and complete access to academicians around the world. So essentially, I think it's something very, very similar. So overall, uh, what it boils down to is that the ARM technology is accessible for all the research or educational purposes. You can manufacture silicon, or you can just demonstrate something on a simulation test bench or something of that sort. So all these kind of things. It just depends on the kind of research interest you have. And then our agreements cover all the different types of institutes, and then the good thing is that the access control is managed by the institute. You can download things online real quick and just start to work. I think that's our motive as well, that we want to make the life of academicians pretty simple, give them all the tools, and then let them explore. So, depending on where you land, you could be, a very basic research, doing a very basic research project, and you would just like to have access to very simple like a Codex M class processor to demonstrate something. For that, we have the design start eval or evaluation. And then if you're a little bit more pro, then you have access to the complete RTL of Cortex M class, M0 and M3 and A5 subsystems. And eventually, if you really want to delve even deeper, that's where the ARM academic access comes into picture, where you have the complete offering as I described on the earlier page. So, all of this is streamlined within ARM. So you have our dedicated account management team. So AAA, which means ARM Academic Access dash sales dash team at arm.com. And then we also have, specific people within India to support the Indian institutions for quick access. And with that, I think I'd like to end my talk. A special mention that you could get in touch with Apurva Verma at arm.com for any India level assistance that you're looking for. She's dedicatedly working on supporting the research programs across the universities within India. Thank you very much.
Thank you very much, sir. Thank you very much, sir.
If you have any questions or
Any questions from the audience end? Participants may post their questions in the chat box. Sir,
I don't see any question in the chat box.
yes, sir. Right now, as of now, there are no questions from the participants. So, I would really like to thank you, sir, for such an interesting talk, especially about ARM academic access and tools. It was really an informative session, and I am hopeful that everybody would have gained a lot from your session. Thank you very much, sir.
Thank you.
Next we have Bhupendra sir. Bhupendra sir, are you available?
Yes, am I audible?
Yes, sir. So I'm delighted to invite Mr. Bhupendra Vishwakarma for the next talk. Mr. Bhupendra Vishwakarma has an 18 years of industry experience in the field of custom analog layout design and EDA. He's currently working as a senior principal application engineer at Cadence Bangalore. Prior to this, he worked at Intel to manage the PDK enablement team. He also worked at ControlNet India Private Limited in the early stage of career and worked on analog design and layout. He belongs to Indore, MP, and has done MSc in Electronics from School of Electronics, GAVV Indore, and MTech in Microelectronics from Punjab University, Chandigarh. I humbly invite Mr. Bhupendra for his session. Over to you, sir.
I'm audible, right? So I don't know,
Yes.
somehow I'm not able to turn on my video. So bear with me. Okay. Thank you.
Okay, sir. Sure.
Okay. And there'll be some noise. So bear with me for that also. Okay. Okay.
Sure.
So thank you for inviting me to this conclave. And I would say idea of Fab and Fabric system in Madhya Pradesh is very exciting. As outcome of this conclave can bring reality of having semiconductor ecosystem mainly presence in MP, Madhya Pradesh. Okay, and these days everyone in our country knows because of automobile industry that we are suffering from shortage of semiconductor chips, and this is the right time to discuss how can we build an ecosystem so that in future we don't see such shortage. Okay, so I'm really happy that we are having such conclave in Madhya Pradesh. Okay, since I belong to Madhya Pradesh, and I would really uh, contribute to. I would love to contribute to this. Okay? And to build this ecosystem, we have to start working together as schools, university, and organization. Okay? And we know that it is already there in all the organization, even in Cadence and with other organizations also it is there. Uh, okay? But uh, we need to give more focus to make it strong. Okay, because in all the
Sorry to
companies,
interrupt
in
you,
all the
sir.
yeah.
So in case you're
Hello.
presenting anything, we are not able to see your screen. So could you confirm
No,
if?
no, I don't have any. I don't
Okay,
have
okay,
any
sure.
slides to talk about.
Okay, okay,
I
sure.
should have mentioned that earlier. Okay. Yeah.
Okay, okay, sure, sir, no problems.
Okay. So so there are already many programs at organization, and I said even at Cadence we have these university elections and taking intern from colleges. It is already there, and even colleges have their collaboration with different companies, right? And as I mentioned, there are university relation teams at all the companies, and entry into companies happens through internship programs and placement drives. Okay, so we have both. We take both interns and we do placement drives. And for resources, internship is very useful resource, mainly for all the companies to build a strong availability of trained engineers. Okay? I think there was a noise, right? Okay. So I was mentioning that internship is very useful resource for companies to build strong availability of trained engineers. Like we should have a pool who can work on advanced advanced tools, advanced nodes, all those things in the semiconductor area. Okay, and all the companies they spend in training of interns so that the students are ready for directly to serve from day one. Okay, so internship is very important. Okay. So if you have to enter into, I would say if students have to enter into companies, you should follow the guidelines so that we can work with your university relations team so that you can enter into company with the internship programs. Okay. And from universities and colleges, if we can train students early during the courses, okay, then companies can utilize students effectively. So right now we have the courses, but I think there is a need for train them on tools or train them on the advanced nodes, means advanced process technology, so that they are available when they enter into the company. Okay? And they should plan courses in conjunction with companies. So all the companies are available to work closely with universities and colleges so that we can create a course which will help companies so that whenever they come to or student come to the company, they will they know what they have to work on. Okay. And one more thing which I would touch upon is that if colleges can give more hands-on on EDA tools, then the gap of quality resources will be solved. We feel that I think when the student comes into the companies, that time we have to spend a lot of time in training them and then providing them the means hands-on experience on all the tools, right? So if college can give some resources so that student can work directly on the actual tools and the projects which companies can utilize. Okay? And practical should be designed keeping in mind the specific domains need in the semiconductor industry. Okay? So for this, semiconductor companies and universities should collaborate to design the practical as per the industry demands. Okay? So this is a collaborative approach, and companies do means to do this means already I know means we provide on uh, design means live design projects to for students. Okay, so while they are working or completing their coursework, they can work on the live projects. Okay, that when student so that it will help when the student enters into the industry, they are ready for work. Exactly, they can work on the projects. And then there is one basic thing which I think which is a very important aspect of semiconductor industry is that we should give importance to the knowledge of basic operating system, mainly Unix and Linux. You will feel that okay, we know the Unix and Linux operating system, but this is very important. In the colleges, we should have a separate trainings on these. Okay, and also on the various scripting languages, because you know, in the industry all the tools or environment, they are on Unix, and mainly we work on the basic scripting languages like C shell, Article, or Bash. Whatever you think, I think you should know what are the scripting language, because all the environment design environments and the tools, they are they work on the basic operating system of Unix. Okay? And one more thing is that these days most universities and colleges, they offer courses in digital design, and they don't give importance to analog. Okay? So analog is also very important, and the availability of analog engineers is very I would say very thin. Okay, so we should give means the colleges should give some importance to analog design also. And I would say in the school days also, if we can start teaching about most basic to build the expertise in the semiconductor system. This sounds very funny, but I think we can do this, because right now I can see in the 11th or 12th standards already we teach students about semiconductors. Okay, so if we can teach something about MOS devices also, that will be very helpful. Okay. And now, as a concluding remarks, I would like to give strength on collaborative system development with industry and university to close the gap of quality resources required in the semiconductor field. Okay. Colleges and universities should design practicals and courses around design and testing aspects also. Okay. And also, since now we know India has started these policies for semiconductor fabrication, right? So we should start working on designing courses for fabrication needs also. Okay? In fabrication, we not only need electrical or electronics engineers, but we need resources in all the streams, right? All the streams of science, and this MPVS is for science only, right? This is a science conference. So we should include all the science field like chemical, physics, mechanical, biological. So in fabrication, we need all of the resources from all the science streams. Okay? And this new semiconductor policy will bring more requirements and opportunities for students in all the streams. And finally, ecosystem, as you know, is a system where even if one part is disabled or disabled, the balance of entire system gets disturbed. So we should work together to build a strong ecosystem. So I hope with this conclave, Madhya Pradesh will emerge as one of the hub for Fab and Fabless companies to come and have their setups here. Okay? And also all the educational institutes should take place to make it happen by providing best industry ready students. Okay. And again, I would like to thank MPVS for inviting me and putting my thoughts with the audience. So this brings to the end of my talk. So thank you everyone for attending this, and yeah, I'm open for questions. Thank you.
Thank you very much, sir. Are there any questions from the audience end? You may put those in the chat box.
Even if there are any questions which you are not able to ask, you can send me an email. I'll share my email address with the IIT Indore and MPBS team. Okay.
Sure, sir, sure. So thank you very much, sir, for this insightful talk. You said it right that MOS basics should be taught in the school itself so that we build a good fundamental concept of MOS, and further ahead we go and develop something for the country. So yeah, that was really indeed insightful. Thank you very much, sir.
Thank you.
Now, for the next invited talk, we are pleased to have with us Mr. Prashant Admane. Mr. Prashant Admane is currently working as Group Technical Manager in HCL Bangalore. He has over 21 years of industry exposure in RF microwave circuit and system design and prototype testing, and also in analog circuit design and analog and mixed signal verification. He also served DRDO labs in design and development of RF microwave circuits and systems while working in Gallium Arsenide Enabled Technology Center, Hyderabad. I request Mr. Prashant to deliver his talk. Over to you, sir.
Am I audible now?
Yes, sir, you are audible.
Yeah. Give me a minute. Are my slides audible? Visible, right?
Yes, sir. Yes, sir.
Okay, yeah. Good afternoon, everyone. So first of all, thanks for MPBS, IIT Indore and other organization for inviting me, for giving a talk and sharing my thoughts. So today I'm going to talk on the need of semiconductor industry, basically with respect to VLSI domain. So as Mr. Bhupendra currently said, like, yeah, we are need of semiconductor chips, and because of that many things are being stopped, like from automobile industry to all other industries, right? So basically we need to think of entering into the VLSI industry. In the sense, we need to tell or encourage the people to enter into the hardware industry, in the sense VLSI as well as means analog, digital, PCB design, all, apart from going to the computer science and all. Okay, so the contents today we will be touching upon the topics are the need of the semiconductor industry, then the skill development, skill requirement for that, then the SOC development stages. We will be just looking after the SOC development, what will be the different stages in that, and few tools and technologies on which currently we are working. Then the requirements, then what is the advantage in MP, the HCS collaborations, and finally the summary slide. Yeah. So need of the semiconductor industry, it shows it basically has, we can divide it into the design houses, then the foundry, then the PCB development, testing houses, like that. So when we say the design houses, it will be the product companies as well as the service companies. Then the foundries, normally in India, we don't have any that big silicon or foundry apart from SCL Chandigarh and a gallium arsenide foundry in Hyderabad. Then the PCB development, for we have quite a few in Pune, Hyderabad, Chennai. Testing houses also we have many testing houses like SPL, TESOLVE, HCL, and themselves. And when we are talking about the other things, so what are the requirements for that? So it goes like this, like there will be the design of the chips. We need to do the design to arrive at some product, then the verification of the designs. After verification, fabrication of the chips, where the foundries comes into picture, then the PCB development, assembly and packaging, and testing. So basically, these are the various stages or steps which are involved to come up with a physical chip or the physical system or any physical product. So when we are saying the skill requirement, the current skill requirement for the market, so again, it is like a VLSI specific. So here I have divided into the mainly three broad parts. Basically, into the two parts, we can say pre-silicon and post-silicon, and the PCB development comes in between of that. So when we say pre-silicon, it means all the activities which are being carried out before the chips get fabricated or the actual chips comes into the market. Okay, so it involves, if we are saying about SoC, which is the system on chip, which includes all the things into a single chip. So digital, analog, embedded, AMS, everything. So it involves digital design, where broadly we can say RTL, it comes like RTL design and a GLS design. Then the digital layout. So whatever we design, we need to put the actual transistors, resistors, capacitors on a wafer. So it comes under layout part. Then verification, whatever we have designed, whether it is giving the correct results or not. Then analog design, where all the analog blocks comes in like a we can see the power management blocks, then the data converters blocks, all related to analog things, analog designs, analog layout, analog verification. So when we say analog verification, it comes like a PVT corner where the process, voltage and temperature that we are going to see in the next few slides. Then the integration. So integration means the integration of digital portion and analog portion, and doing its verification, which comes, we have already we do normally the verification on digital part, the verification on analog part, but after the integration also we need to do the verification. So it comes under analog and mixed signal, which is called AMS verification, where the digital would be in RTL, analog can be on Verilog or VMS or model. Digital can be on RTL and analog can be a netlist. Digital can be GLS and analog can be a netlist, transistorized netlist. Like that, there are various stages. So that verification, and after that, the tape out. Tape out means the data which is going to be supplied to the foundry for the actual fabrication of the chip. So when the chip is getting fabricated, it takes some time. So in between, we need to be get ready with our PCB for the testing of the chip, because chip will be very small. So it will be having some extra off-chip components, and how to provide the supply, then supply connection, then ESD and all like that comes into picture. So for that, we need a PCB. So for that, PCB design, PCB manufacturing, and then the component assembly. This comes under the PCB development. When the chip gets fabricated, so there are again the testing, which we can say the on-wafer testing. But let us say the on-wafer testing is done. After that, the assembly and packaging of the chips. That means the bare chip is getting assembled and packaged into various types of package, which is a twin package or ball array package, like that. After that, the prototype testing, and finally the automatic testing, which is going for the production version. So these are the skill requirements. Means anyone can adopt any of these points to go ahead with their career, because these are the very upcoming fields, and a lot of requirements are there for this. Yeah, so what I was talking about are the different stages here for the SoC development. So when I say SoC, it is the system on chip. So when we are going for the develop any SoC which contains both analog and digital part. So first the requirement comes. So that requirement is getting finalized, and various architectures are getting explored. What type of architecture we have to follow to get the better results, better yield, better efficiency, and meet the market requirement also, time to market requirement also. So various architectures gets explored and finalized. After that, the system level simulation comes into picture, where the blocks are being just replicated by their models, and the simulation is being done to meet the end-to-end specifications and arrive at the individual block level specifications. After that, system or the circuit simulation comes, where the subsystems, we can say like a ADC or a PLL, we can see them as a subsystem, and the circuits like a simple band gap, LDO, such level specification got arrived, and those are getting designed. So when we are designing it, first we need to finalize with the foundry. Then with the foundry, which technology node we need to go, and in that technology node also, what type of a process we have to go, either the generic process or a low power or a high power, like that. So once the process gets finalized, then the actual design starts. So first the design is getting done in typical corner, where the temperature is 25 degrees Celsius and voltage at its nominal state, and the process corner is a typical. Once we get we get the simulated results for that, the performance, then the same circuit is being done or optimized for the PVT corners, where the process voltage and temperature are being varied and the circuit performance is checked. When we are getting our required performance for all the process corners, then the layout generation starts. So this is again back and forth process. The layout, after layout, again the LVS and DRC cleaning is being done. Then the post layout verification is being done. So in post layout, there are very much parasitics are also getting involved in that. When the layout is being done, then that particular, let us say, the devices are being connected through various metal lines. So that parasitics comes into picture. And again, the circuit has to be get optimized for required performance, including all these parasitics. After that, layout modification if required. Then again, the LVS, DRC, and finally the DFM cleaning has to be done. Here, when I say DFM, it means design for manufacturability. After that, the foundry data structures are being getting inserted into the tile, and data is getting released. Then the chip gets fabricated. After the chips getting fabricated, the bare chip testing and the foundry data release comes. So bare chip testing means the on wafer testing, and the foundry data means for this particular lot of the chips, what are the different performance of the various active and passive devices. So once the bare chip and testing has been done, so then the prototype testing, where the PCB and the packaging assembly comes into picture. So prototype testing means only the few chips are getting tested, and the performance is getting compared with the required performance. Then the post silicon optimization if required, like the tuning of the bond wires or the off chip components being done. And if still the performance is not getting met, then the respin means the redesigning with the again slightly optimize or change circuit design parameters happens. If the respin is not required, then that particular SoC or chip or subsystem goes for the production version. So there the multiple chips are getting produced, and those are getting packaged, tested automatically. So again, this is the SoC development points, but in a different version. Right now we have seen with respect to design till fabrication. So here with various verticals and horizontals, let us say if you want to go for full chip SoC, ASIC or FPGA, then there are the various stages like architecture, design, integration, synthesis, and horizontal wise, it contains design, verification, physical design, DFT, circuit design. So when we say circuit design, it comes mainly like a analog and mixed signal design, then DFT, physical design, verification comes like a mainly digital verification, and the design means the algorithm development, reference model, hardware, software partitioning, optimization, like that. Yeah. So coming to the tools and technologies, currently what we are working on. So it is not limited to this. These are the few examples I have given where the tanner is already now the part of the metal graphics. But with respect to CMOS, starting from, we can say the 350 nanometer or 0.35 microns till 3 nanometer. These are the various technologies we are working. With respect to gallium arsenide, from 0.7 till 0.25 micron. And with respect to the tools, yeah, we are having mainly Cadence, Synopsys, Metal Graphics. So Cadence also, there are various suits. I forgot to mention here about the Xcelium. So then Virtuoso is there, very good tool set, Virtuoso. Then the Synopsys also has the Circuit Explorer, HSpice, Star RCX, Metal Graphics, Caliber, EasyWave, Eldo. So these are the few, I can say, the technologies and tools which are being used for SoC or chip development. Yeah. So now coming to the requirement side. So when what are the requirements if you want to go for the talent development? So talent development means we can say the skilled engineers. So we may need incubation centers where we can train the people. So for that we need some space. Then the server computers where the centralized server can be put and tools can be accessed from there. Then the EDA tools definitely will be required because that is a very important part of our design and development of the chip. Then the continuing education program. Generally, it is for the faculty people where they will be given more insight about the current requirements and what is the current requirement from the industry. So this comes under continuing education program and access to the government labs, colleges for testing facilities. Again, when we think about that, so here we can say the requirement for the chip development for the startups. When I say the requirement, it is like a requirement from various institutes, NGO, government organizations, or from government. So incubation center, again, that is will be required. EDA tools. Then the process kit, the process design kits. Generally, it is the data from the foundry to do any design. When I say a chip development, it means it can be a service development, service provider. Mainly, it will be IP development, intellectual property development. So here, from design till we can say the real product, real chip, we can consider for here. Then the provision for the pizza mask or the prototype for the various foundry shuttles. Help in assembly, packaging, and testing. Once the chips get fabricated, we may need help for doing its assembly, packaging, and the testing. Then the help in initial business development, which means finding out the requirement will be done by the startups, but to endorse them or to use their products and make them advertise them for them basically. Then help in providing manpowers, which comes like a graduate, undergraduate, postgraduate, and doctorate from the various institutes, so that they can do some internship, or if they are good and they like the things, they can continue their career with them, and help from the technical topics from the various SMEs, subject matter experts. So here we may need help from experts from the industry as well as experts from the colleges, where they can guide the people or guide the startups whether they are going into correct direction or not. Yeah. So again, coming to the point, what is the advantage with MP, Madhya Pradesh? Why one should start a industry or a startup in MP? So MP has ample of availabilities of the universities and colleges, and that too, it has been spread all over the MP. It's not like on a single area like Indore or Jabalpur, but it is like a spread all over the MP. Then the enthusiastic people in the MP, where recently we are seeing like there is a lot of conclaves and all are going on back to back, even there's a pandemic situation. Then MP is well connected with other parts of the India, with all the routes like air, road, and rail. Then the proactive initiative, which has been already taken by the MP government. Recently, government of India has announced a big budget for chip semiconductor industry, but MP has already doing it from last few years, as far as my knowledge is concerned. Then semiconductor industry is ready to invest in MP. Many of the industries have already approached there, and already there is incubation centers are available. So these are the I can say the advantage which already MP has. So one can start think about coming to the MP. Yeah. Then coming back to my company, what are the various things we are doing? So HCL has various collaborations with many institutes. I have just taken one slide from there. So we are having one collaboration with IIT Madras. We have already signed a MOU with them in 3 areas. So it is a RISC-V based processor, autonomous vehicle, and big data analysis. Similarly, we have taped out SoC on 22 nanometer process of Intel. And here I cannot disclose that much details on that. And we are working with the secure Linux OS firmware with the IIT Madras. So basically, many of these things are going simultaneously, means the team from IIT Madras, they are also working, and the team from HCL, they are also working. So whoever gets the better results, we are discussing them, and accordingly, we are proceeding ahead. So this is the one of the collaboration what HCL has with the institutes. So coming back to the summary, yeah, again, it is a very standard statement. Need to bridge the gap between curriculum and actual industry requirements. Then the provision of good environment for the startups so that many startups can come up. Specialized trainings apart from the regular curriculum that we have already discussed, like, okay, we need to give some specialized trainings, let us say in analog design or analog layout or digital design or digital layout or verification, or even in the testing also, the post silicon testing. Then the emphasis on training institutes to cater the advanced courses. We can give the more emphasis to the training institutes, like to start the training institutes apart from the only IP or service startups. The training institutes can also be a startup which can cater the various advanced courses which are required for current market, and the healthy tie-up between the industry and academic institutes. So that's all from my side. If anyone has any question, please go ahead.
Thank you very much, sir. Any questions from the audience end? Participants may also paste their questions in the chat box. So I don't think there are any questions as of now. So
yeah, if
I
anyone
would really
has,
like...
they can post. Yeah.
Sure, sir. Sure,
Yeah.
sir.
Thank you.
Thank you very much, sir. This was a really informative session. You told about internship opportunities for students, which will be really beneficial for them. And also you explained in depth about the SoC development process, and it was really exciting. Thank you very much, sir.
Yeah, thank you. Thanks a lot.
Thank you, sir. Moving ahead, it's my pleasure to invite Dr. Mukesh Kumar for the next talk. Dr. Mukesh Kumar received his MTech degree from Indian Institute of Technology, Kharagpur, India in 2004 and PhD in Integrated Optoelectronics in 2009 from Tokyo Institute of Technology, Japan. He had been in University of California, Berkeley, USA as an exchange researcher. He was a JSPS postdoctoral research fellow in Tokyo Institute of Technology, Japan. Currently, he is an associate professor in the Department of Electrical Engineering and head of Center for Advanced Electronics and Indian Institute of Technology, Indore, India. His research interests include integrated optoelectronics, nanophotonics, semiconductor optoelectronics, and nanofabrication technology. He had also been working on some sponsored projects funded by the Government of India and has published over 70 research articles in journals and conferences of international repute. He's a senior member of IEEE, a regular member of Optical Society of America, and Life Fellow of Optical Society of India. I cordially invite Dr. Mukesh to deliver his talk. Over to you, sir.
Yeah, thank you. Thank you for the kind introduction. I hope I am audible and my slides are visible.
Yes, sir.
Okay, thank you. So is it visible now also?
Yes, sir.
Okay, fine. So thank you so much. So, I'll be talking about, some of the activities and giving you an introduction of, about our Center for Advanced Electronics, which was, I think, established sometimes back in, I think 1 year back at IIT Indore. So I'll be giving an overview of our research and academic activities. So this center, which we call CAE, it was established as an interdisciplinary research center at IIT Indore. And under this center, we aim to develop devices, smart materials and technologies for just take one. Yeah. So for computing, this is one of our applications for advanced digital memory and for communication and interconnects, for medical applications and biochemical sensing, and for energy applications as well. So we are going like this, that we would like to come up as a platform, which will enable applied research in electronics and allied areas, and especially in the area of advanced semiconductor technology, and also a platform for a device development for multidisciplinary applications. So, and another thing which we strongly look at is skill and manpower development, which is, universities are quite, normally they are meant for that. So again, in electronics and semiconductor technology. So we are also, pushing our outreach activities as internship opportunities in electronics and its allied areas. And also, as we all are aware that, universities, in addition to giving out, the manpower to the industry and other sectors, we also, provide ideas, innovations, where you're for the development, especially how do we look at it in CA is ideas to innovate, to innovate the device and system for improved performance. That's how we look at it. And as I mentioned, that we are very strongly pushing our outreach programs in form of summer and winter internships, and for especially for internal as well as external BTech students, they're also welcome. And also we provide thesis guidance for MTech students or MS students as well in the same areas. And also we are also welcoming the external faculty members and scientists for their help. If we can support their research in somehow, they can use our facilities here. So another form of our outreach programs is we are like the faculty members at IIT Indore, especially in CA, we used to give a lot of lectures to other institutions, and also we are organizing number of faculty development programs, short-term courses, and so. And also this is new, we will be doing very soon hands-on training to our whatever machines we have in related to electronics or semiconductor technology. So we'll be providing those hands-on training. So these are the research areas in CA which we are working on. For example, we are into this nanoelectronics, and also integrated optoelectronics and silicon photonics. In semiconductor optoelectronics, advanced materials and devices, biochemical sensors, photovoltaics, advanced memory technology, signal processing, and wireless and optical communication. And recently, we are in planning phase to develop, a facility for nanofabrication, which may be a national facility for device fabrication in central India. So this is, I mean, nothing has came out yet, anything, but it's in planning phase yet. So we have a number of faculty members with diversified background. Like we have people from electronics, electrical engineering, communication, from physics and computer science, and some other with some other background as well. So we are one of our primary research theme is in advanced semiconductor technology. For example, we are working on engineered or hybrid semiconductors where we not only silicon but some other best-in-class materials, like we are working on gallium nitride, some other second floor materials, as well as for uh, for uh, for making devices for different applications. So we are designing those devices and circuits. We are fabricating them partially, and then the applications of our research is, again, I already mentioned it, in computing, the memory, basically advanced memory, communication, interconnects, and so on. So in a nutshell, we have a lot of happenings in the semiconductor area in CA. So because we understand this semiconductor area, is very important, right? So this semiconductors, they are the backbone. They had remained at the backbone for many different aspects of our human life. So this is about the how electronics and computing have evolved. So you see here, this is, you can consider it as a first computer, which was ENIAC, developed by or financed by the US Ballistic Research Laboratory. And this picture shows you our very kind of first, you can consider the first computer in India, which was in TIFR in 1960 or so. And this is these three giants here who invented the first semiconductor-based transistor. So those because of that, the semiconductor devices have replaced almost all the vacuum tubes which were there before. And your semiconductor technology is the backbone of modern electronics or computers. And the key here is in semiconductor technology. The key is miniaturization and large scale integration, which is possible, which is one of the important properties when you look at the semiconductors in form of integration, right? So, and this area is not just electronics. It's hugely interdisciplinary. It has widespread applications, and I don't need to explain things here. So whenever you think of anything, putting some intelligence into your machines, automation, and so on, you need to have chips, you need to have processors, microprocessor, microcontroller, and they are based on semiconductor chip, right? So I mean that's why people call it huge interdisciplinary. It has widespread applications, correct? So some other speakers have already touched about the importance of the semiconductor and the market here. For example, we have there are top companies across the globe like Intel, Qualcomm, and NXP, Texas, and lot more actually, not only these. So they have with respect to end use, they are delivering. For example, the end use can be military and civil, and automotive, industrial, consumer, and some other applications, data processing, communication, and so on. So the semiconductor has the market. It remained hot, and it is still hot, right? So if you see what are the demand drivers, for example, you see here one of the big portion the big driver is computers basically, and then you have the communication, which is around 32%, which is a little older statistic, but still I think it's valid. And for government enterprises, it's 1%. For automotive, it's 12%. Industries, 12% around, and consumers, 12%. So these are the semiconductor demand drivers, basically, right? So looking at that, looking at the semiconductor market and how it can drive the whole economy. Very recently, the government of India has come up with its semiconductor mission, which is called India Semiconductor Mission. Of course, the government has been trying it since long, but it looks like uh, it has come up aggressively now. Like there are some national initiatives under that, so there will be few semiconductor fabs and display fabs, and under that, there will be the establishment of high-tech clusters in that area, and also improving upon the research ecosystem where IITs or other academic institutions can play a very important role here, in building this kind of research ecosystem. So, and the one more initiative is they want to modernize and commercialize semiconductor laboratory, which is owned by ISRO. So I think that is one of the plan. And also one option the government may consider is the joint venture of SCL with some commercial fab like maybe TSMC or Global Foundry. So these are the some of the bullet points, where like compound semiconductors, silicon photonics, sensor and MEMS, and semiconductor design. These are some of the bullet points which are usually highlighted in that mission. So the essence is that the government want to propel the innovation. They want to build the domestic capacities so that we have more digitally dependent thing in India. So it will have a multiplier effect on among all the sectors of the economy. So in CA, we are also looking very close to that, and we are trying to contribute in that direction in our many different areas. Advanced semiconductor technology is one such area. So we have recently taken some initiatives in CA. Some are under planning, like capacity building in the semiconductor technology. That is one we are looking at. We already have some facilities in this experimental and as well as design facilities we have. So we are improving upon that by we are drawing funds from the government and industries, and we are looking into that. Another thing which we are doing is manpower generation, because I think that is the main thing which we should do, which will cater to the national semiconductor needs. Like we have recently proposed PhD program in advanced electronics, which is successfully running now, just started. And also we would like to propose in near future an MS research program, 2-year MS research program, which will have more research focused master program, PG program. And also we are planning to propose one MTech in semiconductor technology. It's a kind of interdisciplinary program. Maybe CA and a few other departments may participate in that. And the one more unique thing which we are looking at is electronic waste into research, which is in planning phase. We have so where we would try to look at the scenario where we have electronic waste, some kind of, and then we use it in our research, because now also in our research we use silicon wafers and some other consumables and other stuff. So we would like to see the possibility of electronic waste, use it for our research, so that we can contribute and we can come up with some prototype devices. So what is our strength? So we have highly qualified faculty members with very long international exposures. So we have published quality research publications and patents. So the faculty members have huge amount of external research funding with them. And we have best-in-class research facilities, which is world-class. And we have excellent research outputs in semiconductors and some other areas in electronics, basically. And we have very strong international research collaborations. So with our strength, we would like to see ourselves as and make our center as a semiconductor technology hub in central India. So I hope, I think within 4 to 5 years, we'll be able to do that somehow. And these are the research laboratories under CA. We have optoelectronic nano device research laboratory, which is my lab. Then we have nanoscale devices, VLSI cycling system design lab, which is Dr. Santosh Vishkarma's lab. And we have this hybrid nano device research group. We have signal and software group, signal analysis research lab, materials and device research group, nano and energy materials laboratory, and this condensed matter physics lab, then advanced engineering lab, and supramolecular chemical. So we have diversified areas, and because of this, there's diversific, fields, and many of us are into semiconductors partially. So I think we will be able to contribute effectively for the semiconductor technology hub. So just very quickly to introduce, so like this is my lab, which is known as Optoelectronic Nano Device Research Laboratories. We're working on semiconductor optoelectronics, silicon photonics, and nanoscale devices for advanced memory and computing sensors. So we have developed and we have developed and demonstrated number of devices for different applications, especially for optical fiber communication and for memory applications. These are our research facilities. If you are interested, then any kind of help or support which we can provide, so you can just look at our web page. Then we have another laboratory, which is supramolecular chemical nanoscience group, which is led by Dr. Purva Das. He also have facilities in materials and organic things, I think. Then we have this materials and device laboratory here, which is led by Dr. Rajesh Kumar in physics. And then we have a hybrid nano device research lab, which is led by Dr. Shabir Mukherjee. You can, if you are interested, then you can always go to the concerned faculty's webpage or CA webpage. You can find this thing here. Then we have this condensed matter physics laboratory led by Dr. Pakhira here. And finally, to summarize, so again, I welcome on behalf of CAE, if you are looking for internship opportunities in electronics or semiconductor area, you are welcome. If you are MTech and looking to do your thesis in that area, we are also open to that. And we are also, as I already mentioned these things, giving research support to external faculty members, and also planning to have hands-on training very soon. So thank you so much for your kind attention. If there is any question, I will be happy to answer that.
Thank you very much, sir. Audience may put their questions in the chat box. Sir, I think as of now, we don't have any questions.
Okay.
Sir, thank you very much. You have walked us through so many different technologies of semiconductors, and you have walked us along the evaluation as well as some national initiatives related to semiconductor technology. It was really an insightful talk. Thank you very much, sir.
Thank you so much.
For the next talk, I take the privilege to invite Dr. Siva Ramakrishna. Dr. Siva Ramakrishna Vanjari completed his PhD in Indian Institute of Science in 2012 and is working as a faculty in Electrical Engineering, IIT Hyderabad ever since. His primary interests include, but not limited to, electrochemical sensors, biosensors, MEMS, and most importantly, VLSI technology. He has a good number of publications in those areas. He is one of the key members in the national initiatives of the promotion of startups in the area of fabless chip design. He's one of the founding members of the Fabless Chip Design Incubator, Fab CI. This initiative is aimed at incubating 50 companies exclusively in the chip design space. He will share his experience regarding the same in this talk. I humbly request Dr. Siva to address the audience. Over to you, sir.
Are you able to hear me?
Yes, sir.
Yeah. So thank you for this opportunity. I'll quickly go through the presentation and we can actually have a lot of discussion thereafter. You're able to see my slides, right?
Yes, sir.
Yeah. So see,
Sir, I
Fabless
would
design-
request you to make it a slideshow so that it would be more prominently visible.
Okay, clear?
Thank you, sir.
Okay, so this Fabless Chip Design Incubator is a one of its kind of incubator started by Ministry of Information Technology, and that is being executed by IIT Hyderabad. The objective is to actually incubate world-class startups in the space of chip design. And we envisage ourselves to be one-stop incubator for startups in this particular space. The offerings that we have for these companies is design tools plus fabrication facilities plus characterization, right? The target is to actually have 50 companies over 5 years, which is we are actually aiming at the sky and hoping to reach at least the top of the tree. And we have actually facilitated virtual incubation, and from FabSay, we would like to see at least one unicorn that's actually coming out, right? Now, just a history in brief. We have actually submitted this proposal in 2014, way back in 2014. And then we got the approval in 2016. And by the time we launched this officially, it was 2018. So there were, there were actually rigorous negotiations involved in EDA tools that took a lot of time. And because of that, we could actually not launch it very quickly. And after that, what we've actually done is we have incubated almost like 10 startups in this particular space. The success story is always what we are actually proud of. We have, through FabCA, we have actually done a first of its kind 5G NB IoT chip in 45 nanometer technology that is useful for in near band IoT applications. Okay, and the plans are there to actually go to volume production pretty soon. Now, certain companies, they have actually focused on analog mixed signal space, and then after that hardware accelerator space. There is a company which actually has looked at critical path optimization. That's the name of that company is Banashri. And we have a body-to-board communications company wherein the data transfer, they have actually demonstrated through body. I mean, in the sense that you have actually seen wireless communication, wired communications. The transmission of data was actually carried out through body, okay, from hand to hand. Now they have actually received the BRICS funding, and they're actually reasonably doing good. And the market right now is actually focused on power management ICs, and Professor Kader Khan has actually started a company in that particular space. Now we are encouraging startups in AI, and 2 companies have actually gone into this particular space. Now, and then there are people who are actually working on NAVIC-based systems and also energy harvesting systems who have actually recently joined us. Now, this is the journey thus far. And I would actually reiterate that this has been more cherishing and challenging. And we cherished the journey throughout. And I'm proud to say that we have actually scouted these companies out rather than the companies approaching us. We went all the way to every place, explained and forced ourselves in, explained what we are actually doing, and then got them on board with, with 0 conditions, right? So it is high time, given the initiatives that are taken by ministry right now, it is high time that we increase the number of companies, we actually boom these companies, like a share market, right? Now, in that particular regard, we have actually collaborated with NXP Semiconductors, and despite pandemic, with a 1 year of effort, we have actually launched a joint program. It's called Semiconductor Startup Incubation and Acceleration Program, wherein startups were actually asked to apply, and we have finally shortlisted almost 8 people. And these are actually judged by well-known people in who's who in NXP and VCs and all those big shots who have actually judged those companies. And then 8 companies have actually started, and 2 of companies are the incubators of FabSi, and the rest of them are actually companies who are running their shows, and we are accelerating them. Right. So far, thus far, the story has been the total numbers that we have actually hit is 16 out of 50. So we are actually at just a pass mark. So we have to actually get it to the 100% level. So what is it stopping us from doing it? I'll explain it in a moment's time. But I mean, the reason why I actually like this forum is that I just wanted to promulgate what we have actually done, and there should be a regional ecosystem everywhere, whether it is Andhra, Telangana, or whether it is Madhya Pradesh or any other place. So you have to actually have a local ecosystem fostering, and after that, the goals of the local ecosystem should actually drive the environment here, right? So with this background in mind, we have actually done a consortium of Telangana state government, IASA Hyderabad chapter, and FabSi. The idea is to have an innovation center which could actually have all the facilities that are required for chip characterization. And given the ecosystem in Hyderabad, we are actually pitching into these companies and asking for contribution. And hopefully, we're going to succeed in less than 1 year's time. The whole target is group of regional systems can actually go into a global system rather than one person leading the show. So it has to be different clusters, and the different clusters have to work together in unison to become big. So let's actually dream big and let's actually work together. Okay. I mean, one thing, the 3-letter word that we have to actually leave in this particular space is EGO. So when we actually let it go, right, we can actually progress, right? So let's do that. We are all for working together, and let's work together on this. Okay. And we have actually done social media initiatives and so on and so forth. Now let's actually deliberate on what could be done and what is it actually that's stopping from people. Now, given this particular scenario, let us say you compare it with a software engineer or an AI engineer, right? So what they would actually do is they'll actually go to a simple, you start after BTech, there are not much of a milestones. They'll actually come back to the finish line. They'll get a lucrative salary, and that's why everybody wants computer science engineering or the AI engineer. I mean, without knowing what it is, the only goal of those people is to actually get into this space. Now, to do a real SI design engineer, you have to actually do a high-level design. Unless or until you do a tape out and validation, you cannot actually understand this space. But the whole point is, once you actually get the full subject knowledge, nobody can actually beat you, right? I mean, this is a niche space which you have to actually master. It is time that this niche space is actually converted into propagated across and make it less niche in some sense, that more and more people actually come in. Now, if you look at it, why does fabless startups not succeed to that extent? The reason for that is, any IIT Indore or IIT Hyderabad graduate with an MTech in microelectronics would actually demand a package of no less than 20 lakhs. Imagine I have to run with the company with 5 people. I mean, that's the minimum requirement, right? So I need 1 crore of investment per year. Where do we actually get it? Right? And after that, 28 nanometer tapes cost you something like $30,000. Where is the money? Right? We can actually pitch into that particular space. But again, a combined effort is actually required. Now, the important point that we need to know right now, which we can actually play on, is that system perspective is essential for chip design. I mean, gone are those days where Pentiums and Celerons are actually being treated as the eighth wonders on the earth. Right? I mean, there were launches which, a decade ago, launch of an Intel processor was an event. It's no more an event anymore, right? So they just have an advertisement saying that we have actually launched a new processor. So building the system around it, so designing novel systems, and then based on it, designing an IC is the way to go forward. And in that particular space, each and every one of us can actually pitch it. And you come up with an idea with all the network that we have, will definitely ensure that all of us are successful, right? So let us actually work together to get the success, right? So any acceleration program, system level acceleration program gets almost like 400 to 500 applications, but not even 50 companies are there across India who can do chip design. So this space has to expand if India were to grow in the next decade. So the entire efforts of the ministry are actually focused on this. So let's actually work together on this particular aspect. Now, whom do we target? So we have to actually target academicians are, sorry to say, are the persons who can, who are not expected to do a startup in this particular space, but we could actually help them out. How do we actually help them out? Let us say that we actually throw some challenge, ask them to design some repetitive chip that are being imported in millions, right? And then, we have taken that task, and in a month's time or two, we are going to get a challenge wherein we will give the set of specifications and we'll ask you to design this. And then after that, once the design is validated, we would actually work, let's actually work together to just take it to volume production, which is the big step. Okay. So the other thing is we could actually identify masters who are actually working in the companies who have, the fat salaries, and at the same time they have neck on their knife, right? So just let's actually propagate that there is a conducive ecosystem. You can do your product, we are behind. So hopefully they'll actually come out and start companies. Again, we should actually look at IP creators who have actually done enough in this industry. They have created an IP and they have ideas, right? So the competent people are there, the masters are there. Now, for us, the challenge would actually come in the next 2 months. We will actually throw a challenge to all the people saying that, look, please design and we'll help you prototype and then characterize it. So once it's actually done, the sky is the limit for you. And let's actually replace brick by brick. Let's actually replace chip by chip from to the parts that we're actually importing, right? We could actually do it, right? We should actually do it. There is an iota doubt that we can do it, but we should do it is what we have to actually look at this particular point of time. Okay, so the queries that we have is how can we actually attract talent from Silicon Valley? That's one thing that we should also keep in mind. So given the ecosystem that we are actually putting in, if you want to have early returns, we should actually not, rule out those people. And then longer nodes reaches wider. So, in the sense that let's not actually be finicky about 7 nanometer, 28 nanometer, 65 nanometer. Let's actually say there are several products that we can actually do at 0.18. What are those products? Just give us some time. In a month's time, I think the efforts that we're actually putting, we would actually list out the 10 products with the specifications, right? So we will actually make I am possible, right, instead of impossible. So that's what I would actually passionately put forward. So with this particular small introduction about a FabSA, I would like to actually listen to queries and listen to views from others, right? And please ask me any question, I'll be able to answer. Thank you.
Thank you very much, sir. Participants may ask their questions, if any. Sir, I don't think we do have any questions as of now, but surely we'll go through the details of FabCI because it was really an exciting story about FabCI and I personally would also like to go through it and contact you in the coming future.
Sure. I mean, my WhatsApp number is available anytime. So you could actually, don't worry about websites and all those things. Email and WhatsApp are the ways to go forward. Okay. Just contact us.
Thank you very much, sir. It was a very insightful talk. Thank you, sir.
Thank you. See you.
Now, moving ahead, I am honored to invite Mr. Arvind Srivastav for the next keynote invited talk. Mr. Arvind Srivastav has more than 2 decades of experience in semiconductor design and development. He's working as a director at AMD. Prior to joining AMD, he has worked at Synapse Design Innovation, Broadcom, and ST Microelectronics. His areas of interest are SoC design, team building, and customer engagement. He has a master's in microelectronics from IIT BHU Varanasi. He holds 2 issued US patents in the area of SoC design. I would humbly request Mr. Arvind to address the gathering. Over to you, sir.
Thank you very much for the kind introduction. Let me share the presentation. Thank you. Good afternoon, everyone. And before I go into the details of the presentation, I've been attending this session since morning, and there has been very insightful discussions. And I think my presentation today is an extension of what has been discussed by the speakers before. Before my presentation, Professor Siva Kumar was there, and he was emphasizing what they are achieving with the Fab C at IIT Hyderabad. Before that, Dr. Mukesh Kumar also talked about the opportunities available at IIT Indore. And before that, Naveen from Marvel was giving a overall high view of the ecosystem. And then Amit from ARM also talked about the opportunities which makes things possible, right? Typically, the semicon design space is supposed to be very challenging in terms of taking an initiative, but all these discussions so far give the direction, and opportunity is there definitely. And so my talk is more about this is not this is a problem which I'm going to talk about. This problem exists, has been there for a long time, but probably now is the right time to have a closer look at the problem and try to find a solution to it. So I'm talking about this presentation about the SSD, and typical SSDs are these are the storage devices, and typically we have been using the parts and components which have HDD hard disk controllers, and solid state drive controllers have been replacing them. There is a good reason to do that. The hard disk controllers, there is a rotating media, a disk is rotating, and then there are sectors and tracks on the disk, and the head, the actuator will go there and put the head and do the data reading. This is a very sophisticated mechanics here, but these are slow devices. These are noisy, consumes a lot of power. So the access time, if you look, the fastest with the maximum RPM could be around 2 milliseconds, whereas SSD could give you same thing in microseconds. IOS, there is a tremendous improvement. So this is the the topic of my discussion, and SSDs, they offer the improvement in terms of speed, the lifetime cost. So the cost of HDD as a product could be smaller. It's definitely cheaper than the SSD. But if we look at the cost of the bandwidth which SSD can offer, this is definitely cheaper in the long run. So dollar per IOPS is much better on the SSD. Power consumption is much less. There is no mechanical rotational media, right? And manufacturing strength is the main driver. A typical, an SSD system, which includes a controller and a NAND flash memory, will have a 20:1 ratio of the flash and controller chips. So, the driver for this technology is the NAND flash manufacturers. Reliability is a concern though here. So we'll talk about that in a while. And why this is more relevant, today, because the kind of applications and especially through the, after the pandemic, what we have seen is surge in the online activities. So, data center and demanding enterprise applications require faster and higher data transfer rates. That is e-commerce, online transaction processing, data mining, cloud computing. That is one reason. We need a good storage system. Client applications, we want a faster response time, less power, longer battery life, and we want a smaller form factor. That is there. And then mobile applications, we want as small as a form factor possible. So, the size is very important here. So, mobile applications is also driving that interest. Let's talk a little bit about the NAND flash. NAND flash is a non-volatile memory. What does that mean? It retains the data when the power is removed, and the data can be electrically erased and reprogrammed. Program in the read time are in microseconds, erase time in milliseconds. This is a typical structure of a NAND. You will have these package balls here, substrate, and NAND die. The connections to the package and die will be made through a wire bound or some other sophisticated technologies. And then the molding will be done. So this is a standalone NAND flash. In the some other applications, we could have a NAND flash and a NAND controller sitting together in a die. That is also possible. And a typical NAND flash memory itself will have multiple dies stacked vertically on top of each other. That's how it gives a good capacity. So that is about the NAND. The smallest unit, of course, is a memory cell, which consists of a FAT with 2 gates. Floating gate is the storage element, and electrons, when they get or removed from the floating gate, that results in the shift of the VT, and in that way the cell is going to store a 1 and 0. If the cell is just storing 1 and 0, this is a single bit. It stores 2 bits per cell. That is called the MLC, or it could be TLC and QLC and so on and so forth. The challenge which comes with the multiple voltage level, that the VT delta, right, between the 2 voltages is reduced. The threshold is more tighter, and that means the endurance is a problem, right, as you increase the number of bits per cell. But it gives you a lower cost and higher density, right? And the performance will be also less. So performance, if you want higher performance, you would go with SLC. If you can compromise on performance but want a better cost, you can go with TLCs. This is how a typical memory cell will be put into a string, and then strings are put together, and the smallest unit is a page and block, and then those blocks make a plane. One die will have multiple planes. One chip will have multiple dies. This is how a typical NAND flash looks like. This is a logical view of the memory. So we will have the what is of interest here is we will have the memory cells here, which for example in this case it is a 512 byte. The 16 byte here is for the redundancy. So this media, there could be different kind of errors on the flash memory, and it may corrupt some of the bits. That happens. These bits which are extra, they come in form of the redundancy and allows this to be functional for a longer duration. So this adds to the reliability. These are the different error types which we typically see in the NAND flash. which are, few are operation related. So we will do read operation, we will do erase operation, and we will do programming is essentially the writing to the flash. And then there could be retention errors because the cell may be losing charge because of some leakage through the electrodes. And then there could be, when we do these operations, there could be disturbances related to that. So those some failure mechanisms are there. These failure mechanisms are, measured in terms of the raw bit error rate. This is the, the reliability measurement criteria. And error rate will increase the technology. With the technology, we will be compressing the voltage, right, of the operation of the memory cell. So that means, there are more chances for read disturb or program disturb, these kind of errors. And it is also depending on number of the program and erase cycles we do. And, the more we access, the more the problem is. But why we choose it, there is a viable option due to high memory capacity in terms of the cost. So we can add as many pages per block, and that will reduce the die size. Smaller tech nodes help to condense more storage on a given area. Okay, and the raw bit error rate is increasing. So in the flash controller need to do a lot of management to make sure we make the data safe on the memory. We will talk about that in a while. So this is a typical SSD controller architecture. We will have the host processor on one side, and this is my SSD controller chip. It has primarily three interfaces. One is the host controller interface. Other is the DDR interface, which this external DRAM memory will act as a buffer or a cache. And then we will have multiple channels of the flash sitting on this other side. We will have a lot of embedded processors, which will be responsible for managing the queues of request which is coming from the host processor. And they are also responsible for managing the transfer of data from host to the flash. And they also are responsible for managing the flash itself. Okay, on the host side, we have, so this is my host. On the how it connects to the NAND flash controller.
Sorry
there are
to
two
interrupt you, sir.
Yes, ma'am.
Sorry, sir. Sorry to interrupt you, sir. We are just running a bit late. I would request you to go through quickly if possible.
Sure. Let me expedite. Okay. So, so this, the SAT, the flash controller will talk to the host through the, three protocols. That's SATA or PCIe. SATA is a slow interface, so the latency will be higher there, and it has less number of queues, and that's what slows it down. When we go to NVMe interfaces, which are available on the PCIe, we can have more number of queues, more commands per queue, and higher number of interrupts, so that helps to expedite the transaction. I will skip a couple of these slides. Okay, let me go to the main idea. This is just talking, how many interfaces we have, what they typically will do. Let me quickly go through this. So when we have multiple queues coming from the host side, right through the NVMe interface, I can digest more queues. And then what we do on the other side, we try to do the interleaving of the data on the flash side. So we will address multiple flash dies in the chip, multiple chips per channel. That will help me to increase the data flow on the flash side. Okay, and so the firmware will, what it does, it tries to make sure that the look and feel of the SSD controller is same as the HDD controller was. So we can do a hot swap of a HDD storage media with the SSD storage media. So this is how it manages the command management. Okay, this I can run through. This is a good slide. So when we do a write to a NAND flash memory, you know, for a software point of view, it is just a write. But what typically flash will do, if I'm trying to write in this block, what it will do, it will read this, put that into the DDR buffer, and then it will erase this page. And then the data in the DDR buffer will be written, and then it is copied into the flash. So it is a complex operation. Okay, and because this through this operation is write requires a read, a erase of the flash memory, so that means it affects the endurance of the memory. Okay, that's where buffer cache comes into picture, right? The multiple use data which is frequently accessed can be moved to the cache, and it helps to increase the bandwidth and also improve the reliability of the system. Okay, now this is what you know is the main thing. I think I should go here. If we look here, the red curve here is showing the data rate of the I/O, and the blue line here is showing the compute power of the SSD. So what does that mean? The bottleneck here is the I/O bandwidth. So SSD can do more than what I/O it is using for, right? So that gives an opportunity to make this SSD smart. Okay, and by doing that, we can do what we are essentially doing. We are offloading some of the compute which host is doing to the SSD, and when that happens, you know, it allows us to do even more on the storage side, because then the host can pump in more commands. Okay, so this is helping. This chart is showing the digitization, you know, what we are doing and what is the contribution of the HDD, SSD, and other type of storage media. The price wise, you know, SSDs are no longer an expensive option if we look at the dollar per bit, right? They crossed at this point of the time on that ratio. Now, what we can do, you know, a lot of traffic is through the internet, right? We do searches, we do e-commerce, we do social networking, and these are the data structures we are playing with. Through a smart SSD, we can do the commands implemented and the algorithms implemented in the hardware, which are optimized for searches, social networking applications, e-commerce. This helps to make the SSD even more intelligent, right? And these are some benchmarks from this a framework of near data processing on big data, right? So on the e-commerce side, we see huge improvement on the performance if we are using a SSD controller versus a normal SSD. On read bandwidth improves significantly. Search times improves also significantly, and energy consumption is reduced due to reduced execution time of the all these applications. Okay. Power improvement is there when we are doing a lot of searches. You know, in the beginning, because we are doing a lot of compute, you can see a surge of power, but then the power settles down on a smart SSD, whereas a conventional SSD has more power through. Okay, there, and this is also very good for sparse data applications, security related, you know, phishing attacks, fraud, you know, illegal transactions, lot of medical applications, movies, IoT, ADAS, right? A lot of this is going to be helpful in this kind of application. And yeah, this slide is showing, you know, this is the bottleneck. On the flash side, I can add so many flash channels and give the storage, but on the host side, we have a difficulty because the PCIe will go at a certain data rate only. So IO is a bottleneck here. And to address that bottleneck, what we can do a smart SSD. We can add local processing that will offload host. We can do compression, which is, we can use a open source compression algorithm, right? This is available from Facebook. That helps to reduce because when you compress, you will, you know, you will use less bandwidth, right? So it will reduce the host IO bottleneck. It will reduce the power because we have less transactions. And when you do that, you can need more channels, right? Because now the same bandwidth you can use to pump in more commands. And because you are doing local processing, you can do more accesses to the NAND flash interface. So it helps to reduce the storage capacity, and that helps at the end to improve the dollar per bit as well. RISC-V can be used as a processor here, which is open source. So again, this reduces the expenses, right, in this kind of chip. No royalties with that, and of course, local processing helps with the power as well. We can do error correction, and that it's very critical because we are sending data here, so we need to have error correction and protection mechanism. And that helps us to use we have a better strategy for error correction, right? That helps us to use a cheaper memory. So I can use a QLC, where data retention endurance is lower, but if I have a better mechanism, I can take that risk. And also, if I can do that, I can open my avenues to use other memory, not only the NAND flash. I can go to 3D expand, mem register, or phase change kind of memories. So this opens the new avenues for this kind of application. And then at the end, what benefits it will offer? It is low-cost development. It reduces royalties, so open source architecture. Overall BOM of the product goes down, and that enables competition for the NAND flash manufacturers. Storage on performance, that is the equation now. So far it is capacity, so that the market dynamics could be changed. We offer improved performance and power ratio could come, and the bottleneck on the network bandwidth, is reduced. And utilization of applications like host server will significantly go up, right? So this is one idea which I wanted to share, and this is something which probably there is a lot of open source areas available, and this could be a good project for students probably. Okay, that's all for me. Any questions, please?
Thank you, sir. Any questions from the audience end? So there are no questions as of now, and not there in the chat box as well. So
Sure.
I would
feel free to reach out to me.
Sure, sir. Thank you very much, sir, for sharing some valuable insights with all of us. And due to time constraints, we could not go into the depth of the presentation, but it was overall very nice. Thank you very much, sir.
Thank you very much. Bye-bye.
Now, I'm pleased to invite Professor R.S. Gamad for the next invited talk. Professor R.S. Gamad is currently Professor and Head EI Department at Sri GS Institute of Technology and Science, Indore. His research interest is in the field of analog and mixed signal VLSI design and ADC design. He has published various research papers in renowned journals and conferences. He has worked in various projects funded by SMDP and Texas Instruments. He has also published a chapter in the book Advance in Electronics and Communication Engineering in 2020. I cordially invite Professor Gamad to deliver his talk. Over to you, sir.
Thank you. Thank you so much. Okay, thank you so much, and very good afternoon to all of you. Am I audible?
Yes, sir, you're audible.
Okay, very good afternoon. So today's talk, which is the established collaborative ecosystem in MP. Okay, so I would like to share a brief about the institute and department, those who are generating the manpower for the VLSI design and semiconductor and VLSI design. So here I go through my slides. Okay, about the institute, GS Institute of Technology and Science Indore, which was established in 1952. And it has ranked top institute in MP since last 35 years. Okay. All India Council for Technical Education AICTE and University Grant Commission UGC, New Delhi has declared the institute as autonomous in 1989. In the year of 2020 to 21, institute NIRF rank is 181. Okay, facilities in the institute. Presently, the institute offers the 10 UG courses and so many PG courses are there, and there have the 22 specialization in various discipline, and applied sciences and computer management, pharmacy, and so many other courses which is running by the institute. Well equipped laboratory in the institute, sports complex are there, hostel facilities for the UG and PG students are there. Institute has the central library, which has the vast collaborative collection of the books, and a reference library, also a large number of books and subscription are there. Institute also having the unique ambient like center for the innovation, design and incubation center. I think this is the second one incubation center in the MP. And about the Department of Electronics and Instrumentation Engineering was established in 1989, comes out as an offering the electronics and instrumentation engineering, numerous development in the field of the instrumentation. And also the department has started a one PG courses, which is the microelectronics and VLSI design. And the department has the lot of facilities in the laboratory for the UG and PG students are there, and so many sophisticated instruments are also available in the laboratory. And initially the intake was the 60. And so many students from our department under the PG program have done the lots of project with the collaboration of the RRCAD, IIT Indore, IIT Guwahati, and IIT Roorkee also. And really we are generating a manpower in a microelectronics and VLSI design, and they are doing a very good job in the various fields. Actually, so many students have taken the admission for the higher studies in the IIT and NITs and various IISc Bangalore also. So we are doing a very good, I think, for the MP, for generating the manpower, developing the skill for the semiconductor and VLSI, microelectronics and VLSI design. And in this department, actually, I am guiding PhD scholars are there. 3 PhD has been awarded under the supervision of me, and 10 in a progress. Okay, and other than, I think so many research facilities are there in the department. Actual my research lab is there, major equipments are there. Yeah, department library is there, research lab is there, major equipments in a laboratory are there, RF analyzer and so many other devices are there. And we have a very good advanced VLSI design laboratory for the developing the design actual or testing of any device which is implemented in the cadence, synopsis, mentor graphics, and other hardware. We have also so many FPGA kits, latest kit are there. So that's why we have a lots of facility in a microelectronics and VLSI design, and definitely we are generating the very good manpower for the other institutes. And really, we are also running the SMDP project, which was funded by the Ministry Government of India, and we have received the lots of grant in this under this project. Okay, the project was started in 1999 to 2005. First phase was there. Second phase, which is 2005 to 13, is there, and we have received lots of rupees are there in crores. And after that, we in the institute has two phases for the technical education quality improvement program. Also, the student receive the so many grants are there. So these are the facilities here, and student achieved, that is the placement record in our institute, and our department is doing a very good in a placement also. In a current year, our student has got the 27 lakh package, annual package at a UG level, and I think around 11 lakh in a PG level. So I think our department is doing very well, and definitely we would like to contribute with the other institute in a collaboration of IIT, NIT, and industry are there. And we have required support for the ecosystem itself in MP. The financial support required, collaboration with the IIT, NIT industry and other university is required. Motivation toward the chip to system design based startup are there. Incubation and seeding support for new entrepreneurs to spread the awareness about the Fab and Fabless technology with the social platform. So these are the brief about the GSITS and Department of Electronics and Instrumentation Engineering, and really we want to contribute in the field of the semiconductor and microelectronics VLSI design, and definitely we will be the part of our next project that will be the collaborative project with the IIT and other institutes. Thank you so much.
Thank you very much. Thank you very much, sir. Any questions from the audience end? You may even paste your questions in the chat box. Sir, it seems there are currently no questions.
Okay, thank you so much. I would like to thank you so much, Dr. Santosh Vishwakarma, for giving me the opportunity for delivering the very brief talk about the fabless and fab semiconductor ecosystem in a third this.
Thank you very much, sir.
Okay,
We are
thank you
also
so much.
thankful to you
Thank you
for
so
such an interesting session. Thank you very much, sir. Moving ahead, I'm delighted to invite Dr. Gaurav Kaushal for the
क्या
next
प्रॉब्लम
invited
है भाई? नहीं क्यों कर ले? हाँ तो उठा लो. मतलब कोई मैं टाक में लगा हुआ हूँ जब.
Moving ahead, I'm delighted to invite Dr. Gaurav Kaushal for the next invited talk. Dr. Gaurav Kaushal received the PhD degree from Indian Institute of Technology, Roorkee, and MTech degree from Manit Bhopal in 2013 and 2008, respectively. He has postdoctoral experience in VLSI System Laboratory, Yonsei University, South Korea, from May 2014 to August 2015. He has authored and co-authored over 30 papers in journals and conferences in various areas of CMOS design and circuits. He is a member of IEEE Electronic Devices. He served in the National Institute of Technology, Patna, India from August 15 to May 17. Presently, he is with ABV IIITM Gwalior, India. His research interests include novel CMOS devices such as nanowire, FinFET, in-memory computing, circuit co-design, and device modeling. I humbly invite Dr. Gaurav to deliver his talk. Over to you, sir. Sir, I would like to. Sir, I think you're muted. Could you please check?
Yeah, so is it clear now? Why is it?
Yes, sir. Yes, sir.
Okay, so warm greeting to all. Here is Gaurav Kaushal from IIITM Gwalior. First of all, I would like to thanks the IIT Indore, Dr. Santosh Vishwakarma, that he has given such a wonderful opportunity And I have listened the various lectures or various lectures delivered by the various in academic as well as the industries. And I have also seen the some of the talk from the government domain also in such a way. So this is a very, I can say that this is a very huge work that is done by the in a beautiful way by in this IIT Indore. So I first thanks to IIT Indore, SGS ITS in Indore, and then MP Vigyan Pradyogiki Parishad and Vibha Vigyan Bharati. Okay, what is the here issue? Say sometimes every institute is wants to deliberate, means every institute here wants to deliver something. And from this conclave, I found that the industry person are also agree that they are saying they can provide the some internship, and the ministries are saying that just before 2 days we have listened that 79,000 crore has been passed, around 10 billion for you can say that research, manufacturing and production. So, but through this conclave, we found that the government policy, we know about the government policy, we found that the what is the thoughts behind the industry person. There are the some persons in the some you can say that research laboratory, central research laboratory, and they also have delivered this such a beautiful talk. And this is a very means I can say you are bringing a lot of person, academic, government policy maker, and the industry person, and you can say that central you can say lab person, they are here and we are here and we are listening it. So I found a very fruitful result from this conclave, and I found that definitely I have noted this some you can say name of the persons who have delivered the lecture. And so but this is not a single day task, as I have mentioned that they have delivered this. It is started from the one of the pre-conferences, that is the one conference was the IIT Indore at 11th September, skilled manpower, startup, ecosystem, MENIT Bhopal. And then you can say that this is the chip design, fabrication and testing facility at ABB Triple ITM Gwalior. And then this is the Riva Engineering College, discrete device and manufacturing, and ESDM and IT manufacturing. And each pre-conference, we found that a beautiful talk, a lot of persons has delivered the lectures, has delivered their thoughts, and I found a very nice experience through this. And this is a very good opportunity to deliver lectures in this conclave, for this conclave. So first of all, if I am thinking that about to develop the MP Madhya Pradesh in terms of the fabless and Fab Semiconductor ecosystem, and then as per of the my institute, I can just say that the thing is that we have the definitely we have listened a very good lectures by the some, suppose Viskarma sir is there, that then we can see that some of the other morning I have sent listen the name, I just forget that. Then in this domain I can just say that we have Triple ITM Gwalior is having the some MTech program in VLSI and embedded systems. Okay, and in that system, basically the name is always insisting that this is the IT institute, basically information technology, and it is the central government institute. And we have the we have the very good number of tools. Say suppose Synopsys TCAD, Synopsys Full Custom, Synopsys Front End. We have the Cadence PG University bundle. We also have the some FPGA board like Area 10 SoC FPGA board, and we have the some jet board also, some another FPGA board also we have in our lab. The thing is that present scenario students because are not available, so the thing is that they are using the FPGA board. For what purpose they are using the FPGA board? Some for you can say that machine learning application they are using the FPGA board. In that FPGA board we can complete develop the SoC. So that is the advantage of this SoC FPGA board. So at present, the MTech first year and second year both are working at from the what you can say that in virtual mode only. The ongoing research project we can say at present we have the compact modeling for passive elastic transport in gate-all-around MOSFET, and it is sponsored by the SRG Serve, and as a PI I am involved. And then this is the IoT smart IoT based smart device to implement gesture keyboard in the light of the COVID-19 disease. This is the one another project that is the sponsored by the TIAC, ABB Triple ITM Gwalior. And this is the one we also have the some project like from SMDP. That is the from SMDP we have the vocoder algorithm for voice coding and decoding. So this is the basically we have done the complete synthesis, and there is basically there is a two part encoder and decoder, and the students has work on this encoder and decoder separately, and they basically use the FPGA board, and then they have implemented they have done the implementation for encoder completely. We take the signal from the actual voice signal, then convert into the MATLAB coding, and then transfer into the some board FPGA board. And then we found that it is basically we have found that it has been implemented in this FPGA board encoder part. We also have basically what I can say that we have sent a chip for fabrication into the SCL Mohali at 180 nanometer, and the chip is about to come, and we are expecting that we if basically the thing is that we now after that we want some we can say that we are looking towards the how can we characterize, how can we start the testing. So this is I can say that different research domain available in the Triple ITM Gwalior in terms of the VLSI domain, and so many students are coming, and as we already know there is a boom for the you can say the students are going from after completing the MTech, and each student has been placed in some good reputed company in the VLSI domain. Okay, so we have this some also facility like there are a few companies are also coming related to VLSI domain, but from here we found a very good platform like we can ask we can say our student that if there is some we can contact to some industry person through this conclave. I can just say that. The other thing what I am doing here is something like device modeling is the first part that I have done during my PhD. But after that, I have shifted the domain, and now I'm working in the circuit domain basically. And that the circuit domain, just I can say in the morning, I have also listened that the some person, they are saying that they are working on this some ADC, PLL, and so we are working on this analog domain also. We have developed this some radiation hardened PLL circuit, and we have also developed this some SRAM flip flops. Some paper have been reported in this some IEEE transaction, but it is okay. So the thing is that we are still working. We are working on the circuit domain. Okay, radiation hardened. We are also working on the analog domain, such that we are going to develop. We are developing the SAR ADC and PLL. Say suppose low noise, low jitter base. We are going SAR ADC for low power. We are developing. One of the paper just has been published in the few that a low power noise analog front end for ECG. We have developed the complete analog front end system for ECG recording. And then at present, I would like to say I'm working on this in memory computation, near memory computation, and hardware implementation of neural network. The thing is that as we are moving towards the artificial intelligence, and it is required, we need to shift our domain. It is okay that we are working on the circuit, but I found that the many industries like NVIDIA and some other company, they are looking to the ML. They are asking the some scripting language. So that is the one of the thing that we need to work, and then we started on the working of the neural network implementation. By using the some SRAM, we can also use the I can say that MATLAB, and in that MATLAB we can use the Simulink platform for implementation of the machine learning. And at present, I can say we are working. When we look towards the some machine learning, then first of the paper we found that can we do the some in memory computation, near memory computation. In memory computation, we can perform the some basically logic operation, addition we can perform. But for multiplication, we need to go to near memory computation. So we are working on this, and one of the paper is communicated, and one paper is in under review. So this is the some work which we at present we have started in the last 2 years. Okay, so this is the current research domain in which we are working. And if I will say just the thing is that every institute here, just I'm saying that the delivering the talk about the what is the going on. So, but I will just like to say what we are doing here. So this is the, I suppose already everyone know that this is moving from planar to gate around. Now vertical gate around picture transistor has been come for 3 nanometer devices. And this is the why we are moving, because we have the greater gate controllability. Now where we can move, where we can do the research in this domain. So as we are moving to the some sub 3 nanometer devices, but there we are going to saturate. So now we are we can say that we need to perform this some in memory computation. What we are doing, some one human architecture, there is the some memory unit. We are using some, you can say, instruction, and then then they will perform the some operation. Then the operation will be perform some different ALU unit. But in memory computation, what is happening? We directly using the some cache memory directly sending to the what is called that you can say that the ALU unit for cache memory only, and in memory computation we can perform the normal operation also without using the ALU operation. So the all the ALU operation we can perform inside the memory. So it will basically increase the bandwidth. It will reduce the what you can say energy. It will improve the energy efficiency. You can say it will improve the latency. High data transfer we can perform by using the in-memory computation. So that's why we are working in this domain. So I'm just giving a brief for this what we are working at present. So what I can say that what is the motivation? Say suppose in this when we have the premium of 4 processor, and that the frequency was 3 to 5 gigahertz. But when we are going to 4 to duo processor, then also we have the frequency of the 4 to 5 gigahertz. Why? Because the power is also increasing proportionally in the same order. But the brain, which is working a lot of, it consume very less power. So basically, the human power is very less. So why we change the topology what we are working? We are using the normal one human architecture. So that's why in memory computation is coming in the picture. So that's we can see here the one of the picture. That is the some if I will say that natural intelligence versus artificial intelligence. Natural intelligence, I can suggest it is the mind, and that artificial intelligence is, this is the one of the competition that in 1997 IBM Deep Blue versus Kasparov, and they found that the power is consumed by the system is 15 kilowatt. Then one another competition by the 2011 IBM Boston versus Ken and Board. They found that the power consumption is around 200 kilowatt by the machine. And 2016 there is the one game of the this is the one of the China game, Google AlphaGo versus the Sodal, and they found that the power consumption is 300 kilowatt. But if I found the power consumption for the what you can say that mind, then the power consumption is very less, 20 watt only. So where we are lacking. So the in 2000 I can say that 2016 we found that they start working on the in-memory computation. So if I will just in brief, I will just say that how the in-memory computation. So suppose we want to perform the some logic, either an AND gate or a NOR gate. In this diagram, I am just indicating the AND and NOR gate. So we have the two SRAM cell. There are the basically the two operand is A and B is indicated here. And by taking the some V reference voltage, and the sense amplifier will sense the difference between these two voltages, and they can perform the AND and NOR gate. So what is the logic behind this slide is just that by using the memory, we can itself perform the all the Boolean logic. AND or NOR gate, we can or XOR we can perform all these operations by using within the memory itself. So that's why the researchers are doing a lot of research in this domain. How can we improve? What is this? Suppose there is the problem of the compute disturbance, there is the problem of the read power, and how can we remove the read power. So there are a lot of research scope is available in this in-memory Boolean logic operation where we are working. And so this is the one domain we are working. Say suppose this is the one work which is going. So this is in this we can say we have performed all the operation. All the logic operation is performed in this diagram. We can say that we have the 4 different operand A, B, C, D, and in a single clock cycle we can perform AND gate, NAND gate, OR gate, NOR gate, XOR gate. So here we can easily see that we can perform all the operation in a single clock cycle without sending the data to the ALU unit. We can perform all these operations. So in this domain,
Very sorry to interrupt you, sir.
Yes.
So we are actually running late. I would request you to quickly go through the rest of the slides if
Yes,
possible.
I'm going quickly. Just one domain I would like to another say that this is the that I'm saying that we are working on the neural network implementation hardware. So this is the MNIST data set we have taken, and then this is the some you can say that we have the some we are using the some here you can say the SRAM is using the for memory as a storing the input, and then there is some weight predefined. So we are also working on this you can say the machine learning, or you can say that deep learning approach. And that deep learning approach we are using the number of increasing the number of the hidden layer basically. So this I can just say that this is the some operation that is we are performing here. There is nothing more. And this is all what I am just saying that from this presentation, one of the things that I found that in this conclave is this is a very good effort by the that from IIT Indore, that the many persons are in a single umbrella, and I found that many useful and very useful and basically very fruitful speech, and you can say the what is the research is going on at present, what is the industry is demanding. So here I can just say that we will definitely contact to the some of the members which have delivered the lecture here for future, and I hope they will respond also. And because the our institute is also working, or you can say that the analog domain as well as the some you can say machine learning deep learning approach, because we have the IT information technology. So there is the one another IT in MTech branch. So the thing is that the student are expert in this artificial you can say that machine learning deep learning. They are using the different model, they are using the so many platform we are available for machine learning. We have the some opportunity means like we have some systems, computational big system, so we can use that. And we definitely, because where is the problem is here somewhere we are lacking in terms of the what is the industry demanding, what we are doing the research just in terms of the base of the research paper we obtain. Okay, so if you matlab, if in this way conclave we basically find out a very means useful in terms of the we found we listen a very matlab, we can say that good person lecture. So definitely I would like to contact, and I am also expecting the if anyone wants to contact, they are also welcome. We are here for any query and for making any collaboration in the future also. And I suppose if this type of conclave will or if we can say a meeting in which we can sit together and then find out the problem and then find out the how can we solve it, then it will also be fruitful for every institute, because each institute wants to contribute at present. And in the industry person are also showing the interest. So if there is a some platform or channel, if it form a channel to transfer the what is the problem in the industries, and they are transferring to the academic, and then definitely we will try to solve the problem, we will provide the solution. And they are very welcome, and we will also contact him. So thank you everyone for listening this talk, and for giving us such a time. I am also thankful to Dr. Santosh sir for giving this opportunity. Thank you once again. So if any question you may ask here.
Thank you very much, sir. Any questions from the audience end? So currently it seems that there are no questions, even in the chat box. So I would really like to thank you very much for joining us over here. It was really an informative session. You've covered the depths of in-memory computing. So it was really an insightful talk. Thank you very much, sir.
Thank you. Thanks.
For the next invited talk, I'm honored to invite Mr. Kunal Ghosh. Mr. Kunal Ghosh is the director and the co-founder of VLSI System Design Corporation Private Limited, a cloud-based learning platform for VLSI education, which has trained close to 40,000 plus VLSI engineers across more than 152 countries in 40 plus different languages. VSD has worked with top institutes of the country like IIT Madras, IIT Bombay, IIT Guwahati for various faculty development programs, which has trained close to 6,000 plus students within India. VSD community owns the largest open source analog, digital, and mixed signal IPs using Skywater 130 nanometer technology node, which is absolutely free for anyone across the globe to download and learn. VSD training community has done more than 20 plus tape outs, which is very rare for a training company. Prior to launching VSD in 2017, Mr. Kunal held several technical leadership positions at Qualcomm's test chip business unit. He joined Qualcomm in 2010. He led the physical design and STA flow development of 28 nanometer, 16 nanometer test chips. In 2013, he joined Cadence as a lead sales application engineer for Tempest STA tool. Mr. Kunal holds a master's degree in electrical engineering from Indian Institute of Technology, Bombay, India, and specialized in VLSI design and nanotechnology. I cordially invite Mr. Kunal to address the gathering. Over to you, sir.
Thank you. So am I audible over here?
Yes, sir.
All right, great. So I'll just share my screen. Okay, hopefully my screen is visible right now.
Yes, sir. Yes.
All right, so great. Thanks for the invitation first of all, and really appreciate the kind of introduction that you have given to us. And yes, my name is Kunal Ghosh. The topic over here is design at $0, and that has been very contradictory to all the funding numbers that we have been seeing till now from all the premium professors at the premium institute. So this is something which is very contradictory, and we were able to achieve this in a very systematic way. So yes, my name is Kunal Ghosh, and as the introduction given to me, it was I have done my master's from IIT Bombay. I majored in sub 100 nanometers lithography technology techniques. I have led a associate design team at Qualcomm from 40 nanometers till 16 nanometers. After that, I have joined Cadence as a lead technical application engineer, and I have supported close to 18 customers across 19 nanometers till 7 nanometer. And post that, VSD is our company. It's a company which is born in India under the guidance of Professor Madhav Desai and Professor Kamakoti from IIT Madras. So now we have built over the last 10 years. Today we have close to 40,000 VSD users and across 151 plus countries. And I'm going to show you everything because our company is mostly open source. So we want everybody to replicate what we are doing, and that's the greatest. There is nothing called as a closed source over here or a closed IP over here. We want to open source and help country to reach the greatest heights. That's the only vision that I had, and that's the only vision with which we have built the company. Okay, so a bit of technical. Initially, I'll start with a bit of technical. Then I will move on to what are the major achievements that we have done in the areas of national semiconductor program. And post that, we are open for opportunities, or we are open for collaboration with any of the institutes within the country. And whatever we can do to help the country, all of you are welcome. And even we appreciate that part from everybody of you. Okay, so let me give you a bit of technical description about our flow. So I'll show you a VSD design to tape out flow, how it has enabled a student. So when I talk about a student, this student is not from IIT, is not from NIT. He is a student who is somewhere lying in the rural area, in a rural area, like for example Sangli or Hubli or this kind of areas, and they have been able to achieve some remarkable things in the areas of VLSI, and they are all got placed. They have all got 3,344 offers from companies like Qualcomm, Cadence, Synopsys, Apple, Google, and companies like that, Sci-Fi, Intel, and all the top companies which you can think of. So we were able to enable them, and that's how we were able to reach a maximum number of students. So let me give you a bit brief of technical presentation. So the first stage of our program is where we encourage each and every participant to do a literature survey. So we were online even before a pandemic started, and so the online model has actually helped us to enable a lot of students to first of all do a literature survey. A little bit of technical, so not getting into details of the technical specifications. For example, if a student has been given a project of a D2A converter, he is being presented with this particular slide. There are 10 to 15 slides related to the D2A converter, but the student is being given this particular slides, and the slides and the data that we prepare, that is so much graphical, that gives enough information for the student to do a literature survey about the design that we give to the student. This is one of the snippet from one of our IP that we have designed. The second phase, the second stage is basically where he does a partitioning, behavioral simulation, or if it's a digital blog, he does a synthesis using open source tools and Sky 130. So the advantage of having open source tools is, first of all, it's free. No license cost. You can download it anywhere at any point of time. And the advantage of having open source PDKs. Now, this is really important because whatever PDKs we have been hearing of, TSMC 20 nanometers or SCL 1T nanometers or Intel 7 nanometers or whatever the PDKs, whatever the nanometers that we have been hearing till now, they are all commercial. They are all closed source. You may not be able to access them unless you are from the top institutes of the country. But Sky 130, Sky Water Technology US has enabled 130 nanometers technology node open source to everybody, and that has actually helped institutes like VSD to enable a lot of students across the country, not across the country but across the world. And basically, the second step is basically to do a partitioning and behavioral simulation. For example, for a D2A converter, one of the students, I'm just sharing the snippets from one of the interns who have done this particular project. He basically creates a detailed. He partitions the whole designs into small steps, and he basically creates he does a behavioral simulation for this particular circuit. 90% of the institutes within our country or within the world, they stop at this particular point because they what I have seen, since I'm also from IIT Bombay and I worked with multiple other IITs, what we have seen progress of our country's specialist engineers, and we tried to solve that particular problem to take this particular thing ahead of the circuit design part. So mostly the IITs and NITs know how to take this particular design to a layout level, but I'm talking about the 90% of the rural areas, which are the sharp minds. The sharpest minds I've seen, they lie in some of the rural areas, and VSD vision statement has always been to help the rural people, the rural students, as far as possible at the lowest cost as possible. So we are mostly enabled to help them, and that's our vision statement. So we take this particular thing ahead. We ask them, we have our own modules where we enable them to explain or to do a place and route STA if it's a digital blog, and to do a post layout simulations and DRC in LP. So this is something. So for the people who are not technical, don't worry about it. This is something which enables something called as a chip tape out. So if you look over here, these are some of the steps. So these are some of the layouts that was drawn by students of the very rural countries who don't have access to institutes like MIT, Berkeley, IIT, NIT. So these are built by those students. So this, if you see, this is not a simple design. This is a very complex design, and the layout of the entire layout was built from scratch by a student who basically doesn't have access to the commercial tools, because I think there is a restriction where the skilled manpower development program gives access to tools only for the top 120 or 130, something top 150 plus institutions. But what about the institutions who don't have access to any tools? So that's where we come into picture, and that's where the 90% of the students lie. They are the sharpest minds as I've seen in the country, and this is what was built by them. And this is the whole 10-bit DAC design, a D2A converter design that was built by a student from scratch, completely online using open source EDA tools. So that's what we are specialized about. And the post layout simulation. So basically, ideally for people who are from the non-technical background, just for me to explain you, your pre-layout simulations should be able to match your post layout simulations for a successful tape out. Okay, that's what the idea is. So this is what you see is a post layout the numbers or the post layout simulations. So ideally this should match with the preload with some parasitic capacitances that is present. So that delay will obviously comes to picture, but the waveform shapes should not be differentiating. So that's the idea. And finally, once you have done with the post load simulations, we don't stop there. The idea over here is to create a detailed data sheet. We need to document each and every parameter that was achieved by this particular IP. Now that is something which has been missing from most of the institutes, and this is something what I've been experiencing personally, and I would love to help to any institute who wants to reach to a level where they have to create a detailed data sheet. So if you see over here, if you see this particular screen, this is something that looks like a data sheet of an IP. If you look into any IP, go to a website like designreuse.com or any of the top website that sells IPs. Now for your information, if you are from the VLSI domain or from the VLSI industry, an IP cost you close to $1 million. It's like it's very costly for you to even buy a IP. This case, this IP, this particular design was built by a student who stays in the remote areas of the country, and this was something which was built by it, and he is the one who is enabling all the students within the country to use his particular IP, because it is made open source. So this particular data sheet looks very close to what is available in the design reuse website. The only difference is the design reuse website and other IP data sheets, those are very accurate because they have been built by using commercial tools by some experts who are like 20 plus or 30 plus years of experience. This particular person that you see, he is a second year or third year third year BTech student who has built this particular data sheet. That's a huge difference. If you see this kind of data sheet that is being built by a third year student, just imagine the amount of achievements that he can do, or the amount of detailing that he can do when he actually enters into the semiconductor industry and gets into the business of IP business or a digital design business. So that's what we wanted to showcase over here. This particular data sheet was built by one of our student, and every step that is needed for any other student in another remote area to duplicate or to replicate his work, it's all been mentioned in this particular repo. So all we have close to 500 plus we have close to 550 plus GitHub repositories, which gives you step-by-step process on how did one particular student was able to achieve the entire thing. That's a compulsory thing in order to, if you want to achieve a VSD certification. VSD certification, you can think of the certificates of VSD very close to that matches Berkeley, MIT, or the top IITs within the country. You need to do a detailed documentation of whatever work you have done, because the criteria over here is any other student who is present in the remote country of the world. He might be from Nigeria or Africa or some other country. He should be even able to replicate each and every step that you have given in your repository on his own laptop. That's the criteria, and that's the toughest part to do. I would as per my experience, that is the most toughest part, and we were able to achieve that using open source CTA tools. And finally, not only that, the students who have followed this particular flow, they were able to do tape outs. Now, it's very rare that an institute or a training institute does a tape out. This was the only company that was able to do 14 tape outs in a year. Last year only is something which we had started a tape out program. This year, Indian students were able to do 14 tape outs through VSD channel. That's that is a number which is even higher, or even the highest number within. If you compare some of the top universities within the country, this number is pretty much at the higher level, and that's because we have a process, we have a flow, and that particular flow enabled thousands of students to do a circuit design. And out of this 14 people, 14 is just a very minimal number. The National Semiconductor Program within India has a dream to achieve 85,000 students that should be able to do these kind of things. That's a very big number, and I'm sure we will be able to achieve that particular number very soon. I think that within the next 10 to 15 years, we will be able to achieve those numbers with this particular methodology that we are showing on our screen right now, that you see on my screen. These tape outs, or this chip design or tape outs, was done by students who are like second year, third year students, or who are first year in their master students. Basically, people who have not even graduated, who have not even seen any industry. So these tape outs were done by those kind of students. Just imagine, with the right kind of collaboration with IITs, and with the right kind of collaboration with all the NITs or with all the institutes in the country, what all things that we can do over here. There was a talk about SRAM. So this is one of the chips that was taped out by one of our students. It's an open source SRAM compiler. This is a DAC, D to a converter. Then this is a comparator, and there is a PLL over here. there is an amplifier over here. There is a I think there was a PLL over here. So these are all the designs, the foundation IPs that was actually taped out by students, second year, third year, or final year students of the country. So we have a potential. We have a huge mass who wants to do things. It's just that we need the right kind of platform. We need the right kind of collaboration to do this. Coming to the collaboration, if I want to conclude the whole thing about how does VLSI or how does VSD enables the learning pattern, it's very unique. For the learning pattern, you have to go to the top-down approach. You start from a chip, then to the architecture, then to the gate level, then to the transistor level, and then to the device level. That's the learning pattern that we have been following for the last 10 years. And if you want to really design an IP, it is basically a down to top approach or a bottoms approach, because you have to need to start from circuit design. I'm very sure experts in this particular group might have various ideas on how do you basically expand this particular flow. But this is the top level flow that we have been following till now, and it's very successful, especially the students. And these students who have done this particular courses, I've seen them getting placed in top companies like Samsung, Apple, Nvidia, Google, Synopsys, Cadence. You name the top, Intel, Qualcomm, you name the top company, and you will find AMD, AMD Toronto, ANSYS Toronto. So these are the companies where these students are getting placed because of a systematic approach. And of course, this was not developed. It was not developed by only me. It was not developed by a single person like Kunal Ghosh. It was developed by a team of people, by a team of professors within the country, and they are all our mentors. And I'm going to show them in a bit from now. And just a query, just a thing over here, that our tape out programs, tape out. So tape out is a word which is for people who are non-technical. This is what our country needs right now. This is what our country. This is the reason why our country has sanctioned $10 billion of revenue of funds for doing this kind of programs, and this is what really means to our country. So we are looking for a tape out programs, and you must have seen the silicon wafers and things like that was presented by the ministers, by the government in the recent talks. So this is what he actually meant, and this is the program that we were running for last 8 to 10 years now. Now this particular program has been accepted by global industry leaders, by eminent professors from the Ivy League colleges, innovators, and government organizations within our country. And I'm going to show you that in a minute from now. So we have been showcasing all our work in form of conferences. Our company has got its own conferences, all been driven by the students of the country. If you see over here, all the conferences which we had, they are driven by the interns and the students by our country, from our country, and they are driving this massive conferences across the world. So for example, in the first conference, if you see Professor David Patterson, who is the father of RISC-V processors, he is the one who was a keynote speaker. Mohammed Qasim, who is is a leader of open source technology, he was a leader who was a keynote speech. Professor Vijay Krishnan, he's from IIT Madras actually, and he has seeded the idea about an online conference. 2018 was even before when the pandemic started. In fact, the pandemic started in 2020, in this particular year. 2018, 2019, we had actually started the online conference long back, because we believed that online is something which will help us to reach each and every student at their and we can reach students who are sitting at their home and doing doing some amazing work, and that's the best way to reach him. So we had already started online long time back, and recently the online has become very popular. In fact, the conference that we're doing right now, that's also an online, and it has become a quite popular one, but something which we have been following over so many years. 2019, we had again some top semiconductor leaders. We had Professor Andrew Kang. So you must have heard of tools like Cadence. He was the one who architected the Cadence tools. You must have heard of RISC-V. So Callister Redmond was the CEO of RISC-V. You must have heard of semiconductor blogs and jobs related queries. So SemiWiki, Dhirendra Lenny, a world leader, he's basically approaching, or he's basically heading that particular blog. And Professor Rabe, I think everybody over here who is 10 years senior than me, or who is like junior than me, everybody must have heard of Professor Jon Rabe. He had delivered a keynote speaker for us. Professor Navid Sherwani, he's also a professor, and he's also a investor he has done a close to $250 million of investment in the in the semiconductor industry. So he was also one of the keynote speaker. Michael Vishad, who is the board of members of the Cypress Semiconductors, he was also a keynote speaker. Anil Sastar Budde, he's the chairman of AICTE, and he was a keynote speaker recently. What we have done, so every big leaders over here, they have acknowledged the design to tape out programs, and that's the next thing to go for our country. In fact, for the whole world, that's the approach. And not only that, we have done a lot of workshops. The first ever device physics workshops. So device physics process and simulation is something which is currently not encouraged so much in the country at a much lower level. We took that particular initiative and made sure that the process simulations and device physics should be encouraged, because if we want to build a fab in our country, these are the topics that is really important. And we did the first ever workshop on device physics and process simulations at NIT Manipur. This is pre-pandemic. That's why you see all of us sitting over here. The largest online VLSI open source EDA workshop was conducted by MNIT Jaipur. It was done in December 2019. Again, 50 universities, 1,800 participants, close to 1,800 participants had attended this whole workshops online from cloud. There is a system called as a National Knowledge Network, through which we had broadcasted the whole training over the cloud. Now, the second largest online workshop was held by IIT Guwahati. Professor Gaurav Trivedi has been a very good mentor. In fact, I would say he is the one who actually started the 5-day workshops. He actually helped us to start the short 5-day workshops within the country. And this was the first workshops that we had done in 2018 at at the massive online cloud level. Dr. Trivedi has been a very dear mentor to us, and you can see this particular screen. Close to 42 universities and close to 1,400 participants had participated. He's also a mentor to our company. He has been helping us and guiding us to do a lot of things. As I said, the VSD company was built on top of huge mentors and in the support of very good mentors. Silicon Institute of Technology, Bhubaneswar. Many of you might not know about this company, many of you might not know about this particular college. This college students are doing tape outs. I mean, this is neither an NIT nor an IIT, but this college is something which is this Professor Saroj has been enabling his students to do tape outs rather than just theory part. He's enabling students to do tape outs on XFab, 600 nanometers and XFab 130 nanometers. He's also a mentor for our company, where he's helping us to do some tape outs related to analog design. So the very dear friend and an awesome mentor that helped us to build our company. Professor Shantanu, if you see this person over here, is Dr. Shantanu. He is currently a mentor with our company and is helping thousands of students to in the areas of analog design. Don Bosco Institute of Technology in Mumbai. They also had conducted one of the largest workshop in the area of open source EDA, and this was live streamed to all the countries. So we had students from these are the students from Mumbai, but live streaming there were students from UK, from US, and there were people who waited the whole night long for this particular workshop. IIT Bombay, everybody must have known Professor Madhav Desai. So he is my guide when I was doing my MTech at IIT Bombay. Professor Madhav Desai, I worked under him, and he was my guide for one of the IR projects. And you must have heard of the chip called as Ajit microprocessor. He's the architect behind it, and me, Dr. Trivedi, we are all students to Professor Madhav Desai, and so it was actually Madhav Desai's brainchild to form our company. He is an excellent professor, and he had this R&D program, and this is something we wanted to. I just discussed with him that how do we take this particular R&D program at a social level, and I just got this particular website, VSD, and tried to put all these programs at an online level. So if you ask me, he's our mentor. Whatever he says, he's the architect and the brain of our company. online. So we had done the largest online workshop in embedded UVM, around 250 plus participants, and this was again conducted through IIT Guwahati under the guidance of Professor or Dr. Gaurav Trivedi. RISC-V. So we had done the largest RISC-V workshop. So RISC-V is a very popular name within the country, and we had done the largest RISC-V workshop, close to 1,000 to 1,500 students plus. And you won't believe, students at 8th grade or the students at 7th grade. These were the students. These were the kind of students that had joined in this particular workshop. Just imagine if a student who is at 8th grade and the 7th grade students are joining RISC-V workshop. Just imagine the level of the level of the workshop that we had brought down to, and that enabled students, even the school students, to attend this particular workshop. That's what actually is the need. We need to graphicalize the whole thing at a much more at a much more downward level, so that even a school student can understand what VLSI and what a semiconductor and what RISC-V is. That's the snippet from a student who was 8th grade and 7th grade. Professor Jan Rabe, he had given a talk in our one of our conferences. He acknowledged the whole program that we have been doing till now for the last 10 years. Many of you might be referring to his notes till now. In fact, I refer to his book on VLSI design to do a lot of some of our research activities. Now, this is an image from with MIT, with IIT Madras and CDAC. Professor Kamakoti has been a very good mentor to us. In fact, 2018 and 19 is something which I had worked with Professor Kamakoti and Sunita Verma. I have worked with them. We were discussing on the challenges on how do we scale up our country and bring up to a level where they are ready-made design engineers, and that's what the brainstorming has been done. Professor Kamakoti has been a very dear mentor to our company. In fact, most of our ideas that we are running till now, it's all his brainchild. I'm just the executor for what Professor Kamakoti says. In fact, anything we don't even dare to do anything wrong, because we have the blessings of Professor Kamakoti, Professor Madhav Desai, and Dr. Gaurav Trivedi, and so we have their blessings, and there is nothing that we can even think of doing anything wrong with the company and with the students. Professor Kannan, we had conducted the largest circuit as an hackathon, close to 3,000 students within the country. Dr. Anil Sahasrabudhe, this myself, and Professor Kannan has been helping us to do the launch the largest circuit as an hackathon. So the reason why I'm and there is a hackathon in pipeline. This is one of the photos by with the MP Tejasvi Surya, and there is a plan to conduct a similar hackathon in the pipeline, so that we make thousands of students aware of what VLSI is and what semiconductor is, what semiconductor design is. So if you see in the country that the students are aware of what software is, but the students are not yet aware how cool our semiconductor and our hardware design is. So that's what awareness is, what we are trying to bring up, and the later the remaining skills can be easily taught to many of the students. There are eminent speakers in this particular conference as well who can conduct all this kind of skill development. But first of all, the first need is to make everybody aware and excited about this particular field, and that's what we have been doing over the years, over the several years, and that's what has been our expertise. So there is a hackathon pipeline at the Karnataka level. So we are trying to do at the VTU, Vishwasara Technical University. We are trying to conduct a hackathon from that particular university through all over Karnataka, and let's see how it goes. It's still under pipeline. So we have close to 13,000 YouTube subscribers, and these are some of the numbers that I wanted to present. And we have 4 IITs collaboration: IIT Madras, IIT Bombay, IIT Guwahati, and IIT Hyderabad. So they are the 4 IITs that we are doing some research collaboration, and you will get to hear a lot of things from all the IITs and VSD very soon. So the question is, how is everything so effective? The answer lies in the VSD Fab experience. So I have a Fab experience. While I was doing a master's at IIT Bombay, this is one of the
Sorry to interrupt you, sir.
I'm done. Yeah, I'm done. Almost done. Yes. So the Fab experience is something which has enabled us to showcase quality training and quality skills to our students. And secondly, cloud. So the previous training model was all on all physical, and lately we have moved everything to cloud. So that's what has been helping us till now, and we have been following the it's totally based on knowledge, understanding, and application approach. That's the approach that we have been following till now. And yeah, now we have close to 40,000 plus members and counting across 152 countries and 48 languages, and it's been growing at a very vaster pace, So welcome MP, welcome Madhya Pradesh to the growing VSD community. Any help anybody of you needs to conduct hackathons in your region, or anybody needs some help to do something in your area, to do hackathons, to do trainings, anything, we are free. We are ready to do anything for the country. We are ready to do anything for Indians and for India and for Indians in outside country. So that's all from my side. Thanks everyone. Thanks for joining. And hopefully I'm just a bit of overtime. Indore is very special to me because of Sharafa market and because of Chappan area. So that's all my friends have taken me to those particular areas. So it's very dear to me. Thank you. Thanks a lot. Any questions? Please feel free to drop me a message. Thank you.
Thank you very much, sir.
Yeah.
Any questions from the audience end? Though the questions in the chat box are already taken care of by your team. But,
thank you.
So as of now, there are no more questions.
No problem.
So, sir, it was indeed a very exciting talk. It was really exciting to know about so much about VSD. And VSD is a very well-known community among the VLSI research scholars as well. And chip tape out is something that intrigues even all of us over here. So it was really exciting to know so much in depth about chip tape out, and it was a really informative talk. Thank you very much, sir.
Sure. Thank you.
Moving ahead, I would like to invite Dr. Dhruv Ghai for the next invited talk. Dr. Dhruv Ghai is currently working as the Pro Vice Chancellor at Oriental University, Indore, India. He obtained PhD in Computer Science and Engineering from University of North Texas, USA in 2009, Master of Technology degree in VLSI Design and Microelectronics from SGS Indore in 2006, and Bachelor's degree in Electronics and Telecommunication Engineering from University of Pune in 2003. He's a senior member of IEEE and a reviewer of various IEEE transactions and journals. He's an associate editor for IEEE Consumer Electronics magazine. He has served as the Vice Chair Membership Executive Committee, IEEE Computers Society Technical Committee on VLSI from 2017 to 2020. His research interests include low power design, layout and optimization of analog and mixed signal nanomos CMOS circuit and systems. So I would really like to invite Professor Ghai for the next talk. Over to you, sir.
Yes, am I audible?
Yes, sir.
Thank you for the introduction. And Kunal's talk was really interesting, and a lot of work being done by Kunal. I would like to congratulate him on having done such good work.
Thank you.
For the reaching out to the rural candidates who don't have exposure, who don't have the right kind of tools. So I remember getting my first experience with Cadence and doing a tape out only when I had access to Cadence. Till then I was just playing with the open source ones, with the free ones, and never really could get that experience. So you were very right about that. When you get to do your first DRC, LVS, and you run it, and then you find that okay, so you're getting closer to the chip, your chip being manufactured, your first chip being manufactured. So very nice talk, very nice to hear that. So I'll go ahead and share my slides. Is it okay? So my talk is more broad. I would just like to talk about the ecosystem. I would like to talk about what's happening at my university, how things can move ahead, and what are the problems which are happening currently in the semiconductor supply chain across the world. So I've kept the title as developing a research ecosystem for skilled manpower in Madhya Pradesh, and what role maybe private universities could play, and along with the IITs. So there was a pre-conference earlier. I had delivered a talk during the pre-conference as well. So I have built upon those slides. Some slides might look familiar to you guys. So, but I have built upon them and added a lot more new slides. So, as usual, you need to start with Moore's law. Every VLSI talk has to start with Moore's law. So we know, we are familiar with Moore's law. It is hitting its scale. And, I have just added a new point that is yesterday's news. I read it in Best Business Standard. So I've added it here that, government is talking about support for semiconductor manufacturing, but now they've specified that, we'll give 30% support for 45 to 65 nanometer feature size development. We'll give 40% for 28 nanometer to 45 nanometer, and more than 50%, almost 50% support for lesser than 28 nanometers. So, the government is also concerned about developing cutting edge semiconductor chips. So that's how they've broken it up. I was very happy to read about that in yesterday's news. And we know that, CMOS is hitting its limit. So alternative technologies are being explored, like carbon nanotube, double gate, FETs, FinFET. And of course, as Kunal had mentioned, and other speakers have already mentioned, that, VLSI is an area where multiple disciplines come together, as Dr. Mukesh Kumar had also pointed out. There's a Center of Advanced Electronics. A lot of people from various disciplines are coming together, whether it is computer science or it is physics and electronics, electrical engineering. So multiple backgrounds are required in physics, analog, RF digital design. So, the need for ICs is increasing as the gadgets being used by all of us across the world are increasing. The number of, mobile phones per user is increasing. And I've just jotted it down, that there are smart cars. So we're talking about autonomous vehicles. We're talking about smart agriculture, where again, IoT and, all the electronics is creeping in. We are talking about smart healthcare, smart homes, smart energy, smart entertainment. We're talking about smart TVs, gaming consoles, smartphones, and smart security. So, now they require a mix of technology, mix of chips. So not all of them would need high-end, cutting-edge 28 nanometer chips. Some are still functioning at 180 nanometers, 130 nanometers. So it's a mix of technologies that's at play. And we could capture either end. We could capture the high end, the cutting edge, or we could also capture the low tech. But it would still make a difference for India. Again, this is just making a case for why we would need to set up fabrication plants in India and in Madhya Pradesh. So there's chip shortage. This is just November's news. Automobile industry is facing a loss. Maruti Suzuki sold 26,000 fewer cars in November than April. Sales have dropped. So this is not that the sales has dropped, not because there is no demand. There is huge demand for vehicles right now, and there is a lot of electronics in the vehicles. So, if you look at the backlog, Maruti backlog is 5 lakh vehicles, and Hyundai backlog is 1 lakh vehicles. We have an upcoming electric vehicle industry, which is again going to need a lot of electronics, lot of ICs, lot of system on chip architectures. And, our design industry is very strong. People are very motivated, and, even using, like Kunal mentioned, even using open source tools, we are ready to do the entire design cycle. But when it comes to fabrication, that is where we are losing out. So, Tatas are entering the semiconductor business. So Vedanta is interested in setting up a display fab unit. All this has now been highlighted because of COVID. So, there's the demand side. What happened after COVID was that the demand for electronic devices went up. Smartphones, gaming consoles, laptops, because people were at home. People falling ill, with people falling ill with COVID, the medical diagnostics demand also went up. Auto sector did not foresee the spike in demand after the first wave. If you look at the supply, mainly I put a pie chart here. So if you look at the supply, you see that Taiwan, the two companies, TSMC and United, are supplying 65% of the chips to the world. They own the 65% of market share. South Korea, Samsung is 14% and China is 11%. And the others are, just 1 or 2%. That is USA, Japan, Malaysia, other countries. So, unfortunately, we had these other incidents happening, like lockdowns in Malaysia. We had a snowstorm in Texas, which disrupted the supply, semiconductor supply, global supply. We had a fire at a semiconductor factory in Japan, and the aftermath is being felt across the world. And people say that it is going to take almost a year again, to normalize, maybe up to 2023. So that is an opportunity, again, an opportunity for India to grab. Again, just an insight. This is one of my older slides. Fabrication facility take a minimum of 2 years to build. We need area. We need a big land to scale. Clean rooms are 1,000 times cleaner than a doctor's operating room. So, we need to keep that in mind. Even a speck of dust can damage the process. There's no short-term solution. We need pure water in vast quantities. We need 24/7 power supply. We need land to achieve economies of scale, because you're ultimately going to sell, your unit cost is going to be $1. You're going to sell one IC for, say, 50 rupees, 20 rupees. So to be able to capitalize on that, you need to be producing a huge number per month, say 40,000 ICs in a month. So that's how you're going to make money. So you need to produce, you need to achieve the economies of scale. So we do have skilled manpower for design. Our design houses are very strong. India is housing, most of the semiconductor countries have design and development happening in India. They have design houses in India. We have our own homegrown companies as well. Some of them in Madhya Pradesh. I'll just point them out in the later slide. But there is a gap in the electronics value chain, and that is where we are not fabricating ICs. We are not fabricating them. The fabrication is being outsourced. So this is just an older slide. Did we miss the bus? Maybe we did the earlier one, but still we have these upcoming industries like the automobile industry, mechatronics, robotics, which would again cause a surge in demand in electronics skills and demands in electronic engineers. Here are a couple of government initiatives which have happened across the years, and which have helped people create an impact in the semiconductor industry. We have the production, the PLI, which is being talked about. It was almost in yesterday's and day before yesterday's, where the 76,000 crore subsidy has been declared by the government. They also have a design linked incentive. So, the design linked incentive would support the design houses, semiconductor design houses, where they would be given, the eligible candidates would be given subsidies up to 50%. And of course, they're seeking interest from companies to set up display fabrication units, silicon photonics, and semiconductor packaging. So again, coming back to the private sector, Tata is always in the news for, they have shown a keen interest in setting up semiconductor fabrication plants in India. And they're looking at states like Tamil Nadu, Karnataka, and Telangana. But, they should be looking at Madhya Pradesh also. The government should think about that how we could make our state more attractive for, these private players to come in and set up fabrication plants. So that would create a lot of jobs for the people who are working here. Intel and Jio are collaborating. Infineon Technologies collaborated with NSDC, and IESA has collaborated with the Singapore Semiconductor Industry Association. Madhya Pradesh has taken its own initiatives, and this is again a big initiative. MPVS in its own is a very big initiative taken by Dr. Santosh Vishwakarma at IIT. I would like to thank him for creating this whole symposium, and a lot of other participants, Dr. Vaibhav and Mr. Prajatantra Gangele, have done a tremendous job. So Madhya Pradesh, again, we have our own analog fabrication investment policy. We have electronics manufacturing clusters in Badwai, Bhopal, Purva, and Jabalpur. Many commitments by semiconductor companies to invest in Madhya Pradesh. Also, we have our own private semiconductor companies, Conclave Semiconductor, Anage Semiconductors, and Scientech Technologies, which is, I believe, housed in Indore. So here's just a brief insight into the private universities in Madhya Pradesh. So we have 39 private universities in Madhya Pradesh which have been established. 4 are still proposed. So maybe by next year we're looking at 40, 45 43 private universities. And, private universities also looking to carve their niche in this research ecosystem. And that's what, we want to discuss. And so, there's a lot of focus on artificial intelligence and machine learning right now. And, people are starting BTech courses on those. So where do they come into the chip design, this thing, so one of the ideas is that AI ML may help shorten the chip design cycle, design better EDA tools. So the entire EDA industry right now is looking at how AI and ML can, be employed in these EDA tools. And there are research papers coming out every day in every conference. And I was recently attending a conference in MNIT Jaipur, and that's what most of the discussion around revolving around. So, I'm sure there's going to be some betterment of the EDA industry. And so the resource can come from private universities, with tie-ups. One another idea is that, once the fabrication facilities get set up, like Kunal said, teaching layout to college students, first year students, second year students, now layout is a skill which is actually marketable. A person can actually become a layout designer, and the making a layout manually is kind of a low-tech job, but still, it pays. So, those are the kind of jobs, more jobs can be created. We can have, layout being outsourced to India. We have the wafer fabrication operator, etch equipment engineer, photo process, photolithography engineer. Those kind of jobs can be created when there is fabrication facility in Madhya Pradesh. So that would cater to our graduates, So, high-tech jobs getting created is great, but then low-tech jobs also are jobs. So, again, this is just some thoughts. We can foster collaboration between universities, and once the companies come into Madhya Pradesh, becomes easier to collaborate. Training, reskilling can happen, and electronics engineers seeing kind of a downtrend in the private universities would definitely pick up again. So just to give an insight, Oriental University has a mix of programs. We have engineering, we have agriculture, management, pharmacy, law, education. And, because we have so many different areas, there is more opportunity for interdisciplinary research. Like I talked about in my earlier slide, that electronics is finding application everywhere, whether it's smart agriculture or it's smart healthcare. Where you have smart agriculture, you would need a subject matter expert from agriculture. So a lot of opportunity for in-house interdisciplinary research happening at our university. This is how we support our faculty to do further research. We have incentive policies in place. We have incentives for research and publications. We provide incentives for state, national, international awards. We provide incentives for patents, copyrights, trademarks, inventions. We have incentives for, faculties upgrading themselves, doing online courses. We have a training and consultancy policy where faculty, can go ahead and do consultancy with the industry or some other institute, and that would be supported by us. We provide seed money for research, for kickstarting research, and we have a research ethics policy in place. Here are some of our MOUs. So, just to point out, we have MOUs with companies like Hyundai, which is into automotives, but again, with smart cars and everything coming in, there's a possibility of doing research in that area. We have MOUs with with the Indian Council of Agriculture Research. We have MOUs with pharmacy companies like McW Healthcare. This is a company based in Indore. And we have, for online courses, we have MOUs with Coursera. Oriental University has been supporting conferences over the years. And one of the highlight is that we've supported this conference, IEEE-INIS, that is the International Symposium on Nanoelectronics and Information Systems. That was started by us. That was started at Indore in 2015. I attended that recently, hosted by MNIT Jaipur. And we've renamed this as Smart Electronic Systems. But that was our initiative, started in 2015, and now that has really taken off. It has become a popular conference hosted by the NITs currently. And, we always have a host of international speakers at these conferences. We had 8 keynote speakers this year. In 2017, you can look at the collection of keynote speakers. We have Dr. Vijay Krishnan Narayan from Penn State. We have Dr. Mishra from NJIT, Sri Parmeshwaran from Australia, Garrett Rose from Tennessee, Knoxville, Dr. Aviral from Arizona State. So we had some very good keynote speakers come in. Oriental University is always ahead. We had student posters presented at MPVS 2021. Our MTech students, MTech VLSI students, MTech Computer Science students presented papers. We have an IET sub-center. IET is the Indian Institute of Electronics and Telecommunication Engineers, which is a very old organization. Very good research happening. They have their own journal, and they also give supporting grants. We have an IEEE student chapter as well. So this conference, IEEE INS, which is now called ISIS, is supported by the IEEE Computer Society Technical Committee on VLSI, TC-VLSI, which I'm a part of. The membership is free. So, you guys can join. They have a newsletter coming out every quarter, keeps you updated. So just one slide about the IITs, how IITs are helping. IIT Indore is just in our backyard. So, they are mentoring faculty from private universities. They provide internships for undergraduate, postgraduate students from private universities. 2 of our students are interning in one of their labs. So that's really good exposure for them. They provide external membership for online library resources like e-journals, e-books, access to other softwares, and of course, consultancy services. So they are also supporting the research ecosystem in MP. So, there's a lot of talk about the new education policy by the government, and these are few of the ways which maybe that could help, where there's multiple exit and entry points in higher education they're talking about. Like Kunal's got his program going on, so we can introduce a certificate program in layout, introduce certificate and diploma courses. We could have a diploma course and an associate degree course in chip layout design. And that would give a layout designer who would get readily absorbed by the industry. So, quick churn out, 1 year, 2 year programs. And that could be possible under the NEP, new education policy. And, we could establish integrated circuit schools, microelectronic colleges, look at models from other countries. And of course, there is talk of foreign universities coming into India and setting up campuses. So that would again help. So thank you. That was it. That's it from my end.
Thank you very much, sir. Do we have any questions from the audience end? Participants may paste their questions in the chat box if any. So I guess, sir, currently there are no questions.
Sure.
So I would really like to thank you for giving such an insightful talk. And it was a really informative session. Thank you very much, sir. Moving ahead, I would like to introduce the next speaker, Mr. Akash Sethi. Mr. Akash Sethi is the Joint Managing Director of Sri Pastronics Limited, a company which is the only manufacturer of active implantable medical devices in India. It is one of the 5 companies in the whole world that manufactures cardiac pacemakers. In its 30 years of existence, the company has implanted its devices in over 1 lakh patents in India and abroad. Mr. Akash Sethi, a graduate of Carnegie Mellon University, USA, has worked with companies like Medtronic, Disney Research, and Tesla Motors. Having spent 10 years in USA, he has decided to move back to India and do something which was closer to his heart. He's passionate about democratizing healthcare by using technology to alleviate pain, restore and save lives, and bring it at an affordable price. I cordially invite Mr. Akash to address the audience. Over to you, sir. Sir, I think you have not unmuted yet. Yeah.
Yeah, it's unmuted now. Thank you for the introduction, and a very good evening to all the members and the panelist members. Thank you for inviting me here, and I'm really humbled to listen to all of the distinguished speakers about the great work that they are doing. And it is really encouraging the initiative that is being taken up by IITs and other institutes to put this conclave together to set the direction in motion. So very excited about this. And as Professor Dhruva in his previous in the talk said that there are a lot of applications of semiconductor devices. There are low-end applications, there are high-end applications. And they are so pervasive, you won't even realize where all you are interfacing with the silicon in day-to-day lives. And I'm here to talk about one such application of these silicon or semiconductor devices in medical devices, which is cardiac pacemakers. So I'm more from a healthcare background, but I promise to you all that I will try to stick to the integrity of this conclave and direct my speech more towards the use of semiconductors. Let me just begin by sharing my screen. Please let me know if you're able to see the screen.
Yes, sir.
Great. So this is how I have scheduled my today's presentation. I'm going to talk about the semiconductor industry analysis, about where things are globally and how can India and more particularly MP now step in and start contributing to this vast space. Moving on, I will be then talking a little bit about who we are, what we do, different projects that we have undertaken or we are currently part of. Finally, I will try to find or relate an intersection of the healthcare industry with the semiconductor industry. And that is where a lot of these applications where we can transform or translate this academic research into more industry oriented programs or with the potential of commercialization exist. And finally, I will be talking about the challenges and need of the hour, and also something that we are currently undergoing, our own company that is undergoing in the current crisis of this semiconductor shortages. So just a very high level idea about where we are, and I'm not going to be spending too much time on this because I'm sure all of you have been listening to such data sets from last 1.5 days quite enough. So where we are currently, the industry itself globally is about $600 billion worldwide. And it is since almost last 3 or 4 decades, it is growing at a very healthy rate. And if we try to distinguish this into fab and fabless revenue generation across the world, then you can see the graph at the bottom. Both industries are again growing at a very healthy rate. Of course, manufacturing, as Professor Dhruva mentioned, is where India is lacking right now. We have a very good design base, designers and engineers, but what we lack is a manufacturing setup. And that is where a lot of these industries, especially who are the consumers of these ICs, and mind you, specialized IC are really impacted, and almost I would say are held hostage to the manufacturers, the few manufacturers that are there in the globe. It is a completely suppliers market where all the terms and conditions are being set by these manufacturers, and companies like ours, which is a buyer, are forced to play the game by their rules. And that is why I would again emphasize the importance of conclaves like this, which sets the tone in the right direction for setting up a manufacturing base. Just another brief highlight about the current status. If you see the graph on the right, you will easily notice almost, I would say 80% of the demand is being met by just few suppliers. And for free and open competition, I don't think this is very ideal. As Mr. Kunal also showed his talked about his venture into the open source open source of these technologies. I'm sure that will be very helpful in the coming years. The buyers and the sales are mostly driven by China and Asia Pacific, which are the growing market, emerging industries. So even India, now the auto industries and electric vehicles are picking up steam. So the future seems very bright for such a market. Finally, sorry, now I'm going to talk about our company, Pastronics. So just to give you a brief introduction, we have a history of almost 30 years long. The company was founded by Dr. Surendra Kesari. He is a cardiac surgeon based in the United States. He was from Indore actually, and he moved to the US during Vietnam War, where there was great need. Just give me a second. Sorry, my laptop was running out of battery. Yeah, so Dr. Sethi, he moved to the US, and having worked there for many years, he realized that there is a very strong need for advanced medical devices in India. And people, just because of the cost barrier, were not having access to very basic healthcare. So it was his vision to set up a company in India, which would be giving such solutions at a very affordable price point. So it was established in 1988, and it has been almost 33 years through lots of ups and downs, a very exciting journey. And today, I'm very proud to say that even in last 30 years, we are the only active implantable medical devices. And by active, I mean devices which have their own electronic circuit and a battery source inside the device, and it is implanted in a human body for more than 10 or 15 years. We have implanted more than 1 lakh people in India and also in abroad. And when we were not present in the country in the early 90s, the cost of these devices were obviously very, very high. And we are very proud that when we entered the market, the prices of all these foreign manufacturers were brought down almost to meet our rates. And at the end of it, the people of our country were the main benefiters of this domestication. And that is why, again, coming back to today's theme, it is very important that we have our own semiconductor base in India, make in India, make India great. So we have an indigenous R&D. Through 30 years, we have been able to stay at par with what the current status quo and the technology offerings are in the market. We have our own manufacturing unit here in Pithampur, which is not very far from IIT. And finally, we have also helped in complete import substitution. We have saved almost foreign exchange to the tunes of 600 crore as of 2018 for the Indian government through these offerings in the domestic market itself. So a little bit about the device, a little technical, not VLSI technical, but more at the device technicalities of what a pacemaker is. A pacemaker is a device which regulates heart's rhythm. It is implanted inside a human body, and through these electrodes which go into the heart chamber, they provide certain stimulations to the heart, which keeps the heart in rhythm at the rate that is required. Many times at old age, the heart muscle weakens and the pumping function stops. So it primarily does the activity of pacing or giving pulses to the heart, and also sensing whether the heart has any kind of intrinsic activity, so that it need not deliver the extra pulse that is required, thereby saving the life of the battery and therefore extending the life of the device inside the human body. Of course, inside, because being an electronic device, it has its own power source. As you can see in the block diagram on the left, it has got its own actuators and sensors controlled by an electronic circuit. And of course, inside the circuit, there are ICs, and more specifically, the application-specific ICs, commonly known as ASICs, that we got them designed almost, I would say, almost 15 years ago, when our first ASIC-based pacemaker was developed. And at that time, unfortunately, we had to outsource this task of development of these highly specialized ASICs, just because we didn't have any precedent in India any company who had specialized in these kind of ASIC designing. And because it is a highly safety critical device where lives of people depend on it, we decided to choose to do it with people who had some experience in the past. Also, it is a highly optimized ASIC for current drain, because the purpose of the device is to last inside the body for as long as possible. So it is a highly specialized device for low power consumption, of course, safety critical as well. Moving on to some of the other projects, because we had this base of implantable manufacturing devices in India, and since no other company had it and still has it, we have been fortunate to be part of a lot of projects of national importance, especially in the biomedical domain. One such project is that of cochlear implants. Cochlear implants is almost a 15-year project, and it was initiated by our late President, Dr. APJ Abdul Kalam, when he was heading DRDO. So this project actually was initiated by DRDO at that time, and because of our previous experience, we collaborated with them to make this device into fruition. And again, the device used to cost almost 15 to 16 lakh rupees, which was obviously not affordable for almost 90% of the people in India. And this is basically a device meant for enabling a person who lacks the mechanism or hearing mechanism to be substituted with this device. What this device does is it captures a lot of the audio signals from the ambient atmosphere. It digitizes that information and wirelessly transmits it into an implant, which is inside the body. And once those digital signals are sent inside, they are again converted into analog biphasic pulses. And finally, those biphasic pulses through nerves are sent to the brain. And thereby, we are essentially bypassing the auditory system and directly communicating and directly transferring data from the ambient atmosphere to the brain. This is a project first of its kind, bioprocesses in India. And as I said, it used to cost almost 15 lakhs, and it was the vision of late President Dr. Kalam to bring it to a price point under a lakh or 2 lakh rupees at maximum. So again, and I'm very proud to inform that this project currently is under clinical trials and will be hitting the market very soon. And we will be only the fourth company in the whole world who will be manufacturing these devices. Again, these devices are highly specialized, and they make use of application-specific ICs, having a mixed signal or more of analog signal ASICs. Some other projects is that of deep brain stimulator. Now, deep brain stimulator, we recently finished some of the prototypes. And again, you can think of it as a device for the brain or a pacemaker for the brain. And it is meant for people who are having movement disorders or who are having Parkinson's diseases. And essentially, you try to give electrical stimulations directly to the brain in order to offset any kind of movement disorder that you may have. Another one project is that of a cardiac defibrillator. Now, you might have seen in movies some movies in which you give a defibrillation shock and you see that ECG going pip 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 and then going blank, and then you have to give an electrical shock. So what this device is essentially making the entire defibrillator into a form factor which can be implanted inside the human body. So just imagine the complexity of starting out with a 3-volt or a 6-volt battery, using a flyback transformer and raising it to all the way to 900 volt, and then delivering almost 35 joules of energy inside the heart muscle. So this is really one of the engineering marvels, very underrated engineering marvels, I would say. Involves an intersection of a lot of different streams of engineering, be it biomedical, computer software and algorithm, mechanical, and of course, at the heart of it is VLSI or semiconductor. So these were some of the projects that I chose to speak about in today's meeting that we are currently doing. There are a lot of fast-moving items in the IoT healthcare space as well, which is the hot topic these days. And as you can see on the right, the growing demand of these connected healthcare devices, and even the previous speaker mentioned about this, that how silicon is playing an important role in further miniaturizing these devices in a form factor which is much more usable in a cath lab or in a patient healthcare setup. India, unfortunately, has a huge deficit of these medical devices and healthcare infrastructure in India. Almost 80% of these medical devices are imported. And I have to remind you that out of this 80%, 66% of this 80% is the electrical and electronics equipment which is manufactured, which is directly related with the semiconductor infrastructure that we have. Last year, we imported about 15 billion worth of medical devices, and it is expected to grow to almost 40 billion in coming years. And China, again, is pushing itself into the Indian market because of its manufacturing capacity. And unfortunately, due to COVID, these imports from China also increased quite significantly last year. So definitely, COVID has opened our eyes to a lot of things that we took for granted, especially in terms of self-reliance and the self-capacity that we have as a nation. We should not be held hostage to a few companies or few countries in the world who are the sole suppliers, especially when you talk about industries like defense, where we absolutely need our own indigenous capabilities. Talking about medical industry itself, some of the design aspects that we are very particular about is the low power design. For example, our pacemakers, the average current is almost less than 15 microamps. So you can imagine the kind of optimizations that are done both in hardware as well as software. We have low power wireless telemetry going on, again at a very low frequency like that of 400 megahertz or even less, sometimes kilohertz. Advanced frequencies like that of Bluetooth is not a luxury that we can afford given our power budget or power constraints in the device. And one very important aspect is regarding the volumes of volumes of manufacturing. So these devices are not like a microwave oven or like a car where you're pumping out essentially hundreds of millions of units in a year. The volumes are limited. So the challenges that we, particularly our company, faces is because of the low volumes and because of these constraints that are there in the industry these days. Not many fabrication houses are willing to entertain low volumes, and I'm sure all of you have gone through this problem where you're trying to tape out these ICs. But because these are very specialized devices, people go for ASICs when they have large volume productions. We went for ASICs because we had very optimized use case, not volumes. However, because of the lack of manufacturing capacity, we are unable or almost having a difficult time finding the right match with the fabrication houses who are willing to take smaller quantities which are more appropriate for medical devices. Hopefully by end of 2022 or 2023 we'll have a brighter future where all these constraints and bottlenecks would be resolved. So and again, design modifications is also one very aspect where you are always trying to continuously improve your device and stay at par with the market. So without going into a lot of details about the very basics of the VLSI and the analog and the digital design of the ASIC, I chose to keep my presentation giving you an overview of what we do, what our capacities and capabilities are, what challenges we face, and how we are really hopeful this initiative by IIT in Indore and the manufacturing Fab and the Fabless ecosystem in Indore would bring good times for all the companies surrounding IIT. So with that, I would like to thank everyone once again for patiently hearing me. I would like to especially thank Professor Santosh Vishwakarma-ji for inviting me to give this talk. Following is my email ID and my contact number in case you need to get in touch with me. I'll be more than happy to get into more nitty-gritty details about our design and what we do. Thank you. Over to you.
Thank you very much, sir. It was indeed an insightful talk. We have one question in the chat box. This is from Mr. Rishabh Barjatia. He's asking, this pacemaker can send data over any website?
That's a good question. So currently, because of the privacy issues, we keep the communication very limited. Basically, the access to that is limited to the technician or the cardiologist who wishes to communicate the device. Because if you are able to crack into the communication lines of the pacemaker, essentially, you can do very devious things. You can essentially kill a patient if you through program stop the pacing of the device. So actually it is not recommended that such a communication be permitted. And also the international ISO standards for these devices, they strictly prohibit any kind of cloud implementation into these devices. And forget cloud, the limited power budget that we are working with, such high amount of data transfer is not really within the scope of such devices.
Okay, thank you, sir. Also, he's asking if you could share your PPT with the participants, please. If that
Absolutely, just drop me drop in an email on my email ID, and I'll be more than happy to provide all the details.
Thank you very much, sir. So it was a really insightful talk, and it was a different kind of talk with covering the health sector related to VLSI. So it was really informative, and it was exciting to listen to you. Thank you very much, sir. Moving ahead, we are delighted to have with us Dr. Pankaj Sharma. Dr. Pankaj Sharma is presently working as Assistant Professor in the Department of Electronics and Communication Engineering at IIIT DM Jabalpur. Previously, he has also worked as Assistant Professor at IIIT Pune. He obtained his PhD with specialization in nanoelectronics from IIT Indore and MTech in VLSI design from CDAC Noida. He is a senior member of IEEE and life member of Materials Research Society of India. He has been awarded with a visiting scientist fellowship at IISc Bangalore by Indian National Science Academy, Delhi. He has published more than 30 peer-reviewed journal and international conference publications. His research interests include design, modeling, and fabrication of advanced semiconductor material-based nanoelectronic devices. I cordially invite Dr. Pankaj to deliver his talk. Over to you, sir. Sir, I would request you to unmute yourself, please.
Am I audible now?
Yes, sir.
Thank you for such a nice introduction. Since we are already more than half an hour late in the evening, so being the last speaker, it brings on some disadvantages. Nonetheless, I would share my screen.
Sure, sir. So if the volume could be a bit more, actually you're audible, but you could check the volume, please.
Yeah, is it audible now?
Yes, sir. It's better. Thank you.
All right. I hope the slides are visible. So
Yes.
I will not be taking much time, just because in the last 2 days, more senior people from industry and academia have already shared their views on the context of the fabless and fab semiconductor ecosystem in MP. So I'll be just presenting the triple IT perspective in that. So first of all, let me take this opportunity to give an idea about triple ITDM Jabalpur. So in the last 2 decades, India has been going through a rapid growth in manufacturing sector. And to integrate the knowledge of a given discipline in IT, for that matter, whether it is mechanical or it is a material science, there was a need to develop an institute which could deliver an integrated course combining all the different disciplines. So with this idea in mind, Ministry of Education, the erstwhile MHRD, in the year 2000, and Triple ITDM Jabalpur was one of the Triple IT who was established with the support from the government of Japan in order to excel in the areas of research and teaching domain in the manufacturing sector. Now, VLSI and nanoelectronics research activities that are being carried out are led by Professor P.N. Kondekar, which is now the acting director of our institute. The other faculty members of our department includes Dr. D. Prakash Samazdar, Dr. Navjeet Bagga, Dr. Kaushik Datta, Dr. Pushpa Raikwal, and including me. So basically, we carry out fundamental and applied research in the fields of compact modeling and simulation of devices, low power VLSI devices, study and analysis of 2D material for electronic applications. For example, applications like solar photovoltaic cells, charge controller circuits, NCFETs, FinFETs, MOS HEMTs, memristors, and various other devices are being investigated with the help of various simulation tools. So these tools are being provided to us under the SMDB bundle, and few of the tools are being procured under the sponsored research project from DST and all. So Micro and Nanoelectronics Lab is equipped with high-end EDA tools, for example, Cadence, Silvaco, Mentor Graphics, Synopsys, Xilinx, and MATLAB. The above mentioned tools are extensively used for research by our doctorate and master students as well as undergraduate research, and that result in high quality publication. At present, 12 PhDs and 15 master students are doing their research work in the micro nanoelectronics group. So far, 11 PhD students have successfully defended their PhDs, and they are well placed in companies like Intel, Qualcomm, and some are doing postdocs in various reputed universities across the globe. Now, I am leading the Advanced Semiconductor Materials and Nanoelectronics Research Group at IIITM Jabalpur, where we engage in exploring the novel semiconductor materials for various optoelectronic application. For example, we investigate different structures for transistors involving new materials. For example, gallium oxide, zinc oxide. Similarly, for solar cell, we are investigating nitride materials and perovskite materials. At present, we have 2 PhD students in my group, Akash and Sachidanand. In addition, we have Roshan and Pratiti who are pursuing their masters. And fortunately, yesterday itself, Pratiti has got an offer from Samsung Design. The basic approach which we follow is since we are we can say we are a very young institute in terms of resources. We do not have any such fabrication facility at our institute, but nonetheless, we are working with the help of simulation tool by modeling of devices. And then we go for fabrication and optimization of different growth parameters or for the material of these devices through various collaborations. Recently, we have got funding from DST for investigating new electrolytes for fuel cell. That is again an emerging domain where Government of India has fixed 80,000 crore in last year's budget. Now, just quickly summarizing points which various eminent speakers during this conclave has discussed. starting from when we talk about having clusters in MP. So first of all, we need to understand the semiconductor scenario. How are these being, what are the factors that are governing the semiconductor industry? For example, as various people have said, funds are a big problem. The availability of funds at academic level really poses hindrance for the development of Indian semiconductor industry. Although various reputed institutes in India as well as in MP region, for example, IIT Indore, IIIT Jabalpur, IIIT Gwalior, and various other research universities, they are producing a highly qualified manpower in the domain of simulation and modeling. But I'm afraid that none of the or I can say very few people or very few students who come out of their masters and doctorate degrees, they don't have any experience on the experimental setup. So basically, what do we need? We need to have a setup where we can develop the skills, the skills apart from the simulation and modeling. Although we have a very big pool of experienced designers, okay, we have a very well no coached students who can design various complex circuits. But the problem is we do not have highly qualified manpower to lead these industries in the fabrication domain. So what do we need? So we basically need to have experimental hands-on training for the master students, and then integration of both kind of, see, we can say these are the two ends of a river. One person who knows simulation and modeling doesn't know anything about fabrication, and another person who has got some experience in experimental domain doesn't work much in simulation. So we need to integrate these two uh, approaches for the overall development of the semiconductor industry. Again, once we develop the manpower, we need to ensure that what are the opportunities available for the manpower, because just producing MTech and PhDs at institutes like IIT, IIIT or state universities will not serve the purpose. We need to ensure that they get good job opportunities. In that matter, we need to collaborate with industries. We need to ensure that they get good jobs within the MP state. In that matter, again, the collaboration.
Dr. Pankaj, we're not able to see your video and hear you. Could you please check internet connection if you are able to hear me? Dr. Pankaj, if you're there in the meeting, could you please type in the chat box? Everyone, let's wait for a couple of minutes. Let's see if Dr. Pankaj joins back as we, or else we move ahead with the session. Dr. Pankaj, are you able to hear me now? Dr. Pankaj, please try to unmute yourself, or else please type in the chat box if there are any issues. Dr. Pankaj, are you able to hear me? Or else, sir, could you please rejoin once? Okay, sir. Sir, I'm not able to hear you. Could you please check the internet connection at your end? Sir, I think you're already a panelist. I think you can unmute yourself. Please try once.
Hello. Yeah, am I audible?
Yes, sir.
Hello.
Yes, sir, you are audible.
I'm really sorry for the. I'm really sorry for the technical glitch. There was some internet connectivity issue. I will just quickly share and conclude.
Sure, sir.
Yeah. So is my slide visible? So I think I was on the skill development point when I left.
Sir, I'm not. We're not.
So in my viewpoint, when I would like to summarize what the challenges are being posed to, so the challenges that are being posed towards the semiconductor industry and semiconductor. Hello, am I audible?
Yes, sir. Although your voice is breaking, but you're audible.
Hello.
Yes, sir. You're audible.
Am I audible?
Yes, sir.
Am I audible? Yeah, I think there is some network challenges that are being faced. Quality of goods in MTech credit system program. However, we are unable to ensure good power available with us. Design really good complex. Look at the silicon 40% belong Indian in India. So there we say that we are producing manpower, but where are we lacking? We are actually lacking in the terms of manufacturing, and there is that is the scene wherein triple ITDM no suitable solution for that. We can good interconnect between industries and academia, and we can develop policies regarding the manufacturing of semiconductor devices, chips, and display devices. So as I said in the just few minutes back, I was discussing about the two ends of the of a curriculum structure. We are having highly qualified VLSI design engineers. We are having very highly qualified verification engineers, but we are not having very qualified experimental engineers who can really work on developing the chips, or who can really work on taking their designs up to the level of tape out. Okay, as Kunal rightly said, that in India, more than 20% students who do their masters and VLS and PhD in nanoelectronics are not able to take their designs of fabrication level. So we need a barrier. So there, we need to work on the opportunities that are available for the students, because being a faculty members, I always think about the future of the students who are coming out of the schools, who are coming up the engineering colleges. At the last, the most important point is collaboration between various topics, Indore, IIT, Java. Yeah, I would like to conclude here. And if you have any questions, anybody has any questions, please you can ask. Thank you.
Thank you, sir. Any questions from the audience end?
Although it was the last session of the 2 days conclave, so I couldn't get much chance, and because most of the points were already covered by eminent speakers before me. So thank you for giving me this opportunity. Thanks once again.
Thank you very much, sir. It was really an interesting session. Moving ahead, I would like to invite Dr. Uday Pawar for the next invited talk. Dr. Uday Pawar graduated in Electronics and Communication Engineering from RGPV Bhopal in 2000. In 2009, he received ME in Digital Communication from IIT DAVV Indore. And in 2015, he received his PhD degree from Manit Bhopal in the area of low power VLSI design. He has more than 9 years of experience, currently working as a professor with the Department of Electronics and Communication Engineering, SIRT Bhopal, and has been granted 5 national patents and 1 international patent. He has published more than 25 research articles in various SCI Scopus and other peer-reviewed journals. He is also the reviewer of various SCI index journals like Taylor and Francis, IJE, Ville, IJNM, IJCC, and many more. I cordially invite Dr. Uday to deliver his talk. Over to you, sir.
Thank you so much, ma'am, for the nice introduction.
Welcome, sir.
My slide is visible, ma'am?
Yes, sir.
So thank you so much, Madhya Pradesh Vigyan Sammelan 2021 and IIT Indore and all the coordinators for inviting me. And I'm very happy to present our institute in this prestigious Sammelan and Expo. I'm not taking much time, ma'am. I'm just taking 5 to 10 minutes for
Sure, sir. Sure.
introducing my institute only here. So let's start. This is just for the motivation. We are now we are now surrounding the semiconductor devices everywhere in our daily life. And this is the graph represents the IoT connected smart devices. So this actually tells how we are connecting and what percentage of utilization in our daily life of the smart devices. And this statistics basically represents the number of mobile phone user in India. So currently we are at approximately 760 millions in numbers, and it is exponentially increases day by day. So now we start with our institute. We are working. I'm working with SIRT Group, Sagar Institute of Research and Technology, which is situated in Bhopal, Madhya Pradesh. Is the center of India, and approximately 20-acre space is taking, and we have 5 institute in the premises of SIRT or SAGE Group, which is SIRTE, SIRTAS, SIRTS Pharmacy, and 1 more pharmacy institute we have. And we have the ISO certification 9000 2001 in 2003 and NB accredited institute in 2009, 14, 16 and 18. So it is also accredited by the TCS in 2010 for closed campus placement. These are the glimpses of our facility. We have a first sports complex which provide the national level sports activity in our in-house campus, and all the labs. These are the courses which is running through the institution: computer science, AI and machine learning, cyber security, CS and IT branch, electronics and communication, mechanical, civil and electrical and electronics. We have some MTech program also.
in computer science engineering, digital communication, microelectronics and VLSI design, thermal engineering, and MCA and MBA courses also. So these are some national and international MOU tie-ups, which helps to enhance the students' skills and knowledge and their job also. Recently, we have our students from civil branch joined Lions Group after signing this MOU, and they got the offer letter. And one Joist is the entrepreneurship development Greek cell, in which we exchange our startup and innovation things with the Joist. So these are the MOUs. Now we go to the R&D activity. So we are working on these two projects currently, which is based on design and development of cost-effective motorized ladder funded by the MPCST, and design and development of polymer composites for microelectronic application, which is funded by the SERB. And we also participated in the consultancy part. Our one department consultancy is done with the DK Electro Mac Corporation, Govindpura Industrial Area, where we planted one controlling device which control the their temperature at some coil. In IPR activity, we have more than 70 plus IPR granted. Where I'm just sharing two snapshot of design patents. One which garbage collector, and another is for text to voice to text converter. This particular patent is done by our faculty members and students. So such kind of various patent and copyright activities is continuously going on. And we also having entrepreneurship development cell activities, in which we also associate with the E-Cell, IIT Kharagpur, Atmanirbhar Madhya Pradesh, and some other organization. We can in lockdown 2020 we conducted more than 50 such activity, national and international level. So these are some creatives in which we worked. One of the in this second 3-day national webinar, Incredible Journey of Entrepreneurs, we have various alumni of IIT. One is from IIT Indore. So Mr. Sandeep Bomi Reddy, you know, I think. And one prestigious event, Entrepreneurship Awareness Drive, associate with the E-Cell IIT Kharagpur, and International Science Festival in 2020 with the Vigyan Bharati. So such we also organized the internal hackathon in 2020 at our premises. So it is the fourth time where we conducted the hackathon. And we also having one cell, that is Institute Innovation Council. Recently, we got 4-star rating from the Ministry of Education, India. So where we also conducted various event, which is given by the MHRD calendar in every quarter. So these are the glimpses. And we must share our student achievements here. So our one student team won the first prize in national level project competition Anvesha 2021 in NCR, New Delhi. In hackathon, our one team also got the second runner-up at IIT BHU in 2018. And two students started their own startup and got the funding of 30 lakhs and 20 lakhs respectively from the government of Madhya Pradesh. And recently we start one Modrob, this IoT lab under the Modrob scheme, which is given in this display. So in this particular E-Cell, IIC cell, and such labs, we are try to give betterment on skill knowledge to our students. So this is all my side, ma'am.
Thank you very much. That was indeed an insightful. That was indeed an. Okay, sir. Am I audible to you?
Hello. Yes, ma'am.
Okay. Okay. Thank you very much, sir.
Thank you so much, ma'am, and thank you so much to Santosh sir who inviting me and giving me this opportunity, ma'am.
Thank you very much, sir.
Thank you so much.
Thank you for sparing your time for joining this conclave. Now, at the last, I, Vasundhara Trivedi from NSDCS Lab IIT Indore, take the opportunity to propose a vote of thanks on the behalf of MPVS and IIT Indore. I am grateful to all the esteemed speakers for sharing some really valuable insights in this conclave. A big thanks to all the participants and the online attendees for joining us on this conclave. It was indeed a pleasure hosting you all alongside my colleague, Ms. Sumiran Mehra. I would like to thank the coordinators, Dr. Santosh Kumar Vishwakarma, Dr. Ajay Kumar Kushwaha, Dr. Mukesh Kumar, and Dr. Shaibal Mukherjee for giving us this wonderful opportunity. I thank all the student coordinators from NSDCS Lab IIT Indore. I thank each and everyone who has in any way contributed to the success of the conclave. It was great to see so much enthusiasm from the audience. I hope everyone would have learned a lot from these sessions. Thank you.